Hello all, I hope you are doing good. I'm Vaibhav Lakhani, a security researcher from India. I've been into this field of cybersecurity from past 3 years, wherein I have helped organizations protect their infrastructure. I have been rewarded Hall of Fames, swags, and bounties from various organizations such as Dutch Telecom, United Nations, and other private programs. I have been acknowledged as top 15 hackers by NCIIPC as well. I wish you a warm welcome to this course. We all are aware of web application penetration testing and network penetration testing. However, only some of us know about mobile application testing, especially iOS testing. So here I am to cover this particular branch of mobile testing for you. This course includes all the basic details that is required for iOS testing. It also covers all the attacks with practical examples so that you can experience the attacks in real time. For the prerequisites, all you require is an iOS device. Make sure this particular device is not your primary device. You can have an iOS simulator as well. The other things which you require are a strong internet connection and willingness to learn. And this course, firstly, will start with setting up your hacking environment, wherein we'll be setting up mobile hacking operating system. We'll then move on to jailbreak and types of jailbreak, and we'll move on to jailbreaking your iOS device. The next module covers some iOS related commands, which are going to be very handy while performing iOS pen testing. We'll then move on to the basics of iOS, wherein I'll teach you about data protection, keychain, and other search terminologies. We'll then start with OWASP, that is the Bible of application security. We'll look at OWASP Mobile Top 10, the two versions of OWASP Mobile Top 10, that is 2014 and 2016. We would be differentiating between these versions as well. We'll be looking at each of the OWASP Top 10 category, all from M1 till M10 with practical examples. The next section onwards will start with the actual penetration testing of the iOS applications. We'll start with static analysis, wherein we'll learn how to find static vulnerabilities both in manual and automated way. The static analysis covers testing of the applications without actually playing with the application functionality. I'll also introduce you to some of the tools that are mostly used in the industry. In the dynamic analysis section, we'll be playing with the application functionality and breaking them in order to find vulnerabilities. We'll be looking at bypassing jailbreak detection, SSL pinning detection, and bypassing local authentication methods. Section 8 covers live attacks, wherein I would be demonstrating certain vulnerabilities on a public bug bounty program. Please note that all the vulnerabilities have been reported to the program owner under their responsible disclosure program. The vulnerabilities should not be exploited by any of the viewer. The author holds no responsibility if any illegal practice is accounted. And the tips and the tricks section, I will be sharing with you certain techniques that would make you better than the rest. This section also includes penetration testing reports, private nuclei templates, etc. Here, we will also walk through with certain reports that other hackers have reported. So this is the overall course content. If you have any doubts, feel free to ask in the Q&A section, and I'll make sure to answer them as soon as possible. Thank you.
Hello everyone, welcome to the module 2 of this course. In this module, we are going to learn how you can set up your environment in order to pen test iOS applications. Let's set up the environment one by one. Let's first set up the ultimate operating system, Mobixler. Mobixler is one of the best operating systems which is used to hack mobile applications. It is specially created by the hackers in order to just pen test mobile applications, be it Android applications or iOS applications. The best part of Mobixler is that it's completely open source and it's built on top of Linux. You can download Mobixler easily for free by visiting this website called as mobixler.com. So it's demo time and let's learn how you can install Mobixler. In order to install Mobixler, you have to first visit this website. You have to click on the download button. Over here, you would be able to see there's a button called as download using Google Drive link. If you want, you can provide your email address. If not, you can just click on that purple button and you would be redirected to a website wherein you can download the MobExplorer OVA file. The MobExplorer OVA file is of 12 GB, so it's going to take some time for you to download. Once downloaded, you can install the MobExplorer OVA file into your VirtualBox machines. So let's wait until the MobExplorer OVA file gets downloaded, and then I'll show you how you can proceed towards the installation part. Hello all, welcome back to this video. So in this video, as you can see that I have switched over to my Windows machine and I have already downloaded the MobExplorer OVA file. So let me show you how you can install this OVA file into your virtual appliance. You can either use VMware Workstation Player or you can use VirtualBox. Either of the two, the MobExplorer OVA file is perfectly going to work with them. So over here, I'm going to demonstrate how you can install MobExplorer inside VMware Workstation Player. So over here, my VMware Workstation Player has been opened. All I have to do is go on to Player, go on to File and click on Open. Once I click on Open, I have to select the OVA file. The OVA file is in the Downloads folder. Once selected, I'll be seeing a agreement which has been provided by VMware Workstation. I have to accept the terms and the conditions. Click on Next. I have to provide the name for the VMware virtual machine. I'm going to provide the name as MobExplorer, and you can select the storage path as well. If you want, you can give any other storage path you want to. I'm just going to go with the default ones and click on Import. Once you click on Import, VMware Workstation Player is going to start importing MobExplorer. For the very first time, it's going to show you an error. Don't worry at all. This error is just a regular check which VMware Workstation Player does. All you have to do is click on retry. Once you click on retry, it's going to start importing. Now it's going to start importing the OVA file. It's going to take a couple of minutes for importing. So meanwhile, what I'll do is I'll just fast forward this for you so that you do not have to wait. So I've fast forwarded it and now you can see that it has been imported. You can see the virtual machine name is MobExplorer. The operating system it is built on is Ubuntu. As I already said that MobExplorer has been built upon Linux distribution, that is Ubuntu. The RAM allocated for this by default is 2 GB of RAM. You can change this. In order to change this, you have to click on Edit Virtual Machine Settings. Over there, you can see memory. Memory, you can select the RAM, whatever you want to. I'm going to provide it up till 8 GB of RAM. Make sure that you do not provide more than 4 GB or 8 GB depending on your computer specification. Do not provide more than 50% of the total RAM which you have inside your system. If you provide more than 50%, your Windows machine will start lagging. Okay, so do not provide more than 50%. I have a 16 GB configuration, so that's the reason I'm going to provide 8 GB. More the RAM, more smoother your virtual machine is going to be. So I'm just going to provide 8 GB of RAM and click on OK. Once I click on OK, I'm going to start to play this virtual machine. So my virtual machine is going to start. It's going to take some time since it's the first boot up of the machine. So it's going to take some time. What I'll do is I'll again fast forward this so that you do not have to wait. You can see over here that it's built on Ubuntu 18.0.4, and once your virtual machine gets started up, it's going to look something like this. By default, the username over there would be present as MobExplorer. The default password for it is going to be 12345. Okay, it's 12345 all in numbers. If you put the default password 12345, this would be the desktop which you would be viewing. Okay, now let me just take you a walkthrough to the MobExplorer operating system. What tools does it include and everything. So over here at the bottom you can see there's a start menu. Inside the start menu we have certain options. We have the favorite section. Inside the favorite section you can see that Terminal emulator has been installed, Android Studio has been installed, Burp Suite. We all know that Burp Suite is a tool which is used to capture the requests and the response and play with them. it is already installed. Obviously, the community version is installed for it. MobSF is an automated tool. We are going to learn more about MobSF in the upcoming sections. Okay, you have JDEX. JDEX is an APK static analyzer, which is used for Android pen testing and Android analysis. You have Hydra, which is a reverse engineering tool. You have Grapefruit. Grapefruit is one of the best iOS instruments. We are going to learn about Grapefruit as well. And you have runtime mobile security application as well. Okay, so these are some of the default applications. Inside the Android zone, you can see that there are different types of Android applications which are available over here. You can see Android CLI, Android Studio, DB browser for SQLite, Frida, JDEX, JDGUI, Mara framework, MobSF, etc. So these are all the different Android related tools. Since we are inside iOS pen testing, let's quickly have a look inside the iOS zone as well. So inside the iOS zone, you can see that we have Bobsuit, which has been installed. We have Cydia Impactor. We have FileZilla. FileZilla is an FTP client which is used to, extract IPA files or extract any documents from the iOS device. You have Grapefruit, which is an instrument for iOS. You have MobSF, Objection, Putty. Putty is again SSH server. Using Putty, you can connect to your devices as well. And then you have IB Lessing, which is an iOS security exploit toolkit. Okay, so these are some of the different tools which comes pre-installed. You have another zone called as the security zone, wherein you have Mobsuit, Root Terminal, SQL Map, Terminal Emulator, Wireshark. So these tools again will are going to help you inside your Android and iOS pen testing as well. And then finally you have the internet section, wherein you have all the different types of web browsers available. You have Mozilla Firefox and Chrome as well. Over here you can see I have opened the terminal, and just to show you that which user I'm working with, I'm currently by default working with the root user. So MobXler also has this functionality that it gives you the root user directly, the super user mode directly. So that's it guys. In the next video, we are going to learn how you can install your custom Mac OS inside any Windows machine. So if you are someone who does not have an Apple MacBook or a Mac OS, do not worry, I've got you covered. I'll be showing you in the next video that how you can install Mac OS inside your virtual appliance. Thank you. Hello all, welcome back. In this video, I'm going to show you how you can install Mac OS on Windows machine. So even if you don't own a Mac machine, do not worry, you'll be able to run all the commands that we are going to perform in the further sections. So in order to install Mac OS on Windows machine, you first have to download the required files. The link to all of them would be given in the description section. You have to install VMware. You have to create and configure Mac virtual machine, and then you have to start the virtual machine and install the Mac OS. So it's the practical time, it's the demo time, and let's check out how you can install the Mac machine onto your Windows system. So here I have gone onto my Windows machine, and over here I'm first going to download VMware. You can download VMware from vmware.com and you can download it. Then you have to install the second file, that is the Mac OS ISO file. The link for this would be given in the description section. Simply go on to this particular link and click on the download button. It's going to take some time for to download because it's around 15 GB of file. So it's going to take 30-40 minutes depending on your internet speed. Thirdly, you have to download the auto updater or auto unlocker. What is auto unlocker? This is basically a tool that is going to unlock your VMware for you to download Mac OS. Please note that by default, VMware does not support Mac virtual machines. In order to download Mac virtual machines, you first have to perform this step. Do not worry, I've covered how you can perform this step in this particular tutorial. So you can download this, you can go at the bottom and inside the assets section, you would be able to see there's a zip file. You can download this particular zip file. Now I have all the three things ready with me. I have VMware installed with me. So what I'm going to do is before I start the VMware, I'm first going to go inside the unlocker. and I'm going to unlock my VMware machine. So in order to do that, you have to go inside the zip file and click on this executable file. Over here, you would be seeing a button called as patch. You need to click on this particular button of patch. My VMware has already been patched up, so it's showing me an error, but for you, it won't be patched. So you have to click on that particular button, and after around 10 to 12 minutes, your VMware would be patched again. Make sure that your VMware is closed while auto unlocker is patching it up. So once this is done, you can close your VMware. Oh, sorry, you can close your zip file and you can open your VMware workstation. Once you open your VMware workstation, you can click on create a new virtual machine. Once you click that, you can click on installer disk image file and you have to give the ISO file which you have downloaded. That 15 GB of file, you have to give the location of it. You have to click on next and you can see this Mac OS X that is selected by default. You have to click on it and give the version as Mac OS 13 because we are currently installing macOS Ventura, that is macOS 13 version. So please give it as macOS 13. Click on next. Once you click on next, you can specify the virtual machine name and you can specify the location. And then you can specify the maximum size of disk that you want to allocate. For me, I'm going to allocate 80 GB of file size. You can allocate whatever you like. You can click on next, and then these are the final set of description that is created for you. Click on finish, and once you click on finish, your Mac OS VMware would be created. For me, it's already been created before, so I'm going to click cancel. Now just select it and click on power on, and your Mac machine would be turning it on. Now turning the Mac machine on for the first time might take some time. This loading bar might take some time, around 5 to 7 minutes. But do not worry, I'm going to fast forward this particular section so that it's easy for you. So yes, once the VMware has been recorded over here, you would be able to see a recovery option, and there are four options that are present inside this. You can select any one of the option. The first one which you have to select is the disk utility. You can click on disk utility and click on continue. Once you click on continue, you have to select the VMware virtual SATA hard drive media and click on erase. Now, why are we doing this? We are doing this so that we create a hard disk, a virtual hard disk for a virtual VMware machine. You can give any name you want and click on erase. Once you click on erase, the virtual hard drive is going to reset and we will be able to install macOS 13 in it. Click on disk utility and quit the disk utility. And now click on install macOS 13 beta. Click continue. Once you click continue, you have to again continue with the setup of the installation of macOS 13 beta. Again, click continue. Now you have to read and agree these terms and conditions. So I'm going to click on agree. I'm going to select the Mac disk, which I want to install my Mac OS inside in it, and I'm going to click on continue. Now this process is going to take around 30 to 45 minutes. So hold back and let the process get continued, and finally after 30 to 45 minutes, or it might take up till 1 hour depending on your computer speed. After that, you would be displaying such a screen wherein you have to select your country or region. So we are going to select our country, that is India, and once we select the country, we are going to click continue. Once we click on continue, there are this particular screen that gets displayed wherein written and spoken languages selection is available. So we do not want to make any changes. So we are going to click on continue. These are all personalized things. If you want to make some changes, you are free to do so. You can connect to the internet if you want to. If not, you can just select the my computer does not connect to the internet option and click on continue. Well, I do not want my computer to get connected to the internet right now. So I'm not going to select the local network option. If you're going to select the local network option, there's a high chance that your Mac will start downloading updates and it might take some more time in order to in order to install the Mac OS. And yeah, so this is the data and privacy screen. This is the migration assistant. If you want to migrate your data from one PC to another, you can migrate it. If not, you can click on not now and proceed to the next screen. In the next screen, again, you would be having certain terms and conditions. You need to agree those conditions. And now you can create your computer account. You can write your full name over here, your account name, your password, and the account hint. So once this is done, this is all personal level changes. You're free to modify whatever changes you want to give. You can give it up and then go to the next screen. Once you go to the next screen, Mac is going to ask you if you want to enable location services or not. I do not want my Mac to use location services, so I'm not going to allow it. I'm going to click on don't use, and then you can select your time zone. So you're going to select our time zone as India. So it's India, New Delhi, and let's click on continue. Analytics, if you want to give analytics, you can give. If not, you can deny it. If you want to set up screen time, you can set up screen time. If not, you can set it up later on as well. And if you want a dark theme, you can give a dark theme. If you want a light theme, you can give a light theme. These things can be changed in the system settings later on as well. So we are going to use the light theme by default, and let's move on. Now, for the very first time, when your Mac OS machine gets started up, it's going to take some time to get loaded because all of the services are jumping up one by one. If you want your Mac speed to get increased, you can increase the RAM as well. You can right click inside your VM and increase the RAM. Please note that your VM's RAM and your Windows RAM should be exactly half or less than half. If you give your VM's RAM more than half, so let's say if your computer system, the entire computer system has 16 GB of RAM, and if you allocate 12 GB of RAM to your VM, your Windows is going to lag, and that's going to cause an issue. So please note that if you are giving or increasing the RAM of your Mac machine, do not give it, do not give more than 50%. So now, as you can see, our Mac machine has been set it up very perfectly. I'm going to go inside the system settings. Yes, it might take some while for the system settings to load, but do not worry. You can increase the RAM and then your Mac machine would be more smoother. So yes, as you can see, system settings has been shown up, and that's it for this particular video. I hope you understood how you can install Mac OS onto your Windows machine as a virtual machine. Thank you. Hello everyone. In this video, we are going to learn about simulators. A simulator is an application that mimics an iOS device. It creates an environment that replicates the configurations and behavior of a real device. Obviously, a simulator is not a real device, and hence you cannot interact with the hardware level properties of an iOS device. Hardware level properties includes Face ID and Touch ID. Here listed are some of the very popular iOS simulators. These include Appetize.io, one of the best iOS simulator, iPadian, and SmartFace. So it's a demo time and let's have a look at Appetize.io. In order to have a look at Appetize.io, you first have to visit this particular website, which is called as Appetize. Appetize.io runs mobile applications and browser-based simulators. Over here, you can try their demo for free. So we are just going to do that. We are going to click on try online demo. You might be facing a account level queue, which you might have to wait in order to try their demo up. What I'll do is I'll simply fast forward it. And over here, I'm going to fast forward it. And as you can see, my simulator has been enabled. Now, as you can see, I can interact with the home button. I can work exactly as a normal iOS device. If you go inside the settings, you would be able to see all the different level settings over here are present. And this is how exactly simulators work. Thank you. Hello everyone. In this video, we are going to look at emulators. I'm sure that you might have watched my previous video wherein I explained about simulators. Emulators are again as similar as simulators with a slight differentiation between them. So iOS app emulators are programs that replicate the hardware of an iPhone so you can run iOS applications on those operating systems. Emulators duplicate the software and the hardware features of the real device. This is a small differentiation between the simulators and emulators. Simulators only duplicate the software features of the real device, while emulators duplicate the software and the hardware features of the real device. One of a popular iOS emulator is Corellium. So let's have a demo of the Corellium. So in order to view Corellium, you have to visit this website called as corellium.com, and you can request a free trial or you can view the pricing as well. uh, since this is a request-based free trial, we won't be seeing it. We will just be seeing the screenshots of it. And as you can see that this is a real-time hardware and software level iOS device which is over here. You can connect that device to your Mac account or to your Linux account as well. You can set VPNs on it, and there are various other features which you can check out for. So this is all about emulators. In the next section, we are going to learn about what exactly is jailbreaking. Thank you. Hello all, welcome back to this course. In the last video, we learned about simulators and emulators. In this video, we are going to learn about jailbreaking, the different types of jailbreaking, how you can jailbreak an iOS device, and then I will be demonstrating of how and what actually are the steps in order to jailbreak an iOS device. So let's start. Jailbreaking. Jailbreaking is a use of privilege escalation exploit to remove software restrictions imposed by the manufacturer. It is done through a series of kernel patches. What jailbreaking actually does is it provides you the root access of the operating system. So let's say in iOS, you have the iOS operating system, and without jailbreaking, you're not going to get the root access of the system. And once you get the root access of the system, you can perform any actions as a super user. In order to get this root access, you require to jailbreak an iOS device. Now, there are various types of jailbreaking. In total, there are four types of jailbreaking. The first one is untethered jailbreak. An untethered jailbreak, the kernel is patched without the help of the computer or an application. It is a very uncommon technique. So what happens in untethered jailbreak is that your jailbreak or your device gets jailbreak without the help of a computer or without the help of any third party application. This is a very rare and uncommon technique. Yes, there are certain jailbreaks which uses untethered way of jailbreaking, but again, this is very rare in such cases. Okay. The second one is the tethered jailbreak. Now, tethered jailbreak is exactly the opposite of untethered jailbreak. Tethered jailbreak requires a computer device or an application in order to patch the kernel. Okay. Without the computer or without a third party application, your iOS device won't be able to boot. That's what we call as tethered jailbreak. The third type is semi-tethered jailbreak. Semi-tethered jailbreak basically means that once your device is restarted, it can go into its normal mode, that is the non-jailbroken mode. Okay, so your device can restart without the help of computer to go into the normal mode. However, it requires computer to patch the kernel or for jailbreak. The last type is semi-untethered jailbreak. In semi-untethered jailbreak, the device can be restarted normally without the patch kernel, and you do not require any computer or any application to patch the kernel or to perform a jailbreak. So these are the four types. Very quickly, untethered jailbreak, you do not require a computer or application. It's a very uncommon technique. Tethered jailbreak, you require a application or a computer in order to patch the kernel or to perform the jailbreak or to get the root access. Third, semi-tethered. Semi-tethered basically means that your device can be rebooted without the help of computer. However, you require a computer or an application to patch the kernel or to get the jailbreak mode. Fourth is semi-untethered, wherein your device can run normally without the patch kernel. It can be restarted normally without the patch kernel. And to patch the kernel, you do not require a computer. So these are the four types of jailbreak. Now let's understand how actually you can perform a jailbreaking of an iOS device. So it's the demo time. So first of all, you have to identify which iOS version you are currently onto. Okay, so my device is currently running iOS 15.7.1. All I have to do is simply go onto Google. Onto Google, I'm just going to check for iOS 15.7.1 jailbreak. Once I enter this, the first website which I'm going to find is of pangu8.com. Now, let me tell you, pangu8.com is a very, very brilliant website. Okay, and it has all the methods listed of different types of jailbreaks which are available. Okay, so for example, let's say iOS 16.3 has come up. Pangu 8 will list down all the available methods of jailbreak for iOS 16.3. Okay, for iOS 16.2, for iOS 16.1, and so on and so forth. Now, there are two methods of jailbreaking. Okay, so first one, you can just visit Pangu 8 website and you can check out which jailbreak method is available. Secondly, there's a tool called as 3U tools. We are going to learn about this tool in detail in the upcoming sections, but just to give you a brief, 3U tools is basically an automated jailbreak script. Okay, it's a toolkit for iOS testing and iOS actions. Okay, so there's an option of jailbreaking. All you have to do is go on to 3U tools and install uh, okay, all you have to do is go on to 3U tools and you have to install 3U tools, click on jailbreak, and there will be available methods of jailbreaking. So you can perform any one you want. We are going to go on to Pangu 8 and we are going to check one by one all the available methods which are listed for iOS 15.7.1. Okay, so you can see Xeon. We have the first method, which is Xeon. It says that Xeon is the best and the most popular jailbreak solution for iOS 15. However, Xeon is a virtual jailbreak. Now, what's the difference between an actual jailbreak and a virtual jailbreak? Virtual jailbreaks are solutions uh, that is going to give you a fake or a virtual third-party application such as CDR. Okay, it's not the actual or the real patched kernel, but it's just a virtual kernel. Virtual kernel. It's similar like you are running a virtual container, okay, wherein you do not actually have the resources, but you can play with those resources. So it's a virtual jailbreak. There are other jailbreaks which are available. Now, the one which we are going to talk about is the Palarin jailbreak. Okay, so for iOS 15.7.1 up till iOS 16.3, Palarin jailbreak is considered to be one of the best jailbreaks. Okay, and this uses checkm exploit, an exploit which was found in the hardware of iOS devices, and it's not yet resolved. Okay, up till iPhone 10 it has not been resolved. We are going to look at a detailed section of how you can use Palarin jailbreak in a couple of minutes. Okay, so let me show you Palarin jailbreak. We have Xena, we have Uncover Virtual. Again, these are just virtual jailbreaks. Shiote Virtual, Checkrange Virtual. These are different types of virtual jailbreaks which are available. The one which we are going to talk about is the Palarin jailbreak. So let's get started. Okay, so welcome back to this video. And now it's the demo time and let's check out how you can jailbreak an iOS device. So over here, you can see that my iOS device is connected. I'm simply going to go on to the about section. And over here, you can see that my software version, which I'm using is 15.7.2. You can see that this is my iPhone name and it's 15.7.2. And I'm going to go on to the Palarin official GitHub repo, which is an ideal jailbreak for this version of 15.7.2. So over here, I'm going to go on to the official GitHub repo, and I'm simply going to go on to my terminal, and I'm going to go inside the Palerin repository. Okay, you can download the Palerin repository by using a simple command as git clone. The same command has been mentioned over here at the bottom. Okay, there's a tutorial which you can find over here, and you can simply clone the repo using this particular command, which is git clone dash dash recursive dash dash depth equals to 1 and the GitHub repo. Once you are inside the repo, all you have to do is use this very simple command called as dot slash pelerin.sh dash dash tweaks. After you perform tweaks, you have to give your iOS version. Okay, so we are running on 15.7.2. We are going to mention 15.7.2. Okay, and I'm going to mention the, okay, so it's 15.7.2. And I'm going to mention a flag called a semi-tethered. Now, why am I mentioning this particular flag? Is because I want my device to restart normally, even if it gets switched off. Okay, so I do not want my device to be dependent on a computer or a third-party application while restarting, and it should restart normally. Okay, okay, there's an issue with the command. We forgot a dot, so we are going to rectify it. And once we hit enter, it's going to install certain tools. Okay, so for example, Gaster is not installed. We have to press any key to install it. And now you can see that my device has been switched to the recovery mode. Okay, so once you see that my device has been switched to the recovery mode, it's now waiting for my device to get into the DFU mode. Now there are certain things which you have to understand or which you have to perform before you launch this particular command. First and foremost is that your device should be connected with a USB Type A adapter. Okay, your device should be connected with a USB Type A adapter. Secondly, this command will only work in Linux systems or Mac OS system. Again, if you're using a Linux system, please make sure that your Linux computer is not running on a virtual machine. Your computer should be having a separate Linux or dual booted Linux with Windows. You cannot run these commands on a virtual Linux machine. Okay, so you have to make sure about that as well. Thirdly, check out which iOS version you are currently running for. If you are running 15.7.0 and above, then and only then this Palerin jailbreak is going to work for you, or else it's not going to work for you. And finally, once all of these three steps have been performed, we can run the particular Paladin command, and it's going to tell you to press enter whenever you're ready for the DFU mode. Now, what is DFU mode? DFU mode is a mode wherein all of your functional units are going to work. Okay, it's a data recovery mode. It's a mode wherein your device gets restored, and it's a mode wherein your kernel is going to get patched. Okay, so we are going to run inside the DFU mode. Now, how do you perform a DFU mode? All the steps would be given over here. Please make sure that you perform it very religiously. Okay, even a slightest mistake will directly throw you out into the recovery mode. Okay, so you have to hold the volume down button and side button for 5 to 6 seconds. After doing that, you have to release the side button, and you have to keep pressing the volume down button for the rest 10 to 11 seconds. Once that is done, once it is perfect, you would be seeing something called as device entered DFU mode. And now you just have to sit back and relax, and the kernel is going to get patched automatically. Okay, so it's going to download certain repositories, it's going to patch certain kernels. We are not going much into details of how this particular exploit is going to work, but it's going to patch the kernel for you. Okay, so let's wait a moment and let this entire process be running. Okay, guys. Meanwhile, this process is running. I just want you to inform that all the steps for running this jailbreak, I will be writing it down inside a document format so that it is easy for you guys to refer. And I would be putting it inside the notes section so you can download it from there. Okay, so these are certain steps which is happening. Let's wait a moment until all of these steps gets completed. Okay, so it's going to take some time for this. And okay, so let's wait a moment, and after the entire process is completed, I'll be showing you the further steps. Okay guys, so now as you can see that all the steps have been performed, and now you can see that there's a application which was installed onto my iOS device, which was Ballerine. Okay, it might ask you to enter into DFU mode for 1 or 2 more times. If you and once your device gets restarted, you have to wait for around 30 seconds. After 30 seconds, your screen will go blank and it's going to refresh. Okay, now this thing of the screen going blank and being refreshing is called as respringing. Okay, what's respring? Respring is when your entire device gets restarted without actually restarting. Okay, so all of your applications gets restarted, your cache gets cleared, your memory gets cleared, everything. Okay, so that's what we call as respringing. Remember this term. For 30 seconds, you have to wait. After 30 seconds, your device is going to get respring. And once your device gets respring, you would be seeing an application called as Ballerine. So as you can see over here, there's an application called as Ballerine. All you have to do is go inside Ballerine and click on install. Make sure that you are connected using your Wi-Fi because it's going to download certain processes. And yes, let the installation happen. So I'm going to fast forward this for a while, and you would be seeing a request for permission. You have to click on always allow. And again, once you click on always allow, you have to tap on that respring button. Okay, so your device again would be restarted if you click on the respring button. And yes, click on the home button, open it up. And now you can see that there are 2 more applications which have been installed. One is called as the substitute. We are going to learn in detail of what substitute is in the further sections. One is called as Celio. Okay, what's Celio? Celio is basically a third-party application. I'm going to tell you more about Celio in the upcoming session as well. Substitute is basically going to help you to inject tweaks. What are tweaks? We'll be learning as those as well. And Celio is going to help you to install those tweaks. Okay, so how you can install, what all you have to do, we are going to learn in the further section. For now, just make sure that your Celio and substitute is working perfectly fine. Okay, if you face any error, do not worry at all. Simply run the Ballerine process all over again. Okay, you can restore your iPhone if you wish to. You have to run the Ballerine process all over again. You can contact me if you have any doubts for the same as well. Okay, so this was it for this video, guys. Thank you. Hello all, welcome back to this video. In the last video, we understood how you can jailbreak an iOS device. In this video, we are going to understand how you can set up your proxy in an iOS device. So once you jailbreak an iOS device, it is very essential to capture all the requests which are moving from an application to the web application server or the mobile application server. Now to capture this requests, we require Burp Suite in order to intercept those, so that we can play with those requests and find vulnerabilities in them. But before Bobsuit can intercept those requests, we need to set up a proxy connection. In this video, I'm going to show you how you can set up that proxy connection. So we are going to set up a proxy connection between an iOS device and Bobsuit using a proxy server. Okay, so it's the demo time, and let's understand how you can set up the proxy connection. Now over here, you can see that this is my jailbroken iOS device. Okay, and it's connected to a Wi-Fi called as TP-Link. You have to make sure that your device wherein the Bob suit is running and your iOS device is connected to the same Wi-Fi network. As you can see that my iOS device and my laptop wherein Bob suit is connected is on the same Wi-Fi network. You have to go inside the proxy settings and you have to edit the proxy settings. You have to select the proxy which is already enabled and click on edit. Once you click on edit, you have to change the bind to address to all interfaces. Okay, so previously it was loopback only, which means that your Bob suit is going to capture all those requests that are coming from the loopback address. What's the loopback address? The loopback address is 127.0.0.1, also called as your local host. Now, you do not want Bobsuit to capture requests just from the local host. You want Bobsuit to capture the request from all the devices which are connected. Okay, so now let's say on the same Wi-Fi, there are four devices which are connected. One is my iPhone, one is my Mac laptop, other two are maybe an Android phone and a Windows laptop. You want your Bob to take all those requests or to capture all those requests coming from all those devices, right? So you're going to click on all interfaces. Why we are clicking on all interfaces? Because I want my Bob to capture the request coming from my iOS device. Once you do that, you have to click on the OK button and you have to click on yes. Perfect. Now you can see that it has been switched to star:8080, which means that Bob is going to capture network or Bob is going to capture traffic from all devices. Okay, perfect. Now let's try to make a connection. Okay, before we make a connection, you have to go inside Wi-Fi. You have to go inside information of the Wi-Fi, and at the very bottom, you can see configure proxy. Okay, you can see configure proxy. You have to click on it. Once you click on it, currently it is off. You have to click on it and click on manual. Okay, so once you click on manual, you have to mention the server address. Now how are you going to get this server address? The Before getting the server address, let's mention the port number. The port number is going to be 8080. Okay, so as you have mentioned over here, similarly the port number is going to be 8080. Now for the server address, you have to give the IP address of your host machine or of the machine wherein Bobsuit is installed. Okay, so all I have to do is I'm going to do ifconfig. I currently have so many networks over here, so I'm just simply going to grep my IP address. For a reason, I know that my IP address starts from 192. Yours might start from something different. So you can check it out. It's very simple. So for me, the IP address is 192.168.1.3. I'm going to insert 192.168. Oops, it's 102. That's 192.168.1.3. The port number is going to be 8080. I'm going to click on save and that's it. Now all the connections or all the requests which my or which my iOS device is going to make, my Bob suit is going to capture. Okay, so now I'm simply going to go on to Safari browser inside my iOS. First, I will be clicking on intercept on. Okay, and I'm going to visit a website called as http Bob. Okay, so now if I visit the website, if I see this particular homepage, I'm sure that my connection is successful. Now, what happens is by default, you're only able to capture the HTTP traffic. Okay, you cannot capture the HTTPS traffic. So for example, we are going to go onto the website called as http://testphp.volenweb.com. Okay, let me write it perfectly. It's testphp.volenweb.com. And I'm going to turn my intercept on. And now you can see that I have captured request from testphp.volenweb.com. Okay, it's an HTTP request. It's not HTTPS request, it's an HTTP request. And you can see the HTTP page has been loaded successfully. Now, at the same time, if I go on to an HTTPS website, let's say google.com, it's going to give me an error saying that the connection is not private. Why? This is because we haven't installed or we haven't trusted the certificate of Bob. This is the reason that it's not going to show me or it's not going to give me the results for HTTPS connection. For that, you have to go onto this website called as http://burp. You have to download the CA certificate. Once the profile is downloaded, you can go inside settings and click on profile downloaded, and you have to click on install. Once you install it, the certificate is going to be downloaded. Now, the certificate is just downloaded. It's not trusted. You have to scroll bottom. You have to go inside VPN and device management and click on the CA certificate, more details, certificate, and you can see these are all the certificates which are available. Okay. And now if you refresh and go on to google.com, it's still going to show you an error. Okay, so it's going to show you an error. Why? Because the certificate has been downloaded, but it's not verified yet. Okay, you can see that the certificate is not trusted yet. It's downloaded, but not trusted. To trust the certificate, you have to go inside settings, general, scroll over the bottom, VPN and device management, configuration profile. Okay, you can see it's verified. You can just search for trusted certificates. Okay, it's inside general. Okay, you can search for trusted certificates and you can go inside certificate trust settings and you have to turn on port trigger CA. You can see that it's enable full trust for root certificates. You have to turn on this, and once you turn on this, I'm sorry, my screen got froze. I'll just, yeah, perfect. If you turn on this, and now if you visit https google.com, google.com is going to load successfully for you. Okay, so we'll wait for a couple of minutes, and yes, now you can see that google.com is successfully loaded. Inside the Burp HTTP history, I can see that all the requests made by Google was successfully loaded. Now let's check out whether we are able to capture a particular request or not. So I'm going to search for cricket and I'm going to capture that particular request. I'm going to modify this cricket to, let's say, football, and I'm going to forward this request and I'm going to turn off the intercept. And as you can see, I have successfully modified the request as well. So in this manner, you can configure your proxy with your burp suite on your host computer and play with the request and the response from the iOS device. Thank you. Hello, welcome to this new module on getting started with iOS. I hope in the previous module you have set it up your environment and you're ready to hack into applications. So in this module, first of all, we are going to learn about iOS applications. So what exactly are iOS applications? iOS applications are nothing but a zipped file under the extension .ipa. So these are nothing but just a compilation of all the assets, all the code, whatever it is written inside a format, a zipped format called as .ipa. So just like we have .apk for Android based applications, similarly for IP applications, we have .ipa. iOS applications are a completed application ready to install, and this application, when it's ready to install, it is called as a bundle. Now, whenever you decompress an IPA, you'd be having something called as name.app. Okay, we are going to see this in practical in a couple of minutes, but you would be having something called as name.app. And inside this name.app, you would be having certain important files. There are a list of all the different files. Now, these different files contains the assets. When I say assets, assets basically means the images used inside the application, the videos used inside the application, the links used inside the application. All of these are called as assets. The source code of the application and other features or other code signatures. So some of the very common folders or files which can be found inside an application is listed down over here. Let's go through them one by one. The first one is the info.plist file. Now, info.plist file is specific application components. Inside the info.plist file, you represent that which iOS device the application should run, whether the iOS device should be having a minimum operating system version. So for example, let's say you want your application not to run on iOS 14 and lower. You can define that inside info.plist. You want your iOS application to have the permission of camera. You can define that inside info.plist. You want your application to get the location every now and then, whether the application is running or not running. You want the location to be constantly given to your application. You can define that inside info.plist. So info.plist is specific, it is specific permissions defined to your application components. Secondly, you have the code signature. The code signature is a plist file with all signature over all files in the bundle. Okay, so it's a plist file with signatures all inside the bundle. You have assets.car. Assets.car is basically zip files that contains assets. So these are zipped assets. Assets include your images, videos, source codes, etc. You have frameworks. Frameworks are basically a folder containing the framework files. Frameworks are something like, let's say you have imported a calculator module, that can be a framework. Okay, you have imported, let's say, an a module which deals with SQLite databases, that can be a framework, etc. So these are framework files. These the frameworks folder contains this frameworks files. You have your core data. Now this is where your application's permanent data is going to be saved for offline usage. Okay, so this is your cache data or a temporary data wherein your application's temporary data is going to save. So let's say you have copied something from your application. Okay, now where is this copied thing going to save? It's going to get saved inside core data. And then finally you have pkg info, which is an alternate way to specify the type and creator codes of your application or bundle. Okay, so moving forward, what we are going to do is, it's the demo time and we are going to download an application, and I'm going to show you, or I'm going to walk you through all the different steps which you have to do in order to view these files. Okay, so for demonstration purposes, I'm going to use a application called as DVIA. Okay, sorry, it's not Diva, it's DVIA. Diva is for Android. We have something called as DVIA, which stands for Damn Vulnerable iOS Application. Okay, you can just search DVIA GitHub, and the very first link from Pratik147, you will be finding it. DVIA is basically a damn vulnerable iOS application, and it is written in Swift language. Its main goal is to provide platform to mobile security enthusiasts or professionals to test their iOS penetration testing skills. Okay, so it's a predefined vulnerable application wherein your iOS testing skills are going to be performed. Now there are certain vulnerabilities with which DVIA comes up with. One of them is jailbreak detection, excessive permissions, runtime manipulation, anti-hooking debugging, binary protection, touch face ID bypass, phishing, etc. There are 15 of all those different vulnerabilities. We have a particular section wherein I have gone through all of these vulnerabilities. You can find it in the code section below. So if you're stuck anywhere with DVIA and you want a walkthrough of it, I've given a detailed walkthrough of each and every vulnerability which is present over here. Okay, so the best way to download DVIA, what Pratik147 has done for us is he has created a swift.ipa file already. You can just click on it and click on download, and it's going to start the download for us. Okay, so we need to wait for some 5 6 seconds and so that it gets downloaded. And I'll just move this forward. Okay, so once it gets downloaded, what you can do is you can right click, open with, and you have to use a software called as the unarchiver. Okay, I've already downloaded this. You can download it. So there will be something called as the unarchiver. We can open it, and what the unarchiver is going to do is it's going to extract for you. Okay, it's going to extract for you. Now, once you extract it, there would be a default folder which would be created called as payload. Now, you have to remember this every time you extract an IPF file, a payload folder is always going to be generated for you. Okay, so every time you extract an IPA file, a payload folder is generated, and inside this payload folder, you would be having your DVIA application. Okay, and you have to right click it and click on show package contents. Now, these are all the different files which we were talking about in the presentation. Okay, so these are all the different slides. So let me just go back to the presentation, and you can see that the first file which we talked about was info.plist, and yes, info.plist, which is specific application components. Secondly was code signature. So you can see there's no code signature over here. Why? Because we haven't yet installed this application onto our devices. So code signature contains signed IPF files or signature of those IPF files. Now, when I say signed, basically means that, so let's say you are a developer, you created an application, you sign that application. When you sign the application, you say that now this application will be hosted onto the iOS store and you can install it. Okay, so signing of that application is called as signing. Since we haven't signed this application, this is just a raw IPA file, we do not have the code signature. Okay, but we definitely do have the assets.car, which is in some format. Okay, some unreadable format. We have the frameworks folder. So let me just quickly find the frameworks folder, and as you can see, this is the frameworks folder. You can see there are all different kinds of frameworks which are being used. You can see Flurry iOS, LibSwift Core, LibSwift Foundation, Bolts framework, etc. So there's a huge list of all the different frameworks which are being used. Core data, again, core data contains cache or temporary data. Okay, we haven't installed this application onto our iOS devices and we have not run this particular application, so your cache or temporary data is not going to be present, right? So your cache data is not present, and that's the main reason core data folder has not been added up right now. Okay, once we run the application, it's going to be added. And then finally you have package.info, which is an alternate way to specify the types and creator codes. So it's basically gives an idea about the application. So here it has some information of the application. So that's it for this particular session, guys. The main idea was to introduce you to all the different folders, and one important file which we are always going to look around is called the info.plist file. We are going to learn about info.plist in the coming videos. So stay tuned and thank you. Hello all, welcome back to this session. In the last session, we learned about what iOS applications are and how you can go about check the source code of the iOS applications, etc. In this session, we are going to learn in detail about info.plist file. So in the previous lecture, I told you that info.plist file is one of the most important files in any iOS application. In this session, we are going to learn about this info.plist file in a bit detail. So what exactly is this info.plist file? Info.plist file is the main source of information for iOS applications. Okay, it consists of a key value pair, structured essential configuration informations about the application. You can grip it easily since it is of key value pairs. Okay, the key is called as the key and the value we define inside the key by using a syntax called as string. I will be showing you about the same in a couple of minutes. Okay, but just remember that this is a key value pair structure and it describes some of the essential configuration information. Now, here are some of the keywords you can always look out for whenever you are checking the info.plist file. So let's go through them one by one. The first is application permissions or app permissions. App permissions are such as whether the application is using your location, whether the application is using your camera. There might be some dangerous functions as well. So for example, the application is trying to read a file from your iOS device. Okay, so such things you can always check out for. And how will you check out for this? You can always check out usage description keyword inside the find parameter. Okay, so you can simply hit Control F and find for usage description, and you'll get a list of all the different application permissions which are being used. Or else, if you are someone who loves to work onto Linux, onto command line, you can simply just cat the info.plist file, hit the pipe button, say grep, and grep for usage description. Okay, then you have something called as custom URL schemes. Now, custom URL schemes are basically custom URLs that are present inside your application. So let's say an application is using a Firebase database to store its information. Okay. So your Firebase database URL would be included inside the info.plist file. And then we have a lot of case studies or lot of test cases for such Firebase database URLs. Okay, but where will you be able to find them? Is inside CF bundle URL types. Okay, you have to look out for this particular parameter, and using this particular parameter, you would be able to look out for custom URL schemes. Now, let's say there are certain exported or imported documents that are coming onto your application. You can check them using UT exported type declarations and UT imported type declarations. So these are also some of the things you can check out for. And finally, you have app transport security, which is also has you which basically says that whether your application should communicate over a website using HTTP connection or not. Okay, so app transport security is going to define whether your application should communicate to a website using HTTP connection or not. And how are you going to look for this? You can look for this using NS app transport security. Okay, so let's go to the demo practical. And for this demo practical, I'm going to use DVIA, which we were already introduced in the previous video lecture. Okay, inside DVIA, I'm going to go inside its master file wherein all the codes are written, and inside DVIA version 2, you would be able to find something called as DVIA version 2 again. Using inside this folder, you would be looking at something called as info.plist file. Now, this is an info.plist file. All I'm going to do is click on raw so that I get the raw data. And once I get the raw data, I'm going to copy it and paste it on my Sublime. So it looks good. Okay. And we would be able to understand. The first line of info.plist file says the version number. Now, info.plist file is an XML coded file or XML file. Okay, so when it's an XML file, you would be finding this key value pairs always. Okay, so the first line always states which XML version is being used, and you can see that version of XML being used is 1.0. And then you can see the doc type plist public because this document needs to be publicly available. And then you have the plist version, which says that which version of info.plist is being used. Since it's the first version, we have written it 1.0. The developer has written it 1.0. Okay, now you have something called as dictionary, and inside dictionary you have a lot of different keys. So you have key and its value is written inside string. Okay, so you have key, you have string, and you have something called as array as well, wherein if there are multiple values to a particular key, you would be able to find those inside array. Okay, uh, all of these info.plist files are not important. Only some of them are important, and that's what I have taken over here. The some of them which are important, I'm just going to have a look at it. And the first one which is important is called a CF bundle short version string, which basically means that once you bundle your iOS application, what version it is running. So it might be running on version 2.0. So that's what the bundled version number is. Bundle version is 2.0. So that's the reason it's called DVIA version 2. Since we are running on the version 2, over here we have mentioned it that it is version 2.0. Okay. Then you have CF bundle URL types, wherein you have CF bundle URL name. So this basically tells you that what is the bundle URL name. So the bundle URL name is com.highaltitudehacks.dvia Swift version 2. Now each application, whatever you create, should have a unique bundle identifier. Okay, now this bundle identifier helps you to distinguish between two different applications. The same concept has been introduced in Android applications as well, and the same concept is there for iOS applications as well. So this is your bundle URL name. It is a name which should be different for each and every application so that it can be distinguished. The application name and the bundle URL name, both of these things are different. Application name can be same. Bundle URL name should be different so that they have a unique identifier for them. So this is what we call as the bundle URL name. Okay, and below that you can see the bundle URL schemes, which is DVIA or DVIA Swift. Okay, these are some of the application names which can be called up. Okay, you have the CF bundle version, which is 1. LS requires iPhone OS. Obviously, since this is an iOS application, we have just inserted a check that iPhone OS should be installed inside so that this application can be running. Okay, it should not happen that this application should run on Android. So this is an additional check which we have required, and as you can see, the value for this is true, that iPhone operating system should be installed. Okay. Then you have NS Transport Security, and inside NS Transport Security, you have something called as NS allows arbitrary loads. Okay, so inside NS Transport Security, you have NS allows arbitrary loads. This is the exact thing which says or which states that allow loading of HTTP website, or in other terms, allow the application to connect with an HTTP website. Now, HTTP is unsecured, we all know that. And if you want your application to explicitly allow connecting with an HTTP website, you can mention it true over here. But while uploading your application onto the portal of App Store, you have to give the exact reason why you have inserted true over here. Okay. And since it is true, and as a security researcher or as a penetration tester, if you find that NS allow arbitrary loads is true, congratulations, you have found one of the vulnerabilities. Okay. So this is a low level category finding which we always give whenever we pen test. If HTTP connection is allowed, if the value is true, you can submit this as a finding. Okay. Now, as I said that if you want to check out for camera usages or application permissions, what application permission it is using, you can always grep the keyword called as usage description. And in this case, we can see that this particular application DVIA is using camera. So as you can see, NS camera. Okay, NS camera basically means that it's using camera. And this is the key. Inside the key with the inside the string, there's an exact description why this camera is being used. So let's read the description. The description says that to demonstrate the misuse of camera, please grant it permission once. So since this is a demo application or an application made of full of vulnerabilities, it says that I want to demonstrate the misuse of camera, so please give me a permission. But if you're pen testing a real application, or if you're checking out a bug bounty program on an IPA file, okay, so and if you find that there's a camera usage description which has been given, and the application functionality does not have any feature that uses camera, then there's a misconfiguration. And you can definitely report that misconfiguration, stating that unnecessary parameters or unnecessary permissions have been given. Okay, so let's say there's an e-commerce website which does not require audio. Okay, there's no access of audio speaking inside that e-commerce application, but still that e-commerce application is asking you for the permission of your microphone, then that's a misconfiguration. It should not be asking because there's no such feature of inputting of my audio, right? So you can always report that. Okay, moving on, you can see there's something called as UI main storyboard file. Okay, this basically states that which is the main file or which is the first file that needs to be run. And the first file is given using root. The value for this is root. There's something called as UI required device capabilities. This basically states that which device capabilities this application can run on. So, so we know that there are different ARM versions or different versions of a mobile device. Okay, ARM v7, ARM v8, ARM v9. This particular parameter tells you that which devices, the minimum of which devices can run this application. So any operating system or any mobile device with ARM v7 can run this particular application. Then you have something called as UI supported interface orientations, which basically means that which orientations are supported. For iPhone only portrait orientation is supported. For iPad, portrait, upside down, left, right, each and every orientation is allowed. Okay, so this was about info.plist file. There can be hidden strings inside info.plist file. You can sometimes find API keys inside info.plist file. So having a look at inside the info.plist file is very important, and you should always check out for these type of files. You can grep it or you can just open it inside Sublime and you can scan it manually. So that's it for this video. Thank you. Hello everyone, welcome back. So in this video, we are going to learn about UDID. So what is UDID? UDID stands for Unique Device Identifier. It is a 40-digit unique sequence of letters and numbers that identifies an iOS device. So it is similar to MAC address or Ether address in your laptops or desktops. So we know that what MAC addresses and what Ether addresses are. UDID is similar for an iOS device. Okay, you can find about UDID inside your About section of your iPhone, or else to simplify the process, you can also find it inside your Finder app on macOS. Now let's talk about why UDID is important. So imagine a scenario wherein you are going to penetrate into an iOS application for a company, and you said the developer that you please give me the iOS application. The developer would give you the iOS application, but at the same time, he does not want any other device to install that particular application. So iOS applications have this wonderful feature wherein only on the basis of UDID, your application can be downloaded and installed. Okay, so let's say I'm downloading an application where my UDID is not mentioned. My iOS device won't let me to download that particular application or install it. So this is the reason UDID is most important. So it's the demo time and let's check out how you can view the UDID of an device. Okay, so to view the UDID, you just have to go on to the Finder application and make sure that your iPhone is connected with your operating system or with your desktop. And over here, you can see that my iPhone is connected. You can see Vaibhav Lakhani's iPhone, and just underneath, you have to click tap. Okay, you have to left click your mouse one time, and you can see that UDID has appeared onto your screen. Okay, similarly, there are various other informations which are available. Let's say IMEI, what is the iPhone value, or what is the iPhone, whether it is iPhone 7 or whether it is iPhone 8. But the important thing which we are talking about over here is the UDID, and you can check out that what your iPhone device's UDID is. So that's it for this video. Thank you. Hello all, welcome back. So in this video, we are going to learn how you can access the device's shell from your computer. Now, why is it important to access the device shell? So let's imagine a situation wherein you want to extract certain files from your iPhone to your PCs, or let's say you want to paste some file from your PC to your iPhone. You want to transfer some file from your PC to your iPhone. In that case scenario, if you have the device's shell ready on your laptops, it's going to be an easy task for you. So how do you do that? So first, once you jailbreak your iPhone, you can connect the shell of your iOS device by simply SSH into it. Okay, so all you have to do is just write SSH root and the IP address of your iOS device. Now, please make sure that your laptop and your iOS device should be on the same network. If it's not on the same network, you won't be able to SSH into the iOS device. Okay, so there are two ways of SSHing into the device. One is using the root user, the super user, as we all know. And the second user is called as the basic level user, called the mobile user as well. The password for both of them is Alpine. Okay, so if you want to just switch users around, the password is going to be Alpine. So it's the demo time, and let's check out how you can actually do it. So over here I have my iOS device ready. Okay, I'm going to go inside network to check what is my IP address, and as you can see, my IP address over here is 172.20.10.3. I'm quickly going to fire up my terminal. Okay, and I'm simply going to write SSH mobile. Let's log in as a normal user first. So that's the reason I'm writing mobile at rate 172.20.10.3. Once I hit enter, it's going to ask me whether I want to save the fingerprint or not. You always have to write over here, yes, you have to save the fingerprint. And now it's going to ask me the password. So as we discussed, the password is Alpine, which you can write over here. And once you write Alpine, you will be shown some basic menu. All you have to do is just enter one and hit enter. So once you enter one and hit enter, okay, so now you can see we have logged in inside the iOS device, and you can see the name is Vaibhav Lakhani's iPhone and mobile is the username. Okay, so this is how you can log in inside the device. I'm just going to run certain commands. Ls who am I? As you can see, who am I has mobile, so the current user is mobile. Now I'm going to write sudo su so that I can switch user and to become the super user. And now it's again going to ask the password for super user, sorry, the password for mobile in order to switch to super user. And as we discussed, the password is Alpine. You just have to write Alpine. And now, as you can see, we are the super user now. Let me clear the terminal first. And yes, now you are the super user and you can go inside any libraries or any folders or any files you want to access. You can do all of that. So that's it for this particular video. Thank you. Hello, welcome back to this video. So in this video, I'm going to show you how you can access the device's shell directly onto your iOS device. This is called as the on-device shell. In order to access your device's shell directly onto your iOS device, you would be needing a tweak such as mterminal. Now using this tweak, you can perform all those commands that you used to perform using the remote computer. So it's a demo time and let's check out how you can do the same. So over here, I have a third party library called as Celio. You might be having something called as Cedia. No worries, both are the same. You can go inside Cedia or Celio and just search for mterminal. Okay, please ignore my spelling mistakes. So I'm going to search for something called as mterminal. I'm going to click on it, click on get, click on queue, and click on confirm. Once you click on confirm, mterminal is going to get installed for you. Click on done. And as soon as you go back to your home screen, you'd be finding that terminal has been installed. Now, once you open this terminal, you are able to run any command you want. Okay, so for example, I'm just going to run who am I, and you can see that I'm the mobile user. The second command which I'm going to run is pwd, which basically means which is the current working directory. ls to list all the files and folders present. I can change directories and whatnot. Okay, so I'm just going to go inside the documents directory. Okay, sorry guys, my iPhone just got lagged. I'll just reconnect back so that you can see the screen. Yes, and now you can see that I'm inside the documents directory. If I ls, I will be able to see all the different files and folders inside that. In fact, I can just switch the user to a super user by simply running the command su and giving the password. The password we have already talked about in the previous video. The password is Alpine, ALPINE, and you can just write Alpine, and now as you can see that you are the root user. So that's it for this video, guys. You can use this technique in order to run all those commands which you were going to run using your laptop. And yes, that's it for this video. Thank you. Hello all, welcome back. So in the previous video, we talked about how you can get the shell of the device, the iOS device. Now in this video, I'm going to talk about how you can transfer files from your iOS device to your PC. You can easily transfer files from your iOS device and PC using SCP. SCP basically stands for secure copy. This is a command which is generally used in Linux-based computers, wherein you can transfer your files very securely from one computer to another computer, or from one mobile device to another mobile device. The basic command of SCP, I have mentioned it over here. The basic command is SCP dash capital P, which basically tells you that which port you have to use. Now, one important thing to note over here is that SCP works on top of SSH. Okay, so you are going, what SCP is going to do for you is it's going to log in as SSH into your computer system, and it's going to copy that file and paste it onto your destination folder or destination path. So that's the reason we are going to mention the port as 22. Basically, we have to mention which port the SSH is running on. So port 22 by default SSH runs on. That's what we have mentioned. SCP dash capital P port 22. You have to mention the username. Now always try to use the username as root. Okay, so we are going to mention root at rate the IP address colon. After the colon, you have to mention the path to the file. Okay, you have to be very specific of the path and the file name. Give it a space and mention the destination path where you want to save this file on your local machine. Okay, so it's the demo time, and let's check out how you can securely copy your files and folders from your device. So what I'm going to do is I'm first going to SSH into my iOS device. We had already seen how you can SSH into your iOS device. So I'm going to SSH using the password Alpine as the folder root. I'm going to go to a particular folder. Okay, so let's say I'm going to go onto the folder called as user. Inside user, I'm going to go inside the folder called as downloads. And over here, as you can see that I already had a file created. I'm going to delete that particular file. Okay, and I'm going to recreate a new file using echo. So I'm going to write something. Echo, the password is you got me, and yes, once I write this, I'm just going to save this entire thing inside a file called as password.txt. Okay, and okay, there was some issue. So let me just recopy the entire thing, and I'll just remove the exclamation mark so things get simpler. Perfect. And now you can see that the file has been created. Let's cat the file, and you can see the file has been successfully created. Now let's say that you want to transfer this file from your mobile device to your laptops. Okay, so I'm going to first close the connection. So I've exited from SSH, and now you can see that the connection has been closed. Please note that currently I'm onto my laptop. Okay, so I'm just going to go on site desktop, and now I'm going to write the command for SCP. So it's going to be scp-p22 because SSH is running on port 22. Root, I'm going to use as a root user. I'm going to mention the IP address, which is 172.20.10.3. I'm going to put a colon, and I'm going to give the exact directory where this particular file is. So as you can see in the above command, this particular file is present inside /user/downloads, and the file name is /password.txt. Okay, that's what we have exactly mentioned over here. I'm going to give a space, and since I want this file to be copied onto my local directory, I'm just going to put a dot. I am sure that everyone knows what dot is. So I'm just going to put a dot so that it gets copied onto my local directory. And now as you can see, once we run the scp command, the scp command automatically asks you the password for root onto my iPhone device. Okay, this is the password of SSH. So you have to enter the SSH password over here, which is nothing but Alpine, ALPINE. And now as you can see, password.txt has been copied successfully. And let me just go on to my desktop, and over here, as you can see, password.txt has been successfully copied. And if I open the file, you can see that the file's contents are preserved as well. So this is one of the methods wherein you can transfer your devices, or whether you can transfer your devices file onto your machines, onto your laptop machines or desktop machines. So that was all for this particular video. Thank you. Hello all, welcome back. So in the upcoming 3 videos, we are going to see different methods of how you can extract and decrypt an IPA using various methods. Okay, so I'm going to show you 3 different methods of how you can extract and decrypt IPAs. Now, before starting off the first method, let's first understand why extracting and decrypting an IPA is important. So there's a high chance, or in most of the cases, you won't be getting the IPA from the developer, right? You would be installing the IPA from the App Store directly onto your iOS device. Now, in order to check out for source code related vulnerabilities or for info.plist related vulnerabilities, you require the source code of the IPA, right? You require the source code of the IPA. Now, it's not possible that you message the developer that is present on the App Store that please give me the source code of the application. It is practically not possible. So how are you going to check for all those vulnerabilities wherein source code is required? Hence, extraction and decryption of IPA is very, very important. Now, IPAs are always encrypted. Okay, so if you simply extract the IPA from the iOS device, that's not going to work because they are encrypted with a strong encryption technique. You have to decrypt that particular IPA in order to view the actual source code files. Okay, so let's start with the first method of how you can decrypt the IPA and extract the IPA from your iOS device. The first method is using Frida iOS dump. This is the most famous method. If you Google it out that how I can extract and decrypt an IPA, the first link you will always see is of Frida iOS dump. Okay, so this is what I'm going to cover in this particular lecture. So before installing or before running Frida iOS dump, a tweak called as Frida should always be installed inside your iOS device. Okay, you can simply install this. You can go onto Celio and you can install Frida. You can search for Frida and you can just install it. If you need help of how you can install Frida, onto your iOS device. I have a video of that as well inside the dynamic analysis section. You can just scroll over and just check it out. Okay, but for this video, we are not covering because it's going to get repeated and the length of this video will also be extended. Okay, so please make sure that Frida is installed. Secondly, after Frida has been installed onto your laptops, you have to git clone this particular repository. Okay, this particular repository is from the user Alone Monkey. He is the creator of this particular tool called as Frida iOS dump. Once you git clone it, you have to install certain requirements. You can install those requirements using pip install -r requirements.txt. The most important thing which you have to do over here is you have to run an SSH forwarding over USB. Okay, what does this particular command means, or this particular thing means? It means that you have to run SSH forwarding over USB, which basically means that you have to allow the device to be connected using SSH using the USB. Okay, using the USB, and you have to give a particular port number wherein this SSH forwarding will be allowed. Now, why SSH forwarding is allowed? Because you are extracting and decrypting that particular IPA. So this particular tool, Frida iOS dump, is going to connect to your iOS device via SSH. It's going to connect via SSH over USB. Okay, and that's the reason you have to run this particular command. The command to run this is very simple: iproxy 4 times 2 22. You can, instead of 4 times 2, you can give any particular port you want. This is the default one, and it is very simple to remember as well. So by default people use this, but you can use any one of them. And then finally you just have to run the command /dump.py, the application name or the bundle identifier. We have already discussed what application name or application name is and what bundle identifier are. Okay, so you can easily do this. And now it's the demo time. Let's understand practically how you are going to do this. So first command, as I said, is to install Frida. I already have Frida installed inside my iOS device. I'm skipping that step. If you want to know how, again, you can just go on to the dynamic analysis section. There would be a title called as install Frida on your iOS device. You can just run that. So I'm just going to go on side this particular repository, and as you can see, this is the repository created by the user Alone Monkey. You can simply copy this, go onto your terminal and just git clone it. So git clone, and I'm just going to paste that particular repository. For me, it has been already been installed before. I'm just going to go inside that particular repository and I'm going to install all the requirements file. How are you going to install? Simply write pip3 install -r requirements.txt, hit enter, and all the requirements will be installed. Okay, now I'm going to clear the screen up, and yes, let's go to the next command. The next command is using iproxy. So you have to write iproxy 2222 and this is going to wait for connection, and keep this command running inside another tab. I'm going to switch over the tab, and now I'm just going to run a command called as frida-ps-ua. Do not worry about this command at all. Okay, if you're going to look at the dynamic analysis section, over there I have explained this very well. Please do not worry about this command. To brief it out or to summarize it out, this particular command is just going to give you which applications are running inside that iOS device and what is the bundle identifier of it. Okay, so over here I'm able to see the application name, the bundle identifier, and the process ID for which they are running. Okay, so this is just a summary of what Frida-ps-ua does, and we are going to take a particular command, a particular application. So let's say I want to extract the application terminal. Okay, so I want to extract the application terminal. So I'm just going to take the bundle identifier of that particular application and just going to write the command python 3 frida ios.py, or sorry, it's dump.py. You can also just run the command using /, or else you can do like this as well. So python 3 dump.py and terminal, and I'm going to hit enter, and once I hit enter, it's going to tell me that start the target app terminal. So what I have to do is I have to start that particular target application. So I'm going to start terminal, and as you can see, it has generated terminal.ipa. So you can see the terminal.ipa file has been generated for us, and it has been extracted and decrypted. Okay, so I'm just going to move this terminal file backwards, and now you can see over here the terminal file has been extracted and decrypted for us. So this was one of the methods how you can decrypt and extract that particular IPA file from your device. If this method does not work for you, do not worry. There are two more methods, two more alternative solutions to this particular problem. So continue the next video and you will be learning about the second method. Thank you. Hello all, welcome back. So in this video, we are going to look at the second method of how you can extract and decrypt an IPA using the second method, which is called as Filza. Well, Filza is a tool that is going to help you to view internal files of the application, not just extraction and decryption of IPAs. It's also going to help you very much in the static analysis of your iOS pen testing. Okay, so in this video, I'm going to tell you how you can install Filza. Filza can be installed from a third-party app store such as Celio or Cydia. Okay, you just have to mention a source URL. I'm going to tell you which source URL you have to mention. And after you mention the source URL, you can search for Filza tweak inside Celio application. Click on get, and Filza is going to get installed for you. Using Filza, you can view the internal files of the application. Once you view the internal files of the application, you have to navigate to a particular path. What is the path? The path is where containers bundle application and the application name. Now, once you get the application name, you have to create a copy of it. You have to create a new folder called as payload. Remember, in the previous videos, in one of the previous videos, I said that whenever you decrypt a particular application or whenever you extract a particular IPA file, you always get that folder called as payload. And I told you that you have to remember this. This is why I had told you that you have to remember when you are encrypting or when you are zipping that particular IPA file, you have to always zip inside the folder called as payload. Okay, you have to always zip inside the folder called as payload. You have to go inside that folder, paste the copy of the application.app, whatever you have created, and then you can simply run the SCP command, which we have looked in the previous videos. And using this SCP command, you can get the IPA file inside your computer system. So it's the demo time, and let's have a look at how you can do these things. Okay, so first of all, I'm going to go inside Celio, and this time you don't have to go inside search, you have to go inside sources. Okay, you have to go inside sources, and there would be a source called as tgsoftware.com/cedia. You have to install this particular source. Okay, so you can just click the plus button. You have to write tigi software software.com/cedia. You have to add that particular source. For me, it has already been added, so I'm just going to click cancel. Now, if you go on to the search for packages and hit Filza, you'd be able to see there are two Filzas. What you have to do is you have to go on Filza file manager 64-bit. Okay, do not go on to the first one. The first one is corrupted. It's not working anymore. You have to go on to the second one. Be specific with the name. It's Filza file manager 64-bit. And you have to follow the same steps. Click on get, click on queue, click on confirm. It's going to install for you. It's going to take a while because it's 8.7 MB. I'll just fast forward this so that it's simpler for you. And now you can see that the Filter application has been installed. And these are all the internal files and folders of the iOS device. Okay, now we are going to go on to that particular path. So as you can see, I'm inside where folder. Inside where I have to go inside containers, bundle, application, and I have to search for that particular application for which I want to create the copy or for which I want to create the IP. Okay, so I'm going to search for an application called as music.app, and this music.app I'm going to create a copy. Okay, so I've created a copy for music.app. I'm going to paste it, and I'm going to create a new folder called as payload. inside payload, I'm going to paste it. Okay, now once you paste this up, you have to hold it and you have to create a zip of the payload file. Okay, so create zip, and once you create a zip, you have to rename this. So you have to rename, you can call it any name you want. Okay, so for example, I'm going to call it, okay, so for example, I'm going to call it music, and dot, you have to give it as IPA. And now you can see the logo got changed. Now the logo is of an IPA file. So now this has become an IPA file. Now you're ready and good to go. All you have to do is run the scp command in order to bring this particular music.ipa back to your computer system. Now for the scp command, we all know that we require the IP address first. So what I'm going to do, the IP address first, and the second is the exact path. So what I'm going to do is I'm going to simply SSH into my iOS device, and I'm going to go inside that particular path. So the particular path is where, inside where it is. Okay, so where containers, inside containers you have to go inside bundle. Okay, so let me go inside bundle, inside application, and now over here everything is written in some coded language. Okay, this coded language is the unique identifier of the application. So in order to check what is the unique identifier of your application, you can simply go inside the music application, and at the title you would be able to get the unique identifier of your application. So let me just find the music application first. So yeah, yes, it is at the bottom, and as you can see, at the above it is 1F3A3F15. That is the unique identifier. So I can simply go and check it out. I can go inside it, hit enter, and you can see music.ipa file has been created over here. So this is the this is the PWD which I have copied. Now I'm going to click on exit. I'm going to click scp, and I'm going to give this particular command as root at rate the IP address. The IP address we had already checked before, so I will simply copy this, give a colon, and give the exact path to the extracted IPA. So the path we have already given, and once I give the path, I'm going to give space and just a just a file name. So file name is music.ipa, and now I have to mention the destination path, which is dot, which means I want to have it inside desktop, and then the password alpine, and as you can see, the music.ipa has been successfully transmitted. So for most of you, this method is definitely going to work, but let's say out of 99 people, out of 100 people, 99 of you, this method is going to work. But for some reason, for that 1%, if this method is not working, do not worry, I have got you covered. I'm going to show you a third method using which you would definitely get the IPA file. Okay, so for the third method, please have a look at the next video. And that's it for this particular video. Thank you. Hello all, welcome back. So in this video, we are going to learn how you can extract and decrypt IPAs using the third method. The third method is iMazing. So what's iMazing? iMazing is a mobile device management software that allows you to transfer files and data between iOS devices and Mac OS or Windows computers. Okay, you can install iMazing by simply going on to imazing.com/download. Now to summarize and give you a short description of iMazing, iMazing is basically a toolkit. It's a toolkit using which you can perform multiple actions onto your iOS device. Okay, you can perform these multiple actions either from your Mac OS machines or Windows computers. So that basically means that iMazing is available for both Mac and Windows. And one of the best features which iMazing gives you is that you can extract and decrypt the IPS as well. But since iMazing is
very user friendly. There's one disadvantage with which iMazing comes up. The only disadvantage that iMazing comes up while extracting and decrypting IPAs is that you cannot run this IPAs with another Apple ID. Okay, because these are signed by your own code signature. Okay, so once you extract and decrypt a particular IPA, you cannot run that IPA on any other device which does not have the same Apple ID as you used when you were extracting and decrypting the IPA. So that's the only disadvantage of using this particular method. But yes, nevertheless, this method definitely works out well. Okay, so it's the demo time and let's check out how you can perform the same. So what I'm going to do is I'm going to go on to imazing.com/download and you can download for Mac or for PC. I've already downloaded it for Mac. It's ready with me. And there's a trial version which you can download for Mac. It's a trial version of 10 days, I believe. And I have connected my iOS device, my iPhone, with my laptop, and that's what it's showing over here. It shows available. Okay, so inside iMazing you have all the different options, and now we are going to extract this IPA called as Xterminal, which I've directly downloaded from the App Store. Now to extract this you have to click on manage apps, and you would be able to see that Xterminal which we have downloaded from the App Store is visible over here. All you have to do is click on the download button first. You have to give your Apple ID password. Okay, I'm just going to remember my password so it does not ask me again. And you have to wait until this gets downloaded. Okay, so I'll just fast forward this. And perfect. Now it's downloaded. You have to right click and you have to click on export IPA. Once you click on export IPA, you just have to choose the destination path, click on save, and that's it. Your IPA file will be extracted for you. Now this is very simple to do, but the only disadvantage, as we talked about, that you cannot install this IPA back again into any other app, other device that is running with a different Apple ID. Obviously, you can install this on the device that is running this with the same Apple ID, but not the different one. So that was it. We got introduced with three methods. Frida iOS dump. Second one was using Filza, and the third one was using iMazing. You can use any of these three methods. My personal favorite is Frida iOS dump. It works in most cases. You can use the same, or you're free to use any three of them, or any one of the three of them. Alright, that's it for this particular video. Thank you.
Hello all, welcome back. In the previous video, we saw how you can extract and decrypt IPAs from your mobile device using various methods. In this particular video, I'm going to show you how you can install applications using two methods. The first one would be covered in this particular video, that is using 3U tools. The second one is by a method called as side loading. So what is 3U tools? 3U tools is the most efficient iOS files and data management tool. 3U tools can help you install IPA files, not only just installing of IPA files, but also 3U tools supports jailbreaking of some iOS versions. So it's the demo time, and let's check out how you can install 3U tools. So in order to install 3U tools, you first have to go onto this particular website called as 3u.com. Over here, you can see that there's a download button using which you can download it. 3U Tools is the most efficient iOS software. It allows you to flash and jailbreak in an intelligent way as well. And these are all the different features of 3U Tools. Now for me, 3U Tools has already been installed. So I'm just going to open it. Now one important thing to note over here is that 3U Tools can only be installed in Windows computer. 3U Tools does not support iOS devices or iOS computers such as Mac OS. But do not worry if you are using a Mac machine and if you want to know how you can install an IPA file, you can use the second method that is called as side loading. That will be covered in the next video. So let's continue. In 3U tools, the first section is the iDevice section, wherein you will be able to get all the details of your iOS device, such as your information, whether the device is jailbroken or not, what is the Apple ID, what is the battery life, etc. So all of these details would be seen inside the 3U tools section. Then you have the application section wherein you would be able to download and install all apps. You have RT and WP section, you have Smart Flash. The toolbox section covers all the different tools that 3U tools support, such as backup, restore, virtual location, real-time screen, 3U Air Player, etc. It also supports jailbreak as well. So if you can see, there's a jailbreak tool. It downloads a configuration first. That takes some time. And once the download happens, it's going to show you all the possible methods of jailbreaking that particular iOS device. So once the tool is open, you can use any of the method and you can start the jailbreak section. There's a classic device jailbreak as well, which you can use it. Now we want to know how we can install IPA files using 3U tools. So in order to do that, you have to go inside apps. You have to click on import and install IPA and click on the IPA you would like to install. Once you click on the IPA you would like to install, it's going to transmit it to your iOS device. Make sure your iOS device is connected and it's going to install it for you. Now installation might take some time. So once the installation is complete, you would be able to run that application on your iOS device. So that's it for this particular video. Thank you.
Hello all, welcome back. So in the previous video we saw how you can install applications using 3U tools. In this video I'm going to show you a second method of installing applications. This method is called as side loading. What is side loading? Side loading is a method of installing applications by manually signing them. So you manually sign the applications and install it inside your iOS devices. This method is the same which is followed by 3U tools. Okay, so 3U tools also follow the same method, but over here we are going to use the same method using a different tool called as altstore. What is altstore? Altstore is an application that signs the IPF file and sideloads it. Okay, so it's the demo time and let's have a look how you can install altstore and how you can sideload the applications. So in order to install altstore, first of all you have to go onto the website called as altstore.io. Okay, you can install altstore for Mac and Windows. You'll be installing altstore server. I already have altstore installed over here. Okay, as you can see above I have altstore installed and it has certain functionalities which needs to be completed first, certain things which needs to be completed first. uh, you have to open the mail. Okay, you have to keep the mail open. The mail which comes with Mac OS, you have to keep it open for Mac machines. For Windows machines it is pretty simple. And now we are going to install the IPA file of DVIA. Okay, so I'm just downloading DVIA version 2 IPA file and I'm going to show you how you can install it. Meanwhile DVIA gets installed, all first you have to do is you have to install altstore onto the iOS device. All you have to do is click on altstore application, go on to install altstore and choose the iPhone for which you want to install the altstore application. So you can choose the iPhone, make sure that your mail is running at the background, and once you click on install altstore it's going to ask you for your Apple ID. You have to give your Apple ID and password. Using this Apple ID and password it's going to sideload that particular application by signing it. Okay, so once the application gets signed in, it's going to get side loaded and it would be installed inside your iOS device. So I'm just going to fast forward this once. Okay, it might ask you for 2FA and you have to give your 2FA and OTP which is there present. Okay, so what I'm going to do is I'm going to keep open DVIA GitHub as well over here and I'm going to just install the IPA file. Okay, I'll click on view raw and once I click on view raw the IPA file is going to be downloaded. So once the IPA file is downloaded, as you can see the download has been started and the IPA file has been downloaded. Meanwhile, altstore was also installed. So you can see the altstore has been installed. You have to go into settings and you have to sign in with the same Apple ID as you used while installing altstore. So once you give the Apple ID, which I have given over here, I'm just going to fast forward the password, hit on submit, and yes, altstore would be connected. Okay. Now inside my apps, you have to click on the plus button and you have to select the IPA file. Once you select the IPA file, what altstore will do is it's going to manually sign in and it's going to install the application on your iOS device. Make sure one thing which is very important to note is that any application which is installed using altstore only remains active for 7 days. Okay, after every 7 days or before the 7-day expiry, you have to refresh it. Why? Because the account which we are using is not a developer account, it's a normal user account. Also, only 3 applications at a time can be side loaded. Okay, so we have already used 2. We can use one more application to side load it, but more than 3 applications at once won't be side loaded. These are some of the restrictions which are given by the Apple development team. Okay, so if you have a paid developer account, your expiry would be for 99 days. If you do not have a paid developer account, then every application will be expired in 7 days, but you can simply refresh the list, or you have a button called as refresh all. You can click on it by connecting your alt store and your alt server, and it's going to refresh. Okay, so you don't have to worry about it. And once that is done, you can now see that DVIA has been successfully installed inside our iOS device. So this was it, guys. We saw 2 methods how you can install applications. One was using 3U tools. The second one was using side loading. There are other side loading applications as well, such as Sideloadly. It's an alternative for altstore, but altstore works the best. You can use Sideloadly and other side loading applications if you want to. So that was it. Thank you.
Hello all, welcome back to this new module. In this module, we are going to learn about iOS basics. Now, this particular module is not related with iOS pen testing. However, in this module, we are going to look at what various features does Apple give us while protecting its application and file contents. So we are going to learn about each and every basic features of what Apple has given us in order to secure their iOS platforms. And we are mostly going to look at the mitigations part and how you can implement these features. And we are going to learn in detail of each and every feature. So let's start. Let's first start with data protection in iOS. How does exactly iOS perform its data protection? We have known that iOS is very famous for its data protection, but how does it actually happen? I'm going to explain you in very brief by this or by the help of this particular diagram. So let's say there's a file, there's an txt file, and you want to encrypt this particular file. You want iOS system to securely save this particular file inside your iOS device. So what happens first is, as soon as the file is created, the file contents are logged with a 256-bit AES key that is generated, and this particular key which is generated is called as the file key. The file key is stored inside the file metadata. So as you can see over here, there's this file metadata, and inside the file metadata, this particular file key is stored. Now this file metadata again in turn gets logged up or is encrypted. And how is this encrypted? This file metadata is encrypted by using the file system key. Now, how does this file system key get generated? The file system key gets generated by using a hardware key. This hardware key is no other than a key that is derived from your UUID, that is your unique identifier of each and every device. Now, since the UUID for each and every device is different, it makes it almost impossible to crack this particular file system key. Once the file system key is generated, there are two things which gets generated. One is the class ID and one is the class key. Now think of it something like this, that each and every class ID will be having a class key associated with it. So in order to unlock the class key, you will require the class ID. Now this particular class ID and the class key is generated using two things. One is your hardware key. Again, this is the UUID which is generated, and one is the passcode key. The passcode key is nothing, but it's the 6-digit passcode number or alphanumeric number, uh, which is used in order to unlock your iOS device. So as soon as you lock your screen and you try to unlock your screen, you are required to enter some passcode. This is that particular passcode. So your passcode and your hardware key, this in turn clubs up to create the class key. And once the class key is decrypted, you get the class ID. Using that particular class ID, you can locate your file metadata, the encrypted file metadata. Using the file system key, you can decrypt that particular file metadata. So using the class ID, you can get the file system key. Using the file system key, you can decrypt your file metadata. Once you decrypt your file metadata, you get the file key. And using this particular file key, you can decrypt your file. And finally, you get the file contents. So I hope you get this particular thing, how data protection exactly happens in iOS. If not, I'll just quickly recap it within 1 minute. During the encryption process, your file contents are first encrypted using a file key. This particular file key is stored inside the file metadata. This file metadata is in turn encrypted using a file system key, which is created by the hardware key, which is the UUID of your device. This file system key generates a class ID, which is stored along with the class key. And this class key is finally encrypted using hardware key and the passcode key. While decrypting of your data or when you want to view the file contents, what happens is your hardware key and your passcode key, they combine to create the class key. The class key gets unlocked. And once the class key gets unlocked, you get the class ID. The class ID is going to give you the file system key. The file system key, using the file system key, you're going to unlock your file metadata. You would be getting your file key, which would be stored inside the file metadata. And once you have the file key, you can unlock the file contents. And then finally, you can view your unlocked file. So this is exactly how data protection happens in iOS. Now to make the protection process more smoother, there are four options that Apple gives you. The first one is called as the complete protection, which stands for NS file protection complete. This is the particular value which you would be looking for into your info.plist file. If there's complete protection, this it would be set as NS file protection complete. Now what happens in complete protection? A key derived from the user passcode and the device UID protects the class key, as we already seen in the previous diagram that the class key is protected by the user passcode and the device UID. The derived key is wiped from the memory shortly after device is locked, making the data inaccessible until the user unlocks the device. So what exactly happens is the derived key from the passcode and the hardware key, this is not saved in the memory at all. Okay, it is wiped off from the memory as soon as the device is locked. And once you unlock the device, this key will again be generated and then you will be able to see the file contents. The second one is protected unless open. The value for this is NS file protection complete unless open. This protection class is similar to the previous one, that is NS file protection complete, except for the fact that the derived key is not wiped off from the memory. Okay, and you can use that derived key whenever. So it says that this protection class is similar to complete protection, but if the file is open when unlocked, the app can continue to access the file even if the user locks the device, which basically means that the key is not wiped off, and even if the user locks the device, he can still continue to use this particular file. So this usually happens when you are downloading an attachment either from Google Chrome or from your mail. So let's say there's an attachment which you are downloading and it's a huge attachment, let's say of 1 GB. And meanwhile it's being downloaded, you lock your device. Even if you lock it, you can still let the attachment be downloading. Okay, so the attachment is going to download in the background. So that's what happens in protected unless open. Then you have protected until first user authentication. The value for this is NS file protection complete until first user authentication. The file can be accessed as soon as the user unlocks the device for the first time after booting. It can be accessed even if the user subsequently locks the device and the class key is not removed from the memory. So again, the class key is not removed from the memory. The fact is that the derived key is only calculated once, and when is that once? The derived key is only calculated as soon as you unlock your device for the very first time after rebooting it or restarting it. So that is only the first time when the derived key is going to uh, get created, or the derived key is got the derived key is going to be updated, and yeah, after that it's never going to be removed from the memory. And then finally you have no protection, which basically means there is no particular protection which has been enabled. The value for this is ns file protection none. So that is it for this particular video, guys. I hope you understood how data protection exactly happens in iOS. So yeah, that's it. Thank you. Hello all, welcome back. So in the previous video, we learned about data protection in iOS. In this video, we are going to look at an advanced level of data protection that Apple has given us. Yes, you heard it right. It's keychain. So what's a keychain? A keychain is an encrypted container where every application can store sensitive pieces of information, and only the same application or authorized application can retrieve the contents. So what does it mean? So think of keychain as a box, a sandbox, a box where only the authorized applications are able to view the file contents or sensitive contents such as usernames and passwords. Now let's say there's a container of an application, let's say test, and there's another application, let's say ABC. Now ABC wants to access the passwords of test. That is not going to happen. Why? Because keychain is developed in such a way that only ABC is authorized to view the contents of ABC sandbox, while application test is only authorized to view the contents of test sandbox. Or else the developer has explicitly tell ABC that you can view the contents of test. Only in that particular condition, ABC can retrieve data from test, or else it's not going to retrieve any data from test application. The iOS generated its own password for the keychain and stores an encrypted version of the key and the device. So for keychain, an own generated password is created by iOS. How is this password created? This password is created using an AES key that is created by a PBKEF2 function of the user's password plus salt. What is the salt? The salt is nothing but the device UID. And since the salt is device UID, it becomes impossible for another device's keychain to decrypt the password of this particular device's keychain, because UID for each and every device is going to be different. And that's the reason keychain is called as one of the most encrypted password library that Apple has ever created. So that's keychain for you. Now, keychain provides 4 different levels of access control flags. Now let's have a look at these access control flags one by one. The first one is KSEC access control device password, which basically means that you can access any file contents or any file via a passcode. KSEC access control device biometry any, which basically means that access the item via one of the fingerprints registered to the touch ID. Adding or removing a fingerprint won't invalidate them. So this particular thing, basically you can see it in WhatsApp. If you have an iOS device and you have used WhatsApp inside iOS device, WhatsApp is one of the best examples. And if you have biometric touch ID or face ID enabled. Okay, when I say about biometry, it includes both the touch ID and the face ID. So if you have biometric enabled in WhatsApp, you can see that WhatsApp first asks you for your touch ID or your face ID, and then and only then it's going to allow you for viewing the contents of WhatsApp. So for keychain, for access control device biometry any, it is similar to what WhatsApp has built the feature for. Okay. Then you have the third one, which is KSEC access control biometry current set. Access the item via one of the fingerprints registered to touch ID, and adding or removing a fingerprint will invalidate the item. So this thing basically means that if you add or remove a fingerprint, the item is going to be invalidated, and it's again going to ask that the fingerprint has been added or removed. do you want to continue or do you want to change the settings? Okay, that's what ksec access control biometric current set tells you about. And then finally, you have ksec access control user presence. Access the item via either one of the registered fingerprints using touch ID or face ID or default to the passcode. So you can use any one. You can either use the item to you can either use the touch ID or face ID to view the item, or you can use that 6-digit passcode or your device unlock passcode to view that particular item. So I hope this particular video would have made you clear more about keychain and how keychain works and how keychain encrypts itself. So that's it for this particular video. Thank you. Hello all, welcome back. So in this particular video, we are going to talk about application capabilities and purpose strings. So each application has a unique home directory and a sandbox so that they cannot access protected system resources or files stored by the system or by other applications. So what happens in iOS devices is basically each application has its own different box area. Okay, if you're familiar with Docker does the same thing and is working or works on the same concept. Each Docker application is inside a separate sandbox area so that it does not get involved with other applications. Similarly, in iOS as well, each application works inside a sandbox area so that other applications or other system resources or other files are not accessible by this particular application. And this particular application works only with its files. Now, purpose strings or usage description strings are custom text that are offered to users in the system's permission request alert when requesting permission to access protected data or resources. So for example, let's say an application, okay, e-commerce application wants to access location. Now this particular location can also be termed as an application because at the end it's a software. Okay, it's something that is going to give the exact location of the device. Okay, so it's a software. Location works inside its own different sandbox, while as this e-commerce application is also working on its own different sandbox. And since it's an e-commerce application, it might require location to get the exact location of the device so that it can check whether that e-commerce application can deliver items to that particular place or not. So that's just a test scenario which I'm talking about. So in the screenshot below, you can see that there's a my route application that is asking for location. Okay, that is a different application. Now, when these things happen, when one application asks or uses software of the other application, they have to send a particular permission request. And with that particular permission request, you have to give a usage description. That usage description is called as the purpose string. That for what purpose you're using this particular software or you're using this particular application capability of. Okay, so in our example, the application capability is location. And what is the purpose string that has been given? That your location is used to provide turn by turn directions to your destination. So you can see that uh, inside light black colors that your location is used. That is what we call as the purpose string. Now, this application capabilities as well as the purpose strings can be found inside the info.plist file. So it's the demo time. And what I'm going to do is I'm going to open three such applications. I'm going to open the info.plist file for three such applications. And I'm going to show you what are the different purpose strings that can be seen and how you can check these purpose strings and whether these purpose strings should be given in the application and whether they can be vulnerable or whether they can provide any security impact to the application or not. So let's check that out. So the first application which we are going to look is DVIA2, that is Damn Vulnerable iOS Application version 2. For this, we have already seen the info.plist file in the earlier section, but since the topic is revolving around the application capabilities and purpose string, I'm once again going to revise that particular topic for this particular application. So now over here, you can see that there's something called as NS App Transport Security. This basically tells whether the application can work onto HTTP connection or not. Specifically inside ns allow arbitrary loads. This ns allow arbitrary loads is the application capability, which particular tells whether the application can connect with an HTTP request or not. And for this, you can see that the value is true. So this is the application capability, which was defined inside info.plist file. The second application capability is NS camera usage description, which basically means that this particular application is going to use your camera. Now, why is it going to use the camera? Since this is a vulnerable application, we have the purpose string over here that says to demonstrate the misuse of camera, please grant it permission once. Now, let's say there's an note-taking website, note-taking application, and this note-taking application is asking for your location permission. Now, over here, you have to run your minds, you have to run your thoughts whether why this note-taking application is going to ask for my location. Is there a need for the note-taking application to ask the location? No, there's no need for a note-taking application to ask my location. So this can have a security impact, and you can report this inside unnecessary permissions granted or unnecessary permissions asked. You can report this particular thing or this particular security vulnerability inside this particular topic. So this is how you can just check out the application capabilities which are used, as well as what purpose or what purpose string are they being used. So before reporting it, you can simply have a look at the purpose string. Why is the application actually asking? And if you are comfortable, if you feel that no, this particular application would require location permission, for example, or for instance, in our case, then that is not a vulnerability. But if you think that this purpose string is not proper, then you can definitely report them as well. So we have UI main storyboard wherein the string is root. And let's go to the second application, that is unsafe bank. Again, this is one of the vulnerable applications, and inside unsafe bank, you can see there's something called as UI launch storyboard name, that is launch screen. Then you have UI required device capabilities, and you can see that it is ARM v7. And then we are finally going to the third file, that is OVIA, that is over secured vulnerable iOS application. Again, this is one of the vulnerable iOS applications. And over here, you can see there's something called as NS App Transport Security. Again, for this particular application capability, it is true. Again, you can report this if you think that why HTTP connection is being allowed. So that's it, guys. This is how you can check out for application capabilities as well as the purpose strings, and you can find certain low hanging fruits by just checking out the info.plist file. And yeah, I hope you understood this particular video. Thank you. Hello all, welcome back. So in this video, we are going to talk about iOS app extensions. So what are app extensions? App extensions lets applications offer custom functionality and content to users while they are interacting with other applications or the system. For example, some of them are custom keyboard, wherein the iOS system keyboard is replaced with a custom keyboard for use in all applications. Share, post to a sharing website or share content with others. And something called as Today, also called as widgets, that offer content or perform quick tasks in Today view of notification center. So to make things short or to make things simpler for you, let's take an example. So let's say that you are taking some notes on your note keeping application, and you want to send this note to one of your friends via SMS. Okay, so what you're going to do is you're going to click on that share button, and once you click on the share button, you'll be seeing that there's something called as messages. You click on messages, and another application of messages pops up onto the same screen. Okay, and it asks you to select a particular number or particular contact whom you want to send that particular message. You select that contact, and if you see that particular notes, whatever you had written gets copied and pasted inside that SMS text box. All you have to do is click on send. So that is what Apple has come up with. It's a very beautiful feature called as application extensions. So let's have a look of exactly how these application extensions work. So in our example, we have taken the example of two applications. One is notes and one is messages. You want to share your notes with a particular contact using SMS, and that's how SMS is going to work. So our notes application is the host application, which you can see over here. And inside the, oh, okay, I'm sorry. Let me just go back. Yep. So inside the host application, what host application does is it's going to request for an app extension. What is the app extension? The app extension is the SMS in our case. Now that app extension is going to open that particular URL, and that application is going to get opened up inside the same screen. Now that notes is written inside a shared resource, a shared memory from that SMS application or the messages, what we call in iOS. From the shared resource, it's basically going to be read. Okay, we are going to perform a read operation, and we are going to read what notes are there inside that shared resource, which was written previously by the host application inside that shared resource box. And once the notes are read from that shared resource, the app extension is going to ask you for the contacts. It's going to paste inside that SMS box. And once you click on send, it's going to close it. And then again, we are going to move on to the host application. So we are exactly going to see this entire demo with a practical approach. So over here, I have my iOS device. Okay. And what I'm going to do is I'm going to open notes and I'm going to start writing some notes. So let's say I'm writing hello iOS pen testing. Okay, please ignore my spelling mistakes. And what I'm going to do is I'm going to click on three dots and I'm going to click on send a copy. Okay, and inside send a copy, I'm going to select the application called as messages. Okay, there are other applications as well. Uh, we want to send it over SMS, so we are going to use messages. And as you can see over here, inside the messages, my notes thing got copied up inside the text box. How did this get copied up? Before opening this up, my notes was written inside a shared resource and my SMS read it from that shared resource and pasted it over here. Okay, and you can see over here the messages application functionality has popped up inside the same application as the notes. Okay, there's not a different application which has opened, but it has come inside the same application. And if you put cancel, okay, or else okay, if you go on to mail, it's going to mail it as well. There are other application extensions which you can use. So this is exactly what has happened inside app extensions. So to summarize it very quickly, host application sent a request to the app extension and it has written what has to be sent inside the shared resource. The app extension opened a URL, which basically means that the application was opened and that particular application read from the shared resource. And inside, in our case, inside the SMS box, it has pasted it. And finally, when you hit the send button, the response is again going to go back to the host application and you can continue to work onto your host application. So this was it for iOS app extensions. I hope you understood how app extensions work in iOS. So that's it for this particular video. Thank you. Hello all, welcome back. So in this particular video, we are going to learn about iOS device management. So from iOS version 6, there's a built-in support for device management capability with fine-grained controls that allows an organization to control the corporate Apple devices. So what has happened from iOS version 6 is that if you get a corporate iPhone or if you get an iPhone or an iPad device from your corporate can have the exact control of your iOS device. And that is all possible due to device management. So how and what device management is and how does it work, we are going to look at it in a couple of minutes. Okay, so what happens is the user can see the installed policies inside settings, general profile and device management, and under these policies is what gives the access or what gives the right for the corporate administrators to have a hold of your particular device. So they can incorporate certain policies such as a particular application cannot be downloaded or particular application cannot be run. You can use only so much of data in so much of data in a particular day or so much of data in a particular month, etc. So these are all the different policies that a corporate administrator can set up, and a corporate administrator can install it onto your device using device management. And the iOS device basically has to incorporate and accept these particular policies. Okay, and the profiles are tied to the device ID, signed and encrypted by the MDM server, and are tamper proof. They cannot be removed without losing all the corporate data. So if you try to remove this particular profiles, these particular profiles will be removed, but again, if you remove them, all of your corporate data is also going to get removed now. Okay, so your device would become a plain device and it won't be compliant to corporate. Okay, so that's iOS device management. It helps you to know, or it helps you to manage your particular device very efficiently. So it's the demo time, and let's have a look how you can install this particular profiles. So what I'm going to do is I'm going to download the application DVIA version 2. And if I try to open this particular application, okay, uh, if I try to open this application is not going to open. Why? Because when I install DVIA, it asks me for a particular profile to be installed, which I haven't yet installed it. Okay, that's because I had sideloaded the application, and when you sideload a particular application, you have to trust that particular application inside device management. So I did not trust it yet for this particular video. And as you can see, the DVI version 2 application is verified, but it's not trusted. So once I trust the particular application, then and only then it is going to run onto my iOS device. Except for that, it's not going to run. So what I'm going to do is I'm going to trust this application. And now you can see the application has been trusted. I'm just going to go back and check it out. Yes, you can see the application has been trusted and it is verified as well. And once now, if you go inside DVIA, you can see it has been opened for us. So device management is one thing wherein a profile gets downloaded and you have to trust that particular profile in order for some applications to be running. So yes, I hope you understood what device management is and how device management exactly works. So that's it for this particular video. Thank you. Hello all. Welcome back to this new module. In this module, we are going to learn about OWASP Mobile Top 10. Now, before learning about OWASP Mobile Top 10, let's understand what exactly is OWASP, why is OWASP important, why one should follow OWASP, OWASP Mobile Top 10 2014, OWASP Mobile Top 10 2016, and then we are going to learn about some key differences between these two versions of OWASP, the 2014 one and the 2016 one. So let's start with what exactly is OWASP. OWASP, the full form of OWASP is Open Worldwide Application Security Project. It is a non-profit foundation that works to improve the security of software. So what exactly does OWASP do? OWASP basically will give you a brief understanding about all the security issues that can be found into an application. Now, the application does not mean the only the web application, but it also includes APIs, Web3 applications that are built on blockchain, cloud, mobile applications, be it Android or iOS, web applications, desktop applications, all sorts of application. Why is OWASP important? OWASP is important because it categorizes the vulnerabilities into certain groups, and these groups of vulnerabilities it categorizes into a sequential format from 1 to 10, wherein the vulnerability number 1 is the one which is most commonly found. Now, if you have been into web application testing, you might be knowing that there is a recent list which has come out, that is OWASP Web Application Testing 2021, The very recent one is 2021, wherein it has categorized from A1 till A10. There are 10 vulnerabilities which are categorized. These are the top 10 vulnerabilities which were found back from 2017 till 2021. So what OWASP does is OWASP categorizes or creates a particular list wherein the top vulnerabilities that are commonly found, be it for web, be it for mobile, APIs, those are listed from A1 till A10. Now, why should one follow OWASP? Well, one should follow OWASP because OWASP's top 10 or OWASP is going to help you and your organization to mitigate risk as well as conduct threat modeling or architectural threat analysis. And hence, it is important for your organization, and it is important to build a security expertise for your organization. Now, let's talk about mobile. So, OWASP top 10, as it has categorized for web applications, it has also categorized for mobile applications. There were two versions of OWASP that came into picture. The very first one was back in 2014 and the second one was in 2016. So that's what we call as OWASP Mobile Top 10 2014 and OWASP Mobile Top 10 2016. And the 2016 version is the very latest one. After the 2016 version, there was no such version as of this video being recorded. So let's quickly jump on to what was OWASP Top 10 2014 and what was OWASP Top 10 2016, and let's understand them one by one, and let's understand what are the key differences between them. So let me just pull up the slide, and over here, as you can see, I've listed down OWASP 2014 version and the OWASP 2016 version, and these arrow marks basically show you what is the difference between them. So let's go through OWASP Top 10 2016 because that is a very recent one and one should understand that. So for mobile applications, the notation is something different. It's not categorized as A. For mobile applications, it is categorized as M. So you will be finding M1, M2, M3 up till M10. So the very first one is called as improper platform usage, which basically means that the platform of the application was not properly used. M2 stands for insecure data storage, wherein whatever data was being stored by the application is stored in an insecure format. M3 is insecure communication, wherein whatever communication is happening between the client application, the client mobile application, and the web server or the application server at the backend is in an insecure format. M4 is insecure authentication, wherein authentication mechanisms are very much insecure. M5, as the name suggests, insufficient cryptography. The cryptography methods are insufficient or lacking best practices. M6, insecure authorization, just like we have IDOS and access control issues inside web applications. Similarly, over here, it's called as insecure authorization, wherein we have authorization issues. M7, client code quality, which basically means the quality of the source code of the mobile application is not proper. M8 is code tampering, wherein the mobile application's code can easily be tempered. M9, reverse engineering. The mobile application can be reverse engineered to find the source code and find other sensitive details from the source code. M10, external functionality, wherein certain functionalities which are not required are still inserted. So this was a complete list for OWASP Mobile Top 10 2016. Now let's check out what are the changes between OWASP Top 10 2014 and 2016. So M1 was weak server-side controls. This was replaced by improper platform usage. Insecure data storage still remains the same. Insufficient transport layer protection. The name has been changed to insecure communication. Unintended data leakage has been merged with insecure data storage in 2016. Poor authorization and authentication. Now, in 2014, authorization and authentication were categorized inside one, but these issues became quite often. So these were splitted up in 2016 to become insecure authorization and insecure authentication respectively. So uh, poor authorization and authentication was splitted into two. You have broken cryptography, which took its place from M6 to M5 to create insufficient cryptography, the name has been changed again. Client-side injection, the name has been changed to code tampering, and it's lost its place from M7 and went to M8. You then have security decisions via untrusted inputs. Well, this particular category was not present in 2016, so there's a high chance that security security decisions via untrusted inputs have been reduced by the time it came to 2016. Improper session handling has been merged with insecure authentication, and lack of binary protections has been merged with reverse engineering. So this is for OWASP Top 10 2014, the differences between 2014 and 2016. Well, to remember, OWASP Top 10 2016 should be onto your fingertips. So if any person asks you that I have found this particular vulnerability, under which category should I categorize it? You should be able to answer that you have to categorize this into this particular category. So all of the topics or all of the categories should be onto your fingertips. If someone asks you what is the position of insecure authentication in an instance, you should be able to answer that it is M4. In the next upcoming videos, what I'm going to do is I will be taking each of the category and I'm going to explain in a bit depth with proper examples. So yeah, that's it for this particular video, and I hope you are enjoying this journey of iOS pen testing and you're learning a lot. So see you in the next video. Thank you. Hello all, welcome back. In this video, we are going to start with the first category, that is M1, improper platform usage. So what exactly is improper platform usage? An application can be termed to be having an improper platform usage when the application is misusing a platform feature or failing to use platform security controls. So for example, let's say the application is not maintaining proper platform permissions, then in that case it can be termed as improper platform usage. Secondly, if an application is misusing touch ID, or let's say it's misusing keychain, or there are certain violation of guidelines, then in that case as well we can term that the application has been misusing, or the application is not properly using the platform. So it's a demo time, and let's check this out by an example. So what I'm going to demonstrate over here is improper platform permissions, how an application can implement improper platform permissions and what are the harm of implementing improper platform permissions. So for this, what I'm going to do is I'm going to go onto a web application called as DVIA, and I'm just going to go inside the info.plist file, and inside the info.plist file I'm going to scan, and over here you can see there's a key called as ns camera usage description, and the string for this is that to demonstrate the misuse of camera, please grant it permission once. This basically means that the application is asking for the device's camera to be used, and it appears to be saying that this is going to demonstrate the misuse of camera. So NS camera usage description might be an improper platform permission that has been set it up by the application. The second improper platform permission that is set it up by the application is the NS app transport security, wherein it has something called as NS allows arbitrary loads for which the value has been set to true. Okay, I'm sorry. Yep, for which the value has been set to true. Now this basically means that the application is going to communicate over HTTP, that is an insecure way of communicating, and since the permission has been set it up for insecurely communicating with the other servers, with the other application servers, we can term this again as improper platform permission, which comes under improper platform usage. So this was a short example of how you can demonstrate or how you can find improper platform usage happening inside an application. I hope you understood this, and I hope you will now be able to define whether an application is using an improper platform or not. So that's it for this particular video. Thank you. Hello all, welcome back. So in this video, we are going to learn about insecure data storage. Insecure data storage comes under the second category of OWASP Top 10 2016. Insecure data storage vulnerabilities occur when development teams assume that users or malware will not have access to a mobile device's file system, and subsequently sensitive information is stored in the devices database. So for example, let's say there's an application and this particular application has the login functionality. While registering onto the application stored the username and the password in an SQLite database file that is stored onto the mobile devices system or mobile devices file system. Okay, now the developers over here are thinking that any user won't be able to access this mobile devices file system and won't be able to grab the sensitive information. However, this is not true. Attackers or malwares do have the access of the file system, and if the data is holded by the attacker or the malware, it is very simple for them to access the particular application. Now this whole scenario comes under insecure data storage. There are other examples as well. Data can be stored insecurely in log files as well, and even there's an example of Firebase wherein if there's improper authentication of Firebase database, that too would be coming under insecure data storage. So it's a demo time and let's check out how a vulnerable application can be found and how we can find insecure data storage inside a vulnerable application. So I'm going to open the DVIA, that is damn vulnerable iOS application, and I'm going to click on the second one, that is local data storage, and I'm going to click on the first one, that is plist. Now inside plist, what happens is this particular application is going to save data inside plist file that is stored inside the file system, and our task is basically to find this plist file and find whether the data that has been stored inside this plist file is readable by us or not. So what I'm going to do is I'm going to first save certain contents in that plist file, that is test and test, and I'm going to save it, and as you can see that data has been saved successful in the plist file. Now what I'm going to do is I'm going to open Filza. Now do not worry how to download Filza. I have shown in the later sections of the videos. So do not worry that how will I be able to see this. Uh, if you want to install Filza right now, you can pause this particular video, go on to the video wherein I have shown you how to install different tweaks, and over there you will be able to know how you can install Filza. So let's continue. So in order to find the plist file, all you have to do is first you have to go inside the repository called as where. Inside where you have to go inside a repository called as mobile. So let me just search for mobile, and okay. Okay, sorry, by mistake I have entered inside containers. It's not inside containers, it's inside mobile. Inside mobile you have to go inside containers. Inside containers you have to go inside data, then inside the application folder, and you have to search over here the folder name of the application, that is DVIA version 2. So over here at the very bottom I can see it, and inside this you have to go inside documents, and over here you would be able to find the info.plist file. Now if you open this info.plist file and just expand the root keyword, you would be able to see that there are two keywords over here, that is password and username. So whatever we had stored inside the application, everything was stored in clear text format inside this file system, and if an attacker or a malware gets access of this particular file, the attacker or the malware can simply log in into the application and grab all the user details. So storing passwords and usernames in clear text inside the file system is one of the examples of insecure data storage. So I hope you understood what exactly is insecure data storage. Thank you. Hello all, welcome back. So now we are moving forward to the third category, that is M3, insecure communication. So mobile applications frequently do not protect network traffic. They may use SSL TLS during authentication but not elsewhere. This inconsistency leads to the risk of exposing data, session IDs to interception. The use of transport security does not mean the app has implemented it correctly. So what happens is your application might be communicating with your server to retrieve certain information, certain data from the server. But there's a great chance that the application is not using HTTPS connection. Instead, it can be using HTTP connection. And if it's using HTTP connection, there's a good chance that your data can be intercepted by an attacker. This can lead to an MITM attack as well. Another example of insecure communication are usage of older SSL and TLS libraries. So let's say an application is using a TLS library of version 1.1 while the version 1.3 is the latest one. So TLS library of version 1.1 might be vulnerable to many such attacks, and this could lead to insecure communication. A second example could be SSL pinning bypass. So what is SSL pinning? Now, each and every mobile application should only communicate to its destined or should only communicate to its allowed application server. Except for the allowed application server, the mobile application should not communicate with any of the server. This is what we call as SSL pinning. Now, there's a vulnerability called as SSL pinning bypass, wherein you can tell the application that you can connect with another server. And this is how exactly we take the application and we intercept all the requests that are being sent and received by the application in a burp suite. So I've created a whole video on what SSL pinning is and how SSL pinning can be bypassed, what are the different ways to bypass SSL pinning into the dynamic analysis section. This is one such vulnerability that is repeated and that is given and that can be found basically in each and every application. A third example of insecure communication could be privacy information leakage. Now, privacy information could be anything. It could be the information about the application servers, it could be the information about the developers, it could be the information about the users who are using that particular application. It could be anything. It could be any PII, that is personally identifiable information. So let's move on to the fourth topic, that is, or the fourth category, that is M4 insecure authentication. Now, certain applications implement the functionality of authentication, but most of the times this authentication mechanism is poor, or there are certain schemes that are missing inside authentication mechanism, and this allows an adversary to anonymously execute functionality within that mobile application. Now examples include weak password policy, leaking OTP in response, leaking of session IDs. So let's take an example. Let's take an example of an e-commerce application wherein you have to enter your mobile number and an OTP is generated, is triggered onto your phone number, and you have to enter that OTP. And once you enter the OTP, the application checks whether your OTP is correct or not, and it then authenticates you inside the application. It allows you to log in and allows you to perform actions. Now, what if the application, while triggering the OTP, used to send that same OTP inside the response? If that is the case, as seen in this particular image, if that is the case, wherein you can see the OTP is being leaked inside the response itself, the OTP is 8924, that is being leaked inside the response. If this is the case, any attacker could log in inside anyone's account, right? So any attacker could take any phone number, he could simply write the phone number, trigger an OTP, the OTP gets leaked in the response, enters the same right OTP that is being leaked, and it sends the request to login, and the application is going to validate it, and it's going to allow the attacker to log in inside the application. So leaking of OTPs is one such example of insecure authentication which should be prevented. So I hope you understood what insecure authentication is and what insecure communication is. And I'm pretty sure that now you'd be able to identify which vulnerabilities are inside insecure communication and which vulnerabilities are inside insecure authentication. So that's it for this particular video. Thank you. Hello, welcome back. So in this particular video, we are going to go with the fifth category, that is insufficient cryptography. Now what exactly is insufficient cryptography? An adversary can return encrypted code or sensitive data to its original unencrypted form due to weak encryption algorithms or flaws within the encryption process. So to make things shorter and simpler for you, let's say there's this application that is storing passwords and usernames inside a database file. Okay, but the application is safe from insecure database. Okay, it's not storing the password and the username in plain text. Instead, it's using a hashing algorithm in order to store that particular password and username. Now let's say the hashing algorithm used by the application is MD5. Although the application is safe from M2, insecure data storage, but it's not safe from M5, that is insufficient cryptography. Why is not safe from insufficient cryptography? Because as we know that MD5 is a weak hashing algorithm, and the hashes for MD5 are reversible and can be broken, and hence the application is not compliant with M5 insufficient cryptography. Other examples of insufficient cryptography include usage of no encryption techniques. That means that there are no encryption technique that are being used by the system or by the mobile application, and usage of weak hashing and encryption algorithms such as MD5 and SHA-1 respectively. So it's the demo time, and let's check out whether our vulnerable application, that is DVIA version 2, uses certain weak hashing algorithms or not. So for this, what I'm going to do is I'm first going to download the DVIA version 2 IPA file. Then I'm going to rename this and change the IPA to zip format. Okay, I'm going to use zip. I'm going to double click it so that I can extract the entire repo. Once I go inside the repo, there's a folder called as payload. Inside folder, you would be finding an application. I'm going to right click this and I'm going to click on show package contents. Now once I click on show package contents, you'll be able to see there's a document that is the main document for the application DVIA version 2. All you have to do is you have to go inside terminal and use a tool called as O-tool. Now O-tool is going to help us to find out whether there are certain weak hashing and encryption algorithms used by the DVIA application or not. So what I'm going to do is I'm going to write O-tool -I-V. I'm going to then take the application, paste it over here and put a pipe and write grep MD5, or let's say SHA-1 before. Okay, so we are going to grep for SHA-1, and as you can see that there are certain SHA-1 functions that are being used inside this application, and you can see the memory location of this particular function and what is the function that is being used inside this particular application. So now we can make out that DVIA version 2 is vulnerable to insufficient cryptography. Okay, now let's check out for MD5 as well. And as you can see, even MD5 is being used inside the application. So there might be some sensitive data that might be encrypted using SHA-1 and hashed using MD5, which should not technically happen. So as a security researcher, you can always ask the application owner to use strong hashing algorithms as well as use strong encryption algorithms and avoid usage of weak hashing and encryption algorithms. So that's it for this particular video. I hope you understood what is insufficient cryptography. Thank you. Hello all, welcome back. So in this video, we are going to learn about the risk categories. So let's start with M6, insecure authorization. Authorization is the act of checking that the identified individual has the permission necessary to perform the act. Authorization checks always immediately follow authentication of the incoming request from a mobile device. So examples include hidden endpoints and IDOS. So for example, let's say there's a user A and there's a user B. Now user A should not be able to view the documents of user B, and vice versa. User B should also not be able to see the documents of user A. Now if this particular thing is happening, then there's an access control issue that is going on inside the mobile application. So this should be avoided. Or let's say IDOR. So let's say user A's personal documents are available on the internet. So if I just copy the link of user A's documents and paste it on a session wherein there's no login performed, I'm still able to see the user A's documents. Now that's what we call as an IDOR, that is an insecure direct object reference. Again, that comes under insecure authorization. So such things should not happen inside an application. The second one is client code quality. Now, code quality issues are found frequently within most mobile code. The primary goal is to execute foreign code within the mobile code's address space. So, for example, what happens is, let's say there's an application and this particular application is leaking certain memory data. Now, if the application is leaking certain memory data, then the issue of client code quality persists. Or let's say the application overflows the buffer memory, okay, and this particular memory gets leaked inside maybe the logs of the application or onto the application's front end. Again, if such things happen, then it can be a client code quality issue. Let's move on to M8, that is code tampering. An adversary can modify the code via malicious forms of the applications and host it inside third-party app stores. Then the attacker or an adversary can also trick the users into installing this application via phishing emails or other social engineering techniques. So for example, let's say there's a legitimate banking application and an adversary or an attacker can reverse engineer that particular application, tamper the code with it, and uploads this particular application on a third party store. And now the attacker has run a social engineering campaign, okay, let's say a phishing campaign wherein the attacker sends you a mail stating that our application is down onto the Play Store, or our application of the Play Store has been hacked. Please use this particular link to download the new safe application. And you are a victim of the phishing email. You think that this email is from a legitimate source. You download the application, and now for you, the application is running smoothly, but at the back end, it is the tampered code that is happening. So, changing the certificate to bypass SSL pinning, or changing the API version, or tampering of the source code to perform some other malicious actions is or are all the examples of code tampering. Now, how do you prevent code tampering? You can prevent code tampering by a technique called as verifying the signature. Okay, so for example, before installing the application or after installing the application, all you have to do is you have to verify the signature of the compiled APK. So there's a process of installing an application. Before you install an application, the source code is compiled into an APK, and this APK is signed by a developer. Now the signature of the developer is very unique. Okay, it's unique for each and every developer. The application should have checks implemented stating that if the application has been signed by any XYZ signature, or the application has been signed by any XYZ party, the application is not going to run inside the mobile device. The application will only and only run if the APK has been signed by the legitimate developer or by the legitimate signature of the developer. So in this particular manner, you can stop the users from running a tampered code and or a tampered application, and you can save the users by being the victim of the attacker. So this is M8, that is code tampering. Let's move on to M9, reverse engineering. Now by default, all applications are susceptible to reverse engineering, okay, all mobile applications, especially Android applications. All Android applications can be reverse engineered very easily. Why is this the case? Because there's the source code that is converted or that is compiled to become the APK, and this particular APK is then installed onto your device. Now you can easily decompile the APK and get the source code file. So reverse engineering in Android and iOS is very simple, but how can you save from reverse engineering, or how can you protect your applications from not being able to understand by the attacker is something called as name changing. Okay, so what you can do is you can rename the function names, you can rename the variable names into something that is not understood by the attacker. Okay, and if your function names are something that is not understood by the attacker, let's say the function names are a b c d e, the attacker won't be able to know what a b c d e function does. And if the attacker won't be able to know what these function does, even if the attacker has the access to the source code, he won't be able to understand the logic of the application. So you can always save the applications reverse engineering by changing the variable and the function names. Now, certain other examples of reverse engineering include uh, reverse engineering the application to reveal information about the backend server. You can remove all the comments, you can remove all the information that can be leaking or that can help the attacker to craft a well-formed attack. You can remove the server's information, you can remove the developer's information, etc. So these are certain ways in which you can stop reverse engineering, or you can at least make reverse engineering difficult to understand. And let's come to the final one, that is extraneous functionality. So functionality that exposes information related to backend test, demo, staging or UAT environments should not be included in production build. So for example, let's say there's a hidden functionality inside an application to download configuration files. This is not required, right? This is not required. And if the attacker finds this particular functionality, he or she can download the configuration files and misuse those configuration files, right? So such functionality should not be enabled. Another example could be storing or saving all the data or showing up all the data inside the log files or the logs that are generated. Again, logs can be publicly available or publicly visible. So if the attacker gets hold of the device, he can view all the logs of that particular device. And if your application is storing too much data inside the logs, or it's storing too much data inside the logs, it's storing sensitive data inside the logs, the attacker may gain access to it. So having or storing sensitive data inside log files comes under extraneous functionality. So with this, we conclude this particular module. I hope you understood what is OWASP, what is OWASP Top 10, what are the different categories of OWASP Top 10 Mobile 2016, and I hope you understood each and every category. You should always remember these all categories. These categories should be onto your fingertips. If anyone asks you at any time of the day, you should be able to recollect it, and you should be able to give them a firm answer that these are the categories and these are some of the examples of these categories. In the next section, we are going to start with the actual pen testing of the iOS application. We are first going to start with the static analysis of the iOS pen testing. And yes, that's it for this particular video.
Hello all. Welcome back to this new module. From this module onwards, we are actually going to start with the iOS pen testing. Now, pen testing a particular application, a particular mobile application, has two aspects of it. One is called the static analysis. The second is called as the dynamic analysis. In the static analysis section, we are not going to capture the request and the response that are being sent by the application. Instead, we are just going to accept the application and find certain vulnerabilities that are present with the particular application, that are present in the source code of the application. So for example, in the static analysis, we can check out whether the application has certain hard-coded keys installed in it or not. We can check out whether the application is allowing certain insecure permissions to be used or not. We can check out whether the application is using insecure encryption techniques or insecure hashing algorithms or not.
So all of these examples comes under static analysis. And dynamic analysis, what we are going to do is we are going to capture the request and the response that are being sent by the application. And once we capture the request and the response that are being sent, we are going to play with those requests to find logical vulnerabilities or to find vulnerabilities that are present inside the application's logic. So that is the difference between static and dynamic analysis. So let's start with the first one, that is the static analysis. So in order to start with the static analysis, let's first define what static analysis is. Static analysis is about decompiling the IPA file and checking out for source code related vulnerabilities. So certain examples, as we have already discussed, include checking the info.plist file, checking out for file permissions, checking out for insecure APIs and functions that are being used. Now, to perform static analysis, you can have one way, that is the manual way, wherein you take the IPA, you decompile it, and you go through each and every file. And the second way out is using an automated tool. Now, automated tool that we are going to use over here is called as mobsf. Now, you can always go and do the manual procedure. You can manually find out the source code. You can manually decompile the IPA file, find the source code, and find the code level vulnerabilities. But that's going to take a lot of time. Obviously, you have to manually go and visit each and every line of the source code. You have to check out whether this line is vulnerable to any particular vulnerability or not, whether the logic implemented by the application is correct or not, and all of that things. While mobsf, that is an automated security framework, will help you out to find all these vulnerabilities in an automated way. So what is mobsf? Mobsf stands for Mobile Security Framework. It is an automated all-in-one mobile application pen testing framework that helps to perform runtime assessment. And a beautiful feature of mobsf is once the vulnerabilities are found by mobsf, you can download it inside a PDF format as well. mobsf is open source and it is very simple to install. So let's check out how you can install mobsf. Mobsf comes with all the three operating systems, the majorly three used operating systems. You can install mobsf inside Linux and Mac, as well as you can install mobsf in Windows as well. All you have to do is just git clone the particular repository that you can find on GitHub. You can go inside that particular repository and you have to double click or open the setup. Once you complete the setup, mobsf would be installed for you. So it's the demo time and let's check out how you can install mobsf inside your device. So over here, I'm on to github.com, mobsf, the mobsf's official GitHub repo. I'm going to copy the particular link, go on to my terminal and git clone this particular link. Once I git clone it, okay, I already have it installed. So I'm just going to go inside the directory and I'm going to run setup.sh. Since I'm onto my Mac machine, I'm going to run setup.sh. If you're onto your Windows machine, you have to run setup.bat. You have to double click setup.bat. And if you want to install this using Python, you can run python setup.python3 setup.py install. Okay, since I'm onto my Mac machines, I'm just going to run setup.sh. Even if you're on Linux machine, you can run setup.sh. Once I run this, mobsf is going to get installed for me. Now what I've done is, for me, mobsf has already been installed. So after the installation is completed, you have to run another command that is called as /run.sh. Once you run this, okay, mobsf is going to run, and over here, as you can see, for me, mobsf has been running. All you have to do is mobsf is going to run for you onto a particular URL and onto a particular port number. You have to enter that URL and the port number inside your web browser, and this would be the screen that would be displayed. Okay, now let's check out how you can analyze a particular application. Now, in order to analyze a particular application, all you have to do is click on upload and analyze. Okay, once you click on upload and analyze, you have to visit where your IPA file has been downloaded. Just double click the IPA file and click on open. Once you open it, mobsf is going to upload that IPA file, and mobsf is going to take some time to analyze the IPA file and find certain vulnerabilities inside it. So for saving time, what I've done is I have already uploaded it and I have created the report. I've uh, just displayed you the screen which MobSF would display after uploading and reviewing the application. So once your application is uploaded and reviewed, you can see over here, MobSF for the first time gives the security score. What is the file name? What is the file size? It gives three hashes, MD5 hash, SHA-1 hash, and SHA-256 hash. It gives you certain app information. What is the application name? What is the application type? What is the bundle identifier for the application? SDKs, version, platform version, minimum OS version that the application is supporting, supported platforms, what are the architecture systems, sub-architecture systems, etc. So once that is done, you can also view the security score that is 21 out of 100. So out of this security score, you can now know that this application might be vulnerable to a lot of vulnerabilities because the security score is very low. So once you do that, you also have the access to the info.plist file. So once you upload your IPA file inside the MobSF, you can just click on the view info.plist file and it's going to help you view the info.plist file. And this is the exact info.plist file which we have already seen earlier. So over here, you can just view it and you can find certain vulnerabilities such as which insecure permissions have been given, what are the minimum OS versions that the application is allowing, whether the application is allowing to communicate over an HTTP traffic or not, etc. So these are certain vulnerabilities which you can find using the info.plist file. You can go at the bottom and now you can see that there is a custom URL name that is com.highaltitude.dvi Swift version 2 that is being used along with the scheme that is being used that is DVIA and DVIA Swift. So these are certain informations that can be helpful. Now, what MobSF beautifully does is instead of manually viewing the info.plist file, MobSF is going to give you a report wherein it's going to give you a column called as application permissions and it's going to list all the application permissions over here. Whatever the application permissions are being used by the application, all of them is going to be listed over here. So as you can see, the permissions that are being used by the application is NS camera usage description and the status for it has been set to dangerous. So MobSF was detecting that this particular application is using the camera and this could be a dangerous permission that has been assigned. And what is the reason that is given? The reason is to demonstrate the misuse of camera. Please grant it permission once. So this is what MobSF does. It gives you the application permission and it lists down all of those. Secondly, what it does is it gives you app transport security. Now, app transport security basically tells you whether the application should be communicating over an HTTP server or not. And that's what MobSF has raised the flag for. MobSF has said that the severity is high and the application transport security allows arbitrary loads to be used. So app transport security restrictions are disabled for all network connections. Disabling ATS means that unsecured HTTP connections are allowed and ATS has been dissolved. And HTTPS connections are also allowed and are still subject to default server trust evaluation. And that's what MobSF declares that this permission that has been given to ATS of disabling is a dangerous permission and it should not be given. So that's what it has suggested, and you can include this into your report. Now, except for this, MobSF also gives you certain binary code analysis, which basically means that it gives you or it tells you whether certain insecure functions or insecure APIs are being used or not. So, for example, here for this particular application, uh, MobSF has given binary make use of insecure APIs and insecure APIs such as fopen, strncpy, memcpy, strcpy, printf, strlen. Now these are dangerous APIs or dangerous functions that should not be used because they might leak certain data due to buffer overflow vulnerabilities or insecure information storage vulnerabilities, and this could lead to leakage of personal data. So these functions or these APIs should not be used. Instead, secure APIs or secure functions should be used. Also, with the insecure APIs, MobSF has also given that this particular application uses insecure random functions as well, such as underscore random. Now, this underscore random is an insecure random function, and it makes use of insufficient random values. Now, over here, as you can see for both of these rows, MobSF has also declared what is the CWE, that is the common weakness enumeration ID, that is 676 for insecure APIs and 330 for random functions and secure random functions. And it has also given you what is the OWASP top 10 2016. So for insecure APIs, as you can see, the OWASP top 10 2016 is client code quality. And for random functions, it is insufficient cryptography. So you can include these vulnerabilities inside your report as well. But wait a moment, you cannot directly include these vulnerabilities inside your report without any proof. You need a screenshot wherein you can show the developer that these functions are used by the application. Okay, you just cannot display the MobSF report and ask the developer. You need a thorough proof that these functions are being used. Now, how will you get that proof? I've created a video for it later in this particular section only. So please watch that video. Inside that video, you'll be able to know that how you can get that particular proof, that you can show it to the developer that these functions are being used. Now let's continue further with the report of what MobSF has generated. Okay, I'll just fast forward this. Now, as you can see over here, MobSF has also generated that this particular application is logging certain sensitive information inside logs. And how does MobSF come to know about this? MobSF has seen that this particular application is using the function nslog function for login. Okay, so sensitive data, MobSF predicts that sensitive data might be reflecting inside the log files. So using this particular output of what MobSF has given, we can now know that if logging has been enabled, we can also check out the logs to find certain sensitive information. Now, how do you check out the logs and how do you find sensitive information? I've covered a whole video on that as well later in the section. So you can view it over there. Now, for this particular parameter, MobSF has given it as info. Why it has given it as info is basically MobSF does not know whether sensitive data is being stored or not. If sensitive data is being stored, obviously we can raise the bar. Okay, we can raise it and tell that since sensitive data is being stored inside the logs, this might be a medium level vulnerability, a medium severity vulnerability. The fourth point which MobSF has reported is binary make use of malloc functions. Now, malloc functions are functions that can lead to memory leakage. So that is the CWE ID 789, uncontrolled memory allocation. And instead of malloc, it is always good to implement calloc, that is CALLOC. That is a secured memory allocation function. So again, this can be reported uh, insecure usage of memory allocation functions, malloc. This again comes under M7 client code quality. Then you have binary use of WebView components. Now, this is again informational. This basically states that the application is using WebView, and if the application is using WebView, you can implement you can try to implement if any JavaScript related vulnerabilities such as XSS is implemented, or XSS can be exploited inside the mobile application or not. So that's the reason this is again an important point wherein we can know and we can try out certain WebView related vulnerabilities such as XSS. Now, moving forward, you have a detailed binary analysis as well. So the detailed binary analysis is whether ARC, that is automatic reference counting flag, this flag is being used or not. And if you see over here, this flag is being used. So if you can see, the status is true. So ARC is being used. Code signature, the binary has a good code signature. Whether the binary is encrypted or not, it is false, which means the binary is not encrypted. And you can see the severity over here is warning. Warning basically means the binary is not encrypted. And by default, the binary should be encrypted. So again, you can raise this finding inside your report that the binary is not encrypted. Then you have the NX bit that is set to true, the PIE bit that is set to true, the R path that is set to true. Now, R path that is set to true is again a warning. Why? Because the R path should be removed. Okay, remove the compiler option dash R path to remove @ret rpath. So rpath should actually not be set. However, rpath is being set. What is rpath? Rpath is basically run path, search path, and it is a feature that helps the attacker to execute the binary, that helps the attacker to run the particular binary. So this should not be set to true, and hence MobSF has given the warning. Then you have the stack canary that is true. So that should always be set to true. And then you have symbol stripped. This is again a binary. It's set to false. However, it should be set to true. Then you further have the file analysis. What are the different files that are being set? What are the certificate hard-coded files that are being set? What are the server locations? So if you see on this particular map, it tells you what are the server locations. The server has which domain addresses registered. So you can see domain dgcert.com, which is registered, CRT Apple, GitHub, Google, example.com, highaltitudehacks.com, etc. So these are certain domains which are being registered inside the server or the server certificate. Then you have all the other URLs which are mentioned over here. If there are any Firebase database link that has been found inside the mobile application, it would be displayed inside this. So for this particular application, there is no Firebase database link that has been seen or that has been found inside the mobile application. So hence it is not displaying over here. But if there's any Firebase database link, it would be displayed over here. Then you have all the different email addresses that are being used inside the application. And where are these email addresses? You would be finding the file for it onto the right column. So there are email addresses such as pest123, default rem at host.com, pratik at vulnerable iOS app.com, etc. So these are certain email addresses. Then you have certain trackers. So you have a Google Analytics tracker and the URL for this particular Google Analytics tracker as well. If there are any hard-coded secrets that are being stored inside the application, such as API keys or let's say session IDs that are hard-coded and saved, all those would be grabbed and would be shown over here. You would be seeing under possible hardcode secrets. Then you have all the libraries that are being used, all the assets that are being used. So you can see the files that are being used. This are PNG files, text files, the source code files, etc. So these are all the files that are being used. And then finally, we have the option to download the PDF report. So you can click on print report. And once you click on print report, okay, sorry, you can click on PDF report, and once you click on PDF report, the entire report gets generated for you. And the report is so smart that first it gives you the finding summary. So in the finding summary, you can see there are 4 high vulnerabilities which are found, 3 medium vulnerabilities, and 2 informational vulnerabilities that are found. So it is going to give you the vulnerability count, it's going to give you the file information and all of those details which we have already seen before. And you can download this particular report or directly go and take a print of it as well. So this is it for this particular video. I hope you understood how you can use MobSF and how useful MobSF is. In the upcoming videos, we are actually going to see that how you can prove that the MobSF related vulnerabilities are actually present inside the vulnerable application. So I hope you like this particular video. Thank you. Hello all, welcome back. So in the previous video, we saw how MobSF helps us to find all the static vulnerabilities in an automated way. In this video, we are going to check out how you can find the same vulnerabilities in a manual way. So from this video onwards, we are not going to rely on MobSF. We are going to find all the vulnerabilities, all the static based vulnerabilities in the manual method. So let's begin with the first one. Let's first analyze the file system. So let's understand what exactly is file system analysis first. So each application is given a unique 36 character UUID, which represents its app directory sandbox location. So maybe in the video of M1, you might have seen that we were visiting a particular directory. If you do not remember, do not worry. I'm going to cover that part again in this particular video as well. But if you remember, you might have seen that we had to go inside the application sandbox directory. And that application sandbox directory is a 36 character alphanumeric UUID. Now, this UUID is basically a unique identifier for the application. It's a unique identifier for the application's directory where all the data of the application are stored. So you can find this UUID or this application directory sandbox inside the location called as slash private where containers bundle application UUID and the application.app location. And all the data related to the application is found at private where mobile containers data application and the data UUI. So if you do not understand it right now, do not worry. We are going to have a look of this entirely in the demo section as well. Now the endpoint slash private where containers bundle application UUID and the app.app should always be checked for certain sensitive credentials. This is the directory or this is the location wherein most of the applications use to store their sensitive credentials. Now, sensitive credentials can also be found inside the info.plist file, wherein you will be able to find hard-coded API keys, secrets, and session IDs, maybe, etc. There's another file called as, or another location called as slash private where mobile containers data application data UUID. There should be checked out for local storage issues like storage of sensitive data in encrypted format and storing it in plist files. You can also check out for data protection classes such as NS file protection. So it's a demo type. And now we are going to check out how you can perform file system analysis. So to perform file system analysis, I'm going to go on to our vulnerable application that is DVIA version 2. And I'm going to go inside local data storage. Now inside local data storage, we are going to check out for the very first one that is plist. So what happens? Let's first understand what we have to do in this particular challenge. So in this particular challenge, the input entered here is saved in a plist file. Our task in this challenge is to find where this value is stored inside the application sandbox. Now, we have already seen this inside the M1 section, but do not worry. I'm going to replay or I'm going to again show you how you can find these all data. So let's start. First, let's save the username and the password. Let's say test and test inside the plist file. Now you can see the data has been saved inside the plist file. I'm going to go inside a tweak called as filza. That is a tweak which allows me to view the contents or to view the internal file structure of the iOS system. So I'm going to go inside the directory called as where, and inside where I'm going to go inside mobile. Inside mobile, I'm going to go containers, data, application. Over here, you can see this is the application sandbox directory for each and every application that has been installed inside this iOS device. So you can see there are lots of applications and you can see this application called as DVIA version 2. And DVIA version 2, at the bottom, you can see there's a 36-bit character, alphanumeric character of UUID. This is the UUID which we were talking about. So DVI version 2 in this 4E9AFA, this entire string is called as the UUID or the application sandbox directory's name. Actually, the name for this application sandbox is the UUID's name. But what Filza does is, for our understanding, it helps you to map the UUID against the exact name of the application. So it's easier for us to understand. So we are going to go inside DVIA version 2 and we are going to go inside documents. And over here you can see the plist file, the user.info.plist file, which stores all the sensitive data or which stores the sensitive data username and password, which we had stored inside the application. So this was the sensitive data which the challenge required us to find, and we have found it successfully. So with this particular challenge has been done. Let's take the second challenge, that is user defaults. Now over here the input entered is saved using NS user details NS user defaults. Sorry. Your task is to find where this value is stored inside the app sandbox. So our task is to find the details that is stored using NS user defaults. So what I'm going to do is I'm going to write certain text over here. Let's say the text is hello. Let's save it. The data has been saved in NS user defaults. And now I'm going to go inside the tweak and I'm going to, okay, let me just fast forward this. Oh, sorry, my iPhone got disconnected. Okay, so what I'm going to do is I'm going to install the tweak called as Frida. So what you can do is you can go onto this beautiful website called as iOSrepoupdates.com. Okay, iOS-repo-updates.com, and you can search for Frida, and you can just click on Frida and go at the bottom and click on install. Okay, so there will be a option to download it. So it's at perfect. Over here, I can see it's add Frida. I'm going to click on add Frida and click on Celio and click on open. Add the source. So what did we do this? Why did we install Frida? What exactly is Frida? And how do I add the source for Frida? All of these things we are going to look at the dynamic section. Do not get confused at all right now. With the completion of the course, you would be having an exact understanding what Frida is and how Frida works and why did we install this, why did we use Celio. All of this you would be getting a very brief understanding in the dynamic analysis section. So please wait till then. Till then, if you are following the guide, please follow it religiously. For all understanding, you can view the dynamic section sections and dynamic section videos and you would be able to understand. So I'm going to install Frida over here. So let the Frida installed, and once Frida gets installed, what I have to do is I have to write a command called as frida-ps-ua. Now this command basically is going to list down all the applications that are installed on my iOS device. So you are going to, or Frida is going to list down all the applications that are installed in the iOS device. And over here, as you can see, there are 4 applications that have been installed in my iOS device. One is DVIA version 2, one is Filza, one is Safari, and one is Leo Nightly. Now, Frida-ps-ua will only show those applications that are running. Okay, so your application should be running in the background. Then and only then Frida-ps will be able to show you up. Since my DVIA version 2 has been running, hence it is showing up. Now I'm going to use a tool called as objection. Again, what objection is, why am I using this tool? Everything in detail is explained in the dynamic analysis section. There's a whole video created just for objection and what is objection and how objection can be used. So right now, just check the command and just check out how we are able to find the NS user defaults. You would be able to understand about objection in detail in the dynamic analysis section. Okay, so I'm going to write objection dash dash catch it, and I'm going to provide the DVIA version 2's identifier and write explode. What is this command? Again, please wait for a while. You would be able to understand it. And now as you can see, my DVIA version 2 has been installed. I'm going to write iOS NS user defaults and I'm going to write explore. Now this particular command iOS NS user defaults explore is going to help me to get the default value that has been stored using NS user defaults, or the sensitive keywords or the sensitive passwords or sensitive data that has been saved using NS user defaults. This particular command is going to help us grab those details. So once you hit enter, you will be able to find a lot of data that has been stored using NS user defaults, and all you have to do is go find the data that we have used. So you can see there's a parameter called as demo value over here, for which the value is hello. So you can see hello is stored inside demo value, and this was what we had stored inside our local data storage using user defaults. Now, if I write over here, let's say something called a secret credentials. Okay, let's write secret credentials and let's save it in NS user defaults. And I rerun the command. Okay, so I'm going to rerun the command, that is iOS NS user defaults. And now, as you can see, the demo value has been stored to secret credentials. So this was it for this particular video. I hope you understood how you can perform file system analysis and find sensitive details that are being stored using the application. So I hope you understood this video. Thank you. Hello all, welcome back. In this video, we are going to learn about app log analysis. In the MobSF video, we saw that MobSF had found a vulnerability stating that the application is making use of the logging function to log certain data inside its application logs. In this video, we are going to exactly check out how you can view these application logs and how can you determine whether the application is vulnerable to storing sensitive data inside application logs or not. So in order to check out the application logs, all you have to do is you have to visit or view the device logs. Now to view the device logs onto your Mac machines, you can go on to Xcode, you can go on to device and simulators and view the device logs of any device you want. Then you can grab the device logs by the application name and you would be able to view only the application logs for that particular application. In case you are not using Mac machines, and in case if you are using Linux, you can download a tool called as iDevices logs, and you can use this command line utility using a pipe and then gripping your application name. This will help you to view all the application logs that are generated by that particular application. So it's the demo time, and let's check out how we can exactly find the application logs using an example. So in this particular demo, I'm not going to use our DVIA version 2 application. I'm going to use another vulnerable application that is called as iGoat. Now you can visit the iGoat's official repository. iGoat is an application that is intentionally created vulnerable by the very famous OWASP team. And all you have to do is go onto its GitHub repo and go onto its documentation. Inside its documentation, you would be able to find the reference of how you can install iGoat onto your jailbroken device, your non-jailbroken device, and how to set up the iGoat server onto your Mac machines. For me, I have already installed iGoat over here, and if I open the application, I would be able to see iGoat as well. So iGoat basically has a lot of different vulnerabilities that you can practice and that you can learn. So some of them include data protection, memory management, iGoat keychain analyzer, broken cryptography, authentication issues, misconfiguration issues, etc. What we are interested currently is in side channel data leaks and inside device logs. So we are interested in device logs. So let's start. What is our task? Let's find out. So in this exercise, we are trying to extract sensitive information from logs. Many times developers forget to remove the logs which are added during development. In this exercise, what we have to do is we have to check the logs for any financial data leakage. So we understood what our challenge is. Our challenge is to find if any sensitive details are being logged inside the application logs or not. So for that, we have to start the challenge. So we are going to click on start. And once you click on start, okay. Uh, Meanwhile, before we click on start, let's first check out the device logs. Let's go and visit the device logs. So for that, I'm going to go on to my Apple configurator. You can go on to Xcode as well. This is another method to find the device logs. Inside Apple Configurator, you have to select your iPhone that is connected with your Mac machines. All you have to do is go on console. Once you go on console, all the device logs are seen over here. There's a search feature as well inside this console so that you can search for a particular application logs as well. So now we are going to start this particular exercise. Let's click on start. And once we click on start, we have to enter the CC number, the CCV and the pin. So let's enter any dummy data. So let's say we're entering 4 times 8, 3322 over here, the CCV number and the pin code as well. So at the background, you can see there are a lot of logs which are being stored. You can clear it, but clearing it won't stop all the different logs to be entered. And all you have to do is you have to go inside the application and click on submit. And as you can see, we have successfully submitted it. Now you have to find whether any sensitive details has been leaked over here or not. To find inside device logs, it's going to be a tedious task. So what I'm going to do is I'm going to search for certain parameters. And what I'm going to search is I'm going to search for 88. So as you can see, CC number has been leaked. CVV number has been leaked as well. Now let's search for 1234 and let's see if the pin number has been leaked or not. And as you can see over here, the pin number has been leaked as well. You can also search for iGoat related logs as well. And all the logs which are being seen over here are related with iGoat. And you can see the CC number, CVV number, and the pin number has been leaked inside the application logs. Okay, you can grep for anything, whatever you want. If you grep for the application name, all the logs related to the application name will be displayed over here. If you grep for certain parameter, let's say CC number, all the all the logs related to CC number will be displayed as well. So this is how you find sensitive data is being leaked inside application logs or not. I hope you understood this video. I hope you understood how you can analyze the application logs to find sensitive details. So that's it for this particular video. Thank you. Hello all, welcome back. In this video, we are going to learn about hard-coded credentials. Many developers hard-code sensitive information such as secret keys, tokens, API keys, session IDs, etc. inside the source code of the application. Our motto is to find these hard-coded credentials and to exploit them up. If we are successful in exploiting them up, we might have a high-level vulnerability which can be reported to the application owner. So in order to find hard-coded credentials inside the application, we can grab for terms such as secret, crypt, private, token, etc. Applications might be using third-party backend systems as well. So for example, let's say an application is using a third-party database, that is a Firebase database for an instance. We can then analyze .json and .xml files to find configuration credentials or to find the configuration endpoints as well. Once we get these configuration credentials and endpoints, as an attacker, we can directly communicate with the backend database or backend systems and perform certain malicious actions onto it. Many applications might also contain certain hidden features, such as an admin dashboard. So let's say an application is present and the application is only allowing normal users to log in. However, by going on to a particular endpoint, the admin users can also log in and endpoint as well. Now, this is an hidden feature which the normal user might not know. However, searching for keywords such as admin, develop, debug, fake, test, etc. will give the access to such hidden endpoints. There can be API keys as well, which are stored inside the source code of a mobile application. You can find such API keys inside .plist file. So, for example, Google services-info.plist file might contain certain juicy API keys related to Google services. So now it's the demo time, and let's check out how you can find these hard-coded keys. Now, in order to find the hard-coded keys, all you have to do is upload your application onto MobSF, and MobSF is going to give you the hard-coded key, and it's going to display it onto its dashboard. There are other ways to find hard-coded keys as well. You can reverse engineer the application, and you can manually grep it for some keywords and then find the hard-coded API keys. Oh here I have an application wherein a possible hard-code secret has been intercepted by MobSF. So the secret over here is bank password 123, and MobSF has identified it and displayed it onto its dashboard. So in such a way, you can find sensitive data, or you can find sensitive hard-coded credentials from the application. So that's it for this particular video. Thank you. Hello all, welcome back. So in this video, we are going to learn about SQLite database core data. Let's first understand what exactly is core data. Core data is a framework for managing the model layers of objects in your application. Core data can use SQLite as its persistent storage database. Now, to make things simpler for you, developers generally use SQLite database in order to store some sensitive information or information that is related to the application. So let's say if an application wants to store the information about a user's profile, let's say the first name, the last name, the address, the credit card number, developers generally use SQLite database as their primary database source and store all the information inside SQLite database. This SQLite database file is stored inside the file system of the iOS device. Now, if the developer has stored the profile information or the private information of a user in plain text, any attacker can view this SQLite database file and would be able to extract these information. And if that is the case, congratulations, we have found an insecure data storage vulnerability. SQLite core data can be found inside the path that is private, where mobile containers data application, application ID, library, application support. I've written the path over here. If you do not remember, you can screenshot this particular slide and add it onto your notes section so that you remember it later on. So it's a demo time, and let's check out practically how we can find this particular vulnerability. So for this, I'm going to go inside DVIA version 2, and I'm going to go inside local data storage and core data. Over here, you can see there's something called as name, email, phone number, and password. Let's write certain information over here, core data, phone number, and a password, and let's save the data inside core data. Once I save it, the data has been saved successfully. Now I have to go inside my filter and go inside where mobile containers data inside application. I have to search for the application UUID, that is DVI version 2. I have to go inside library. Okay, inside library, application support, and over here you can see the database file has been created. Over here you can see the model.sqlite database file has been created for us. We can open this model.sqlite database file, and you can see there are 4 tables. The tables are Z user, Z metadata, Z model cache, and Z primary key. Let's first go to the Z user table, and inside the Z user table you can see all the data has been saved over here. You can go inside Z metadata, and this are other sensitive data. You can go inside Z model cache as well, wherein you would be able to find other sensitive data, and primary key as well, wherein you would be able to check out how the database has been created and what is the primary key for each and every command that was created. So this is how you can find out sensitive data, if it is being stored inside SQLite or not. Now, in order to mitigate this vulnerability, what the developer has to do is the developer cannot directly put the data inside the SQLite database. Instead, the developer has to encrypt the data and then store it inside the SQLite database. If the encryption technique is not done, any attacker can check out the database and can retrieve the sensitive information. Again, the developer has to make sure that the encryption technique is not the one that is a weak encryption technique. The encryption technique should be strong enough so that it is not decryptable by any attacker. So that's it for this particular video. I hope you understood how you can find sensitive data from SQLite database. Thank you. Hello everyone, welcome back. In the previous video, we saw about SQLite databases and how developers use SQLite databases to store sensitive information. However, SQLite databases are not the only databases that are used by the developers. Developers might use other databases such as YAP databases. These databases can also be used to store sensitive information inside them. In this video, we are going to look how you can find other databases and the sensitive data that are being stored in these databases. Now you can find such other databases inside the repository private where mobile containers, data application and application ID. Once you are inside this particular repository, you can run a simple find command such as find dot slash dash name dot SQLite or dash name dot DB. This particular command is going to help you to find other databases that are not regarding the SQLite databases. So it's the demo time, and let's check out how you can find sensitive data that are being stored inside other databases. So for this particular video, I'm going to use the DBI version 2 vulnerable application. Okay, so I'm going to go inside the DBI version 2 application and I'm going to go inside YAP database. Okay, first, instead of going inside the app database, let's check out about real database. So let's understand what are challenges. The challenges, the input entered here is saved in a real database. Our task is to find whether data is stored in the application sandbox. So we are going to store some sensitive data inside the real database. So what is the sensitive data which I'm going to store? Hello, hello, and I'm going to save it inside realm database. What I'm going to do is, as discussed, we are going to go inside the application, the UUID, and inside documents. Inside documents, you can see there's something called as default.realm. If you open the default.realm file, okay, you would be able to see the realm database. Now, secondly, let's understand how you can find out the couch database. So the challenge over here is the input entered here is saved in a couch-based light database. Our task is to find whether value is stored inside the application sandbox. So again, over here, I'm just entering the username and password, that is hello, hello, and I'm going to save this inside a couch database. And again, if you go inside the application support file and the couch-based light, over here, you would be able to see the couch database. If you open it, over here, you can see the sensitive information has been stored inside the couch database. You have to find the exact column file, the exact table where the couch database has been stored. So inside SQLite master, you would be able to see the database has been stored over here. Now let's understand the third one, that is the YAP database. Over here, again, we are going to enter the sensitive details as hello, hello, and we are going to save it inside YAP database. And you can see the YAP database file has been created as well. Now the extension for YAP database file is .SQLite. And if we open the YAP database file, you can see the YAP database, the data is being stored inside the YAP database file. So this was it for this particular video. I hope you understood that there are various different SQLite databases file that a developer can use, and it is possible that each one or any one of this database file might contain some sensitive information. So I hope you understood this particular video. Thank you. Hello everyone, welcome back. In this video, we are going to talk about Firebase real-time databases. So if you remember in the MobSF video, MobSF had given us a column wherein they would include all the Firebase database URLs that was found inside the application. Now let's talk about it and let's check why MobSF is going to give us this vulnerability and how is this vulnerability profitable for us. So let's first understand about Firebase. Well, Firebase is a NoSQL cloud-based database that has been developed by Google. The database is stored in JSON format and synchronized in real time. So if I add a data over here right now, if that application is using a Firebase database, in real time, it's going to get stored inside the cloud. Now, If you find a Firebase string, there might be a chance of having a misconfiguration inside that Firebase string. So all we have to do is we have to visit that Firebase database URL and append /.json in front of the URL. If the response is permission denied, that means the Firebase database URL is properly configured. While if the response is something like null or there's a bunch of JSON data that is being seen, this means that the database is misconfigured and all the storage or all the data that is stored inside the database is publicly available and is having at least read access. And this is the reason why MobSF basically gives you this particular finding. So it's the demo time and let's check out how exactly you can find this particular vulnerability. So here what I'm going to do is I already have a Firebase database URL from a CTF. Okay. So I was playing a capture the flag thing and I found this Firebase database URL. So I'm going to paste this Firebase database URL only and I'm going to append whatever we had seen in the PPT, that is /.json. So once I append /.json, let's first load this database manually without appending anything. And once you load this up, you can see that this project does not exist or you do not have permissions to view it. So basically this project does not exist or I am not an authorized personnel to view this project. However, if I append /.json in front of this, okay, and let me just append it /.json. And if I load it over here, now you can see that we did not get the error code of permission denied, except we got a particular flag. And the secret of this flag is a bug is never just a mistake. It represents something bigger, an error of thinking that makes you who you are. So this meant that this particular Firebase database was publicly available and a bunch of JSON data was available for us to see. So whenever you find any Firebase database URL, it is a good thing to note that if you append /.json and if you are able to get the JSON format or some data in JSON format, then there's a misconfiguration with the Firebase URL and you can report it. This would be coming under M2 insecure data storage. I hope you understood what exactly Firebase is and how you can find such misconfigurations inside the application. Thank you. Hello all, welcome back. In this video, we are going to learn about iOS keychain and how developers make mistake while storing sensitive data in iOS keychain. What exactly is keychain? I've made a whole video on it. You can find that video inside the iOS basics section. In this video, we are going to learn how you can exploit the iOS keychain to find sensitive data. Now, developers generally use keychain to store sensitive data. Even Apple recommends to use keychain to store sensitive data or sensitive secrets. But sometimes developers do not store them properly, and this leads to the leakage of such secrets. Now, how can you find such secrets? By using a command called as iOS keychain dump, which you can find inside the objection module. So it's your demo time, and let's check out how you can perform iOS keychain dump and find the secrets. So for this, I'm going to first start the Frida inside my iOS device, and I'm going to list all the applications that are being opened. The application which we want to be open is the DVIA version 2, and I'm going to use objection dash dash gadget and the identifier for DVIA version 2 and explore. Once I did this, my DVIA version 2 objection has been hooked with DVI version 2. I'm going to go inside local data storage and inside keychain. Now I'm going to store some sensitive data inside keychain. So let's say hello and hello admin, and let's save this inside the keychain. Okay, so before saving it, once I save this inside the keychain, I'm just going to type iOS keychain dump, and you can see that when I wrote iOS keychain dump, the value for hello admin assassins was displayed inside my keychain dump. You can also see that my Apple email ID and my Apple password is also being displayed inside the keychain. So this is how you can find out what sensitive information is being stored inside keychain by using this simple command of iOS keychain dump. So I hope you understood how you can find sensitive data. Thank you. Hello all, welcome back. In this video, we are going to learn about iOS UI pageboard. So what is iOS UI pageboard? UI pageboard enables sharing data within applications. So it is an inbuilt feature in iOS that helps users to share data from one application to another. There are two types of pageboards. One is the system-wide pageboard, which enables users to share data within any application. The second one is a custom pageboard, which helps users to share data within any application that is having the same team ID. An application can also prevent its users to copy sensitive data to the clipboard, which is recommended. So every application should have this feature which disables the user to copy any data. Custom pageboards can be created using pageboard with name, create, or pageboard with unique name. This should not be used as these are depreciated since iOS 10. So from iOS 10, custom pageboards are being depreciated and applications should not use it. So what we are going to do is we are going to take a demo and we are going to see how pageboards are vulnerable to sharing of sensitive data. So as per the general policies, each and every application might be having a login field or some private data that could be seen onto the application. Now, applications should restrict the users from copying the sensitive data. So, so how does the application would do that? Whenever the user tries to copy any sensitive data, the application should disable it. So we are going to check out whether this application is going to allow the users to copy the data or not. So for that, I'm going to visit my DVIA, that is damn vulnerable iOS application. And inside site channel data leaks, I'm going to click on pasteboard. So once you click on pasteboard, let's understand the challenge. So the challenge says when you copy some text in iOS, it goes inside a buffer known as the pasteboard item. The issue is that it is possible for other applications to get the data stored in this buffer. Your task is to enter some data in the text fields, copy them using the cut copy paste feature in iOS, and write an application that can fetch the data from this pasteboard item. You also need to understand why you cannot copy the data from the CVV field and learn how to code it. So what happens is once you copy the data from an application, another malicious application could read the data from the pasteboard's buffer, and this should be avoided. So in order to do this, in order to complete the challenge, what we are going to do is we are going to write some data. Let's say hello. Inside credit card, we are going to write hello, and inside CVV, we are going to write hello. And once we have saved it, okay, we are going to select it and we are going to copy it up. Okay, so for example, I'm going to select the first one and click on copy. Now I'm going to go on back onto my terminal and I'm going to write and I'm going to again start the objection by first checking out what is the identifier of my application, and then I'm going to run objection dash dash gadget and explode. Once I do this, my application is going to get open and I might have to perform the entire task again. So I'm just going to fast forward it. And now I'm going to write over here iOS pasteboard monitor. So this is basically going to monitor my pasteboard. And if I copy something that is very sensitive, it's going to display it on the screen. So as you can see, I copied a word called as hell and it has displayed on the screen as hell. Now let me copy something else. And again, as you can see, it has copied it up. Now I'm going to copy hello. Hello, it is being copied. However, from the UID section, from the CVE section, it is not copying anything, and in the buffer, it is not storing anything. So this is what we called as the insecure pasteboard, which should be avoided in each and every application. So if you find this vulnerability, you can always report it. The severity for this could be informational or low, depending on which type of application it is. I hope you understood this particular video. Thank you. Hello all, welcome back. In this video, we are going to learn about iOS web views. So let's first understand what web views are. Web views are basically a functionality while developing iOS applications to bring websites to your iOS applications. What web views exactly does is it creates or generates or loads a particular website directly inside your iOS application so that you can directly interact with the website. But with the website comes JavaScript. And if the JavaScript is vulnerable, then there's a good chance that we can execute JavaScript based vulnerabilities inside our application. A good example of JavaScript based vulnerability is cross site scripting. There are three types of web views that are present in iOS. The first one is UI web view, the second one is WK web view, and the third one is SF Safari view controller. Let's understand all of these three one by one. Let's start with UI web view. UI web view was deprecated starting from iOS 12, and it should not be used by any of the developers. Why it should not be used is because JavaScript in this by default cannot be disabled. So you cannot disable the JavaScript inside UI web view. Now let's come to the second one, that is WK web view. Inside Java, inside WK web view, JavaScript is enabled by default, but it can be disabled using JavaScript enabled property. JavaScript can open windows automatically. This particular property can be used to block opening of new windows. And there's a new flag called as has only secure content. This particular property can be used to verify resources are received using encrypted communications. So WK Web View basically provides a lot of good features, and these features help us to save against JavaScript related attacks. So, for example, let's say if you want your web view to not implement any JavaScript, you can disable the JavaScript by using the JavaScript enable property. So let's say if there's a static website and you want your users to only view the static website and they cannot perform any JavaScript related functions or JavaScript related functionality, you can disable the JavaScript. JavaScript can open windows automatically. This will help you to block any new windows or any new pop-ups that can be created using JavaScript. And the third one has only secure content. This particular property is going to help you to check out whether all the resources are being transmitted using the encrypted communication or not. Now let's talk about the third one, SF Safari View Controller. An SF Safari View Controller, JavaScript cannot be disabled by default. JavaScript or this particular web view also shares cookies and website data with Safari, and the user's activity and interaction are not visible to the application. So these were the three different types of web views that I implemented or that can be implemented in iOS. And it's the demo time. And let's check out how we can have a JavaScript related vulnerability inside a particular application. So for this, what I'm going to do is I'm going to go back to our application of DVIA version 2, and I'm going to go inside the web view issue. And over here, let's first understand what are the different challenges which we have to sort out. So client-side injections occur when the input to the application is not validated properly. Because the code is injected on the client side, it is possible to call native functions in the device and perform malicious activities. So now we have understood about the challenge. So let's understand and let's start with the challenge and let's check out how we can implement the challenge. So over here, the text field below takes an input name, adds it to an HTML file and displays it to you in the UI web view below. Your task is to perform the following tasks via injection. So what are the tasks? We have to perform an injection to show a simple alert with the message, hello world. So let's start with this. So what I'm going to do is let's first write a JavaScript based payload, that is an XSS payload, that is script alert. And over here, let me put 1, 2, 3, 4, 5, 6, 7, 8, 9. And let me just close the script tag and let's hit enter. And now as you can see, we got an JavaScript alert box over here that displayed the content 1, 2, 3, 4, 5, 6, 7, 8, 9. So this proves that our UI web view or our web view is vulnerable to JavaScript based attack, specifically the XSS attack. So this was it for this particular video. I hope you understood how web views are dangerous, and using web view you can implement any JavaScript based attack. So yeah, that's it for this particular video. Thank you. Hello all, welcome back. In this video, we are going to learn about iOS hot patching and forced updating. Developers can remotely patch all installations of their app instantly without having to resubmit the application to the App Store and wait until it's approved. This is what is called as iOS hot patching. Each and every application should be forced updated. Now, why is this scenario? Why each and every application needs to be forced updated? The answer is whenever an application is updated, there are certain functionalities or certain fixes or certain security issues that have been implemented, and hence the user should always be running the latest version of the application. It is the duty of the application owner to make sure that their users are running on the very latest version of the application. If the application is running below or latest version, the application should not open inside the user's iOS device. So for example, let's say there's an e-commerce application and the version that a user A is running is version 1.0.0. The latest version that was developed by the application developer is version 2.0. Now, the application developer should make a functionality or should make certain arrangements so that if the user is not updating the application from 1.0 to 2.0, the application won't be running. Instead, there would be a display message stating that this application has been updated. Please update your application from the App Store in order to run. So this is what we call as iOS hot patching slash enforce updating. Each and every application should be enforced to be updated to the very latest version. Now, how can you find whether the application is vulnerable to enforce updating or not? Simply download an older version of the application and check if it allows force update or not. So it's the demo time, and let's check out about enforce updating. So as you can see, this is one of the screenshot wherein this application requires iOS 12.0 or later. Now, when I say enforce updating, that does not only mean the application's version, it also means the iOS version as well. So for example, let's say if there's a minimum operating system that has been set it up by a device to, let's say, iOS 12 in this particular example, and if on iOS device that is running on, let's say, iOS 11 is trying to download that particular application, the application should show up an error stating that the minimum requirement is iOS 12. Now, each and every organization should set up a baseline that which minimum iOS version would our application be supporting to. In today's case, as of today, the general standard that many organizations are following is the iOS 14. So iOS 14 minimum is the required version of the iOS device in order to install a particular application. So it's a demo type and let's check out. Okay, so for example, I'm going to open iGo Swift and I'm going to open this using Filza, and inside Filza, I'm going to extract the package. Once I have extracted the package, iGo Swift has been installed inside my device. Now, as you can see over here, iGo Swift is not running. Why? Why is it not running? Because this version of iGo Swift, which I had installed, was at least supporting iOS 16. Okay, so basically, iGo Swift, which I have currently installed, is supporting iOS 16. So minimum operating system that is required for iGo Swift for this particular iGo Swift is iOS 16. However, my device being on iOS 15.7.2 is not running this particular application. So as soon as I try to open this particular application, as you can see, the application gets an error and it gets closed up. So this is how the developers need to update, or the developers need to provide the functionality inside the application, that the minimum operating system version should be implemented. And if the iOS is running on is running below than the minimum operating system required, then it should not be allowed to open. So I hope you understood what a hot patching and force update means. Thank you. Hello all, welcome back. In this video, we are going to learn about how you can test application memory for sensitive data, or how you're going to find sensitive data that are being stored inside the application memory. So somewhere or the other, sensitive data is definitely going to get stored inside the memory. And we as hackers or as pen testers are going to retrieve this sensitive data. Now, what is the process of retrieving the sensitive data? We will first dump the memory of the application using objection or freedom. The second step is to dump the memory using strings memory, and we are going to save this particular file inside strings.txt. Once this is done, we can open the file inside any text editor and we can try to find the sensitive data that has been dumped inside the memory. So it's the demo time, and let's check out how we can perform this. So for this, I'm going to use a tool called as Frida dump. Before, I'm going to go and check out what is my identifier. Since we are going to check for DVIA version 2, we are going to use that. That is DVIA version 2 and the identifier. We are going to run python 3 freedom.py/u -s, that is the DVIA version 2. Once you enter this command, what Frida dump is going to do is it's going to dump the sensitive memory from the application, and it's going to store inside a particular file. So you can see Frida dump has been started, and Frida dump is going to take some time. Before Frida dump takes some time, what I've done is I've taken certain screenshots, which I'm going to display over here. So once Frida dump has started dumping the memory, it creates a particular txt file. You can open this particular txt file and you can search for sensitive keywords such as password. So here I have searched for password, and as you can see, I've found over here this is a secure password. Okay, you can also search for other terms. Okay, you can also search for other terms such as passwd, and you can see an instance variable name passwd has been found. So you can see over here we have started with the memory dump, and once the memory dump is completed, you can just open the txt file and all you have to do is search for keywords. Once you find the keywords, you will be surely able to find some sensitive data that has been dumped inside the memory. So that's it for this particular video. I hope you understand how we can extract sensitive contents from the memory. Thank you. Hello all, welcome back. In this video, we are going to learn how you can find insecure functions, insecure APIs, insecure memory allocation functions, etc. So in the very first video, if you remember, MobSF using an automated scanner gave us that our application DVIA version 2 was vulnerable to insecure functions, insecure APIs. If you remember, in that particular video, I said that we cannot directly give the MobSF report without verifying whether MobSF has actually found this or not. So in this particular video, we are going to verify whether these functions that MobSF had reported previously are actually found inside the application binary or not. So in order to do that, it is very simple. On the left hand column, you can see the insecure functions, while on the right hand column, you can see what command you have to run in order to get those functions. In order to do this, it is pretty simple. All you have to do is use a tool called as OTool. You have to write -iv and you have to give the application binary. You have to then pipe and grep for whatever function you want to grep. So let's say you want to grep for weak hashing algorithms such as MD5 and SHA-1. You can simply write MD5 SHA-1 after the grep command. Let's say you want to find random functions that are insecure. You can grep for random functions. You want to find for insecure memory allocation functions, then you can grab for memory allocation functions as well. There are vulnerable functions. Over here, I have mentioned all the vulnerable functions. In the command section, you can use any vulnerable function and you can just write besides the grep function. So you can take a screenshot of this particular slide so that you do not miss any random function in future. So it's the demo time, and let's check out how we can test for insecure functions. So what I'm going to do is I'm going to write otool dash I dash v. Okay, it's small v, not the capital one. Uh, I'm going to give the applications app binary, and I'm going to grep for, let's say, MD5. So let's first grep for MD5. And as you can see over here, we have listed down all the functions where MD5 function has been used. On the very left hand column is the memory space, and on the right, the function that is being used using MD5. Similarly, you can search for SHA-1. You will be able to find all the functions, and you'll be able to find that SHA-1 has been used. You can similarly search for random functions using RAND, and you can see that there are various insecure random functions being used. You can search for malloc as well using malloc, and you can see that even malloc is being used instead of calloc. You can then search for all the vulnerable functions. So for example, I'm taking over your getas, and you can see that getas is being used. You can also check for memcpy. You can check that memcpy is being used, and you can then go on to check all the other random or all the other insecure functions. Okay, so over here I have checked for str and cpy. I've checked for print, etc. So this is an example of how you can check for all the different insecure functions. If you find all these different insecure functions, you can take a screenshot of it and you can paste it inside your report and report it to the application owner. So that's it for this particular video. I hope you understood how you can find all the different insecure functions. Thank you. Hello all. Welcome back to this new section. In this section, we are going to start with the dynamic analysis of the iOS application. In the previous section, we learned about the static analysis of the iOS application. We learned which vulnerabilities would be covering inside the static analysis of the iOS application. In the dynamic analysis, we are going to capture the request and the response that are sent and received by the iOS application. We are going to play with this request. We are going to play with the functionality of the iOS application, and we are going to try to break the functionality of the iOS application. Let's start with the dynamic analysis. But before we start with the dynamic analysis, let's first understand certain basic terminologies. Let's first start with tweaks. What are tweaks? Tweaks are often used to bring extra features or customization options to your device. These are applications that can be installed using root privileges of the iOS device. One important thing to note over here is root privileges. Root privileges to the iOS device can only be given if your device is jailbroken, which directly means that you require an jailbroken device in order to install tweaks. In iOS pen testing, tweaks are going to help us bypass a lot of issues, which we will be looking in the coming sections. To give you an example, let's say there's an e-commerce iOS application which authenticates a particular user based on their Face ID. As an iOS pen tester, you want to bypass this Face ID mechanism and you want to check whether the application is still allowing you to log in inside the application or not. In order to do this, you would require a tweak called as Frida to be installed. Now, Frida can only be installed if your device is jailbroken. Why you require a jailbroken device is because these tweaks can only be installed using a third-party app store. Now, this third-party app store can only be installed onto your device if your device is jailbroken. So it's a chain. Your device needs to be jailbroken. If your device is jailbroken, you can install a third-party app store. And if you install a third-party app store, you can install the different tweaks. In our example, we require Frida to be installed. Once Frida is installed, we have a switch which is going to disable the Face ID detection. And if it disables the Face ID detection, if we are able to bypass it, congratulations, we have got a vulnerability. Now let's move forward. Let's understand what exactly is substitute. Now, if you would have referred my jailbroken video that was prior video, you would have known that there are three applications that gets installed. One is the Ballerine application. That is the application using which our device is going to jailbreak. Once Ballerine installation steps are completed, there would be two applications that would be downloaded. One is the Celio and one is Substitute. Let's first understand what exactly is Substitute. Substitute is a default application that gets installed when the device gets jailbroke. This particular application allows to fine tune and control tweak injection. So what Substitute basically does is Substitute allows you to install tweaks, and not just allows you to install tweaks but also manages them. So if a tweak is generating a problem or it's crashing the iOS device, Substitute is the one which is going to block that particular tweak and help your iOS device get secure. It attempts to prevent processors with memory limits from crashing as well. So that basically means that if an application or if a tweak is having a memory limit and if it's going to get crash, Substitute is the one that is going to save that particular application. Now let's come back to Celio. So if you would have jailbroken your device using Paladin, you might have noticed that Celio gets installed. If you have not jailbroken your device using Paladin, but if you have jailbroken your device using maybe Uncover or Checkrain, there might be Cydia which might be installed inside your iOS device. Do not worry. Cydia and Celio both are third-party applications. Now, Cydia and Celio both are graphical user interface of APT for iOS. That is, they enable users to install softwares that are not authorized by Apple on their jailbroken devices. These are third-party app stores from which the tweaks are going to get installed for us. Some jailbroken devices might have Cydia, some might have Celio, or there's a high chance that some jailbroken devices might have neither, but a third-party application. Do not worry at all. The tweaks which we are going to install in this whole course, these tweaks can be installed using any third-party application software. So do not worry about that. For me, I'm going to use Celio. If you have Celio, it's well and good. If not, the steps are again the same. For Cydia as well, the steps are same. Even the interface for Cydia and Celio is almost the same. So it's the demo time and let's check out. So first let's understand about Substitute. So as you can see, Substitute has been installed into my jailbroken device and you can see the tweak injection is enabled. So if you enable tweak injection, only then Substitute is going to allow you to inject tweaks. You have other features as well inside Substitute. Inside Substitute, you can enable or disable tweak injection. You can enable log file. There's jetsam operation mode, which you can choose the value for. You can share the crash data uh, with with the creators of Substitute or not. And then there's the credit section, and then you have clean crash data in order to clean the cache as well. Inside settings, if you go, there would be something called a substitute, and over here as well, you would be able to find the same options. Now over here, you can see there's something called a Celio. Inside Celio, you have four things. One is featured, wherein all the featured tweaks are shown over here. These are all the different tweaks that are featured and that are used widely by the community. Then you have something called as new, inside which all the new packages that are being installed would be shown over here. You have sources. Now, how does this tweak injection exactly work? Let me give you a brief for it. Now, developers from all over the internet, all over the world, enable you to install tweaks. All you have to do is you have to copy a specific URL and you have to add that particular source inside your tweak source. It is similar of how you can install a particular application in a Linux system. You add the source of that particular application inside the sources file, and then you just run apt get and the application name. Similarly, over here, you have to add the source, which source you want to download that particular tweak from. And you can, once you add the source, you can search that package or search that tweak inside the search section. So over here, you can add the source. This is the command to add the source and then you can install it. Now, in order to find the sources, all you have to do is you can go on to iOS repoupdates.com. This is a wonderful, wonderful website. Whatever tweak you want to install for, you can just search it over here. So let's say I want to install a tweak, let's say called as Frida. And once I hit on the search option, it's going to give me all the details related to Frida tweaks. I'm going to install the very recent one that is updated on 17/2/2023. I'm going to click on that. Once I click on that, there would be something called as Add Frida. I'm going to click on Add Frida, and then I'm going to click on the third-party app store which I'm using. Make sure if you're using Cydia, use Cydia. If you're using Zebra, use Zebra. If you're using Installer, use Installer. And those users or those viewers who are using Celio, use Celio. Since I am using Celio, I'm going to click on Celio. And once I click on Celio, what happens is it gives me a prompt to open in Celio. I'm going to click on open. And once I click on open, my source gets added up. All I have to do is click on add source. For me, the source has already been added, so I've clicked on cancel, but you can simply add the source. And once you add the source, you can go inside the search. These are all the different packages that have been installed, or some packages that might need update can also be found over here. You can click on upgrade all to upgrade all the packages. Over here in the search option, I'm going to search for the source which I have added, for the tweak which I have added, that is Frida. So let's say I'm searching for Frida, and I would be getting for Frida. Over here, I'm searching for jailbreak related tweaks. So over here, I'm getting a lot of jailbreak related tweaks. And let's say I want to install a particular tweak. You can install it using by clicking on the get button. Once you click on the get button, you can install that tweak as well. So yes, that is it for this particular video. I hope you understood how you can install tweaks. I'm going to create a new video for how exactly we are going to install tweaks, but I hope at least you understood what Substitute is, what Celio is, what are third-party app stores. So that's it for this particular video. Thank you. Hello all, welcome back. In this particular video, we are going to learn how you can install tweaks. So in order to install tweaks, we have to perform the following steps. First, we have to go onto a third-party app store such as Cydia or Celio. We have to go inside Manage, Sources, Edit, and then click on Add. We have to add the repos link over there. Go to Search and search for a particular tweak. We have to then click on Modify and then click on Install. A good tip is that you can visit iOSrepoupdates.com to find the different tweaks along with their different repo links. So let me just show you an example for it. So let us try to install Frida. Over here, I've mentioned the installation steps for Frida. So the different installation steps are: first, obviously, you have to go inside the third-party app store, click on Manage Sources, Edit, Add, give the repo link. For Frida, the repo link is https://build.frida.re slash. Go to search for Frida, click on Modify, Install. Alternatively, what you could have done is you could have gone on to iOSrepoupdates.com, search for Frida over there, click on to add Frida, and choose the respective application app store. So it's the demo time, and let's check out how you can install Frida. So first, what I'm going to do is I'm going to go inside my third-party app store, that is Celio. So I'm going to go inside Celio. I'm going to click inside sources. I'm going to click add. And over here, I'm going to add a particular source. The source is build.frida.re. As you can see in the PPT, the source is build.frida.re. So I'm going to write over here build.frida.re and click on add source. Once the source has been added, for me, it has already been added. You can go on site search and search for Frida. Click on get and click on queue and then confirm. Once you confirm it, Frida is going to download for us. It's going to take 17.6 MB of space. Let me fast forward this so that Frida has been installed. And alternatively, what you can do is you can go on to iOSrepoupdates.com, and over here you can search for Frida. Let's search for Frida and click on search and go inside Frida. and then click on add Frida. So you can see there's a button, and click on the application store, that is Celio. And then you can add the source over here as well. For me, the source has been added, so I'm going to click on cancel. Let Frida get installed for us. So it's going to take a while. Perfect. Once Frida has been installed, you can see over here something as modify. So if the button has been changed from get to modify, that means Frida has been installed for us. Now, it's not at all necessary that each and every tweak has a GUI. So for example, Frida does not have a GUI, but you can still confirm that Frida has been installed inside this. How? You can go inside the terminal and just write frida-ps-ua. This particular command is going to help you to know that which applications are running in the background. So as you can see, there are two applications running in the background, that is Safari and Celio nightly. So this way you can confirm that Frida has been installed inside the iOS device. So that's it for this particular video. I hope you understood how you can install the different tweaks. Thank you. Hello all, welcome back. In this video, we are going to learn about jailbreak detection. So we know that in order to install tweaks, we require our iOS device to be jailbroken. Jailbreak detection is a mechanism which is implemented by most of the developers so that the application cannot work on jailbroken devices. Why do developers implement this? Jailbreaking a device basically means getting the root access of the device. And the application developers do not want you to run their application on root privileges, since this might cause harm to the application. So, what does the developer do? The developers implement jailbreak detection. However, some developers do not consider jailbreak detection as a best practice. For those who consider it and who implement jailbreak detection, there's a high probable chance that they might not have implemented it properly. So jailbreak detection bypass can be bypassed in various methods. We're going to look at 5 methods of bypassing jailbreak detection. Let's start with the first one. The first one is using Frida. Now, Frida is a tool which hooks a particular script with your application. This hooking of script helps you to bypass jailbreak detection or bypass other functionality. So what does the script do? The script basically has certain controls using which it's going to manipulate the response that is coming from the application. So let's understand this in a very simplified manner. So let's say there's an application wherein the jailbreak detection has been implemented. As soon as you open the particular application, the jailbreak detection function detects that the device has been jailbroken, and it's going to send you a response. Let's say the response is true. Jailbreak detection is true, which basically means that jailbreak has been implemented, or jailbreak, or this device is jailbroken. What Frida is going to do in that case is the response that was received, that was true, Frida is going to convert this response from true to false, and it's going to pass it. Now, since the response has been converted from true to false and has been passed to the application thinks that the device is not jailbroken, and it bypasses the jailbreak check and continues to use the application. So this is how exactly how Frida works. Now, in order to bypass the jailbreak detection, you first have to install Frida. This can be seen in the previous video. You can install Frida. It's very simple. You have to check the application package ID or the application identifier bundle by using the command frida-ps-ua. We have already talked about this command before. And then you have to hook the jailbreak script. The jailbreak script could be found over here in codeshare.frida.re, the link which I have mentioned. Do not worry. In the tips and tricks section, I have given a particular resource wherein all the Frida scripts are present over there. So you just have to visit that particular link, and I have collected all the different Frida scripts from different sources and have created them and merged them inside a GitHub repository. The link for which would be seen in the next to next section, that is the tips and tricks section. So in order to hook the Frida script, you have to write frida-u-f in in dash F, you have to mention the package ID, which we have found using frida-ps-ua, and then mention dash L, and then give the jailbreak script, which can be downloaded. So once you do that, you have to hit enter, and then Frida is going to do all the work for you, and it's going to bypass the jailbreak detection for you. So it's the demo time, and let's check out how jailbreak detection can be bypassed using Frida. So what I'm going to do is, first I'm going to download this particular script. So all I'm going to do is, I'm first going to write frida-ps-ua, and now you can see that my application is not running currently. I'm going to open the application, and now I'm going to again write the command frida-ps-ua. It's very important for you to note that your application must be running in background for Frida to identify the device identifier or the application identifier. So once you have the DVI version 2's identifier, I'm going to go inside jailbreak, and I'm going to test all the jailbreak methods. So you can see devices jailbroken. For jailbreak test 2, it's jailbroken. Test 3, devices jailbroken. You can see the error message was different this time, which means there's a different jailbreak check which has been implemented. For 4, again, the error is different. And for jailbreak test 5, again the error is different. So you can see there are 5 jailbreak tests, and we are going to bypass all of these 5 different jailbreak tests. For 5, you can see once we click on OK, the application has been exited. So I'm again going to go inside the application, and I'm going to open the screen. Now what we are going to do is, we are going to download this jailbreak.js script. You can simply go onto this particular link, the link for which I would be giving in the description section. You can just copy the link, paste it onto Google, and you would be able to see this particular page. Once you see this particular page, you can copy the script. You can also check out different scripts by simply Googling it out. Do not worry, I have compiled all the scripts. As I said before, I would be given the link for the compiled script into the video. So please do watch that video as well. For now, we are going to use the script which we have already mentioned. All you have to do is you have to copy it. Okay, I'm just going to fast forward this. Yeah, so you have to copy this, and you have to paste it inside the text editor. Once you paste it, save this file using any file name what you want. You can save it with whatever file name you want. I have saved it with jailbreak. Make sure that the extension for the same would be JS, because Frida basically takes JavaScript based scripts, so your extension should be JS. Sorry, I've saved it as frida.js, and all I have to do is now go on to my command, and I have to write the command, that is frida-u-f, frida space -u-f. I'm going to mention the identifier, which in our case is com.highaltitudehacks.dvi Swift version 2 -l, and I'm going to mention the script name. So for the script name, it is frida.js, and I'm going to click on enter. Once I click on enter, you can see that my application got exited, and now it's again open by hooking the Frida script. So you have to keep the terminal running, and now if you try to test the jailbreak device, you can see device is not jailbroken. So what did Frida do? Frida basically took the response from the application, and it modified the response, and it bypassed it. So you can see device is not jailbroken. You can click on OK. You can see it was start64 bypass. It's a bypass technique name. And for the second one as well, you can see device is not jailbroken. Third one, device is not jailbroken. Fourth one is again device not jailbroken. And fifth one is again device not jailbroken. So we successfully bypass the jailbreak detection using Frida. So this was first technique using which you can bypass jailbreak detection. If you come across any application using which Frida is not helping you out to bypass it, do not worry. There are other methods as well. We are going to look at each and every method in detail. So this was just the first method. There are more methods to come. So that's it for this particular video. Thank you. Hello everyone, welcome back. On this video, we are going to look at the second method of jailbreak detection bypass. In this method, we are going to use a tweak called as shadow. So what is Shadow? Shadow is a jailbreak detection bypass tweak for modern iOS jailbreaks. You can add the repository of Shadow by simply writing ios.jjolano.me. This is the source of the Shadow tweak. You have to install the source by adding the source inside your third-party app store. And then to use the tweak, you simply have to go to settings, click on Shadow, and enable all the options that are required for you to bypass the jailbreak detection. So it's the demo time, and let's check out how you can install Shadow and how you can install and bypass the jailbreak detection. So for that, you have to go inside Celio, you have to go inside sources, and you have to add the source, that is ios.jjolano.me. Okay, I'm sorry, it's .jjolano.me. Okay, it's not .com, it's .me. Once you install jjolano.me, you can simply search for Shadow. You can click on get and then you can click on install. For me, it has already been installed. So what I'm going to do is I'm simply going to go inside settings and I'm going to click on Shadow. So if you go inside Shadow, you have various options that are available. The first option is always on. If you click on always on, by default, Shadow is going to bypass all the jailbreak detections that would be visible to it. Okay, it attempts to bypass jailbreak detections in all applications by default. It has no effect of override by per app setting. So if you want Shadow to only work with one particular application, please keep this option as off. If you want Shadow to be implemented on all the applications, you can keep this option as on. So either you can keep it as on or you can keep it as off. You can go inside bypass settings. Now there are different hooks which are available with Shadow. So for example, there's file system hooks, dynamic libraries, URL handlers, environment variables, detection frameworks, foundation frameworks, M1 Max spoof, etc. There are certain extra hooks as well which are available. Now it's a trial and test error for you to know that which hook is going to work for you in order to bypass the jailbreak detection. For most of the applications which I have seen till date, for them, Shadow's default hooks, which are on, are very successfully used and are very successful in bypassing jailbreak detection. So you do not have to turn on or turn off any other extra hooks. There might be chances that if you turn on any extra hook, the application might crash as well, which is perfectly okay. Even if your application is crashing, it's perfectly okay. There's no need to worry. Just you have to make sure that that particular hook, you're enabling that particular hook is crashing the application, which means that that hook is not going to work for the application. So you can enable any hook, whatever you like to. What I'm going to do is I'm going to keep the default ones. Okay, I'm going to go back and then you have the application settings as well. Now, if you want to enable jailbreak detection or enable Shadow's jailbreak detection bypass on a particular application, you have to go inside the applications. You have to select the applications. In our case, it was DVIA version 2. And inside that, you have to enable it. So again, inside the applications, you have certain bypass settings as well. So what we are going to do is we are going to go inside DVIA version 2 and we are going to go inside jailbreak detection and we are going to test. Now, as you can see, jailbreak detection, the Shadow's global setting is on and hence it was showing that it is not jailbroken. But now if you see device is jailbroken, we have those methods enabled. So you can see that the device is jailbroken and yes, now in order to bypass this, what we are going to do is we are going to keep always on option enabled. And now we are going to go inside Shadow and now we are going to test for each and every method. And for each and every method, you can see that the device is now not jailbroken. So this is how you can bypass jailbreak detection using Shadow. I hope you understood it. Thank you. Hello everyone, welcome back. In this video, we are going to learn how you can bypass jailbreak detection using Liberty. So Liberty is another jailbreak detection bypass tweak. You can add Liberty by adding the following repository into your sources section, and you can install Liberty directly from the search. To use this tweak, we simply have to go to settings and enable the tweaks section. So it's the demo time and let's understand how you can install Liberty. So in order to install Liberty, all you have to do is you have to go inside Celio and you have to add the repo. So the repo over here is ryleylangus.com/repo. For me, it has already been added. You can add it by simply adding the plus button. And once you add the repository, you have to go inside search and search for Liberty Lite. You can install Liberty Lite by simply clicking on the get button and installing it. Now all you have to do is you have to go inside the DVIA version 2 application and you have to check whether you have to first check whether other tweaks have been enabled or not. So over here I have other tweaks which are enabled. So I'm just fast forwarding this so that all the other tweaks are disabled. And once I disable the tweak, now if you see that jailbreak detection test is being failed, you can see that the jailbreak detection test is being passed and it's now showing that the device is jailbroken. So now what we are going to do is we are going to go and install and enable Liberty. As you can see, Liberty has been enabled over here. And once you enable Liberty, all you have to do is you have to go inside. Yeah, all you have to go do is you have to go inside the application, go inside jailbreak detection, and now as you can see that jailbreak detection is not implemented and jailbreak detection has been bypassed using Liberty. So I hope you understood this particular video. Thank you. Hello all, welcome back. So in this video, we are going to look at another tweak that is called as A bypass. A bypass is a very famous tweak that is used to bypass jailbreak detection. You have to simply go into the sources and add the following repo, that is repo.co.kr, and install A bypass from search. Just like Liberty, you can go to settings and use this particular tweak. Now it's the demo time and let's check out how you can install A bypass. So all you have to do is go inside Celio and go inside sources and add repo.co.kr. For me, it has already been added. And I'm just going to search A bypass. I'm going to click on get and install. For me, it's already installed. Why should one use A bypass is basically up till Liberty was only used till iOS 14. After iOS 14, Liberty can bypass jailbreak detection, but it's not 100% sure that Liberty is being properly used or not. And hence, one should use A bypass. A bypass is a tweak that supports iOS 14 and later devices and is used very well with the modern applications to bypass their jailbreak detection. So you can go inside A bypass and all you have to do is enable it. So I'm going to enable for DVIA version 2. And now if I check it out, you can see that the jailbreak detection is failing and we are able to bypass the jailbreak detection. So I hope you understood what A bypass is and how you can implement A bypass. Thank you. Hello everyone, welcome back. In this video, we are going to look at the fifth method of jailbreak detection bypass using objection. Now in the static analysis, we had used objection for 2 or 3 methods, but we never understood what exactly objection is. Objection basically is a runtime mobile exploration toolkit. What does that mean? That basically means that objection helps you to find certain vulnerabilities or to explore the mobile application in real-time runtime. It has certain tools that are pre-installed inside it, which is going to help you to find certain things inside an iOS application. To install objection, all you have to do is simply write pip3 install objection frida and frida tools. Objection will only work if you have frida installed inside your iOS devices. Now, in order to explore the package, all you have to do is you have to write objection dash dash gadget and you have to specify the package name and click on and write explore and then click enter. Now, in order to disable the jailbreak detection, you have to simply write iOS jailbreak disable. Once you write iOS jailbreak disable, it's going to disable your jailbreak detection. So it's the demo time and let's start. So in order to install objection, first you have to write pip3 install objection. For me, it has already been installed. So I'm just going to write freera-ps-ua and I'm going to check the identifier. I'm going to write objection dash dash gadget and I'm going to write give the identifier and click on explode. Once you click on explode, objection gets hooked up with your application, and once it's hooked up with your application, you can run all the tools that are present inside objection. So once you click on explode, you can now see that it has been hooked up, and now you can use the tool that is iOS jailbreak disable. Once you click on iOS jailbreak disable and once you hit enter, okay, once you hit enter, now if you see now the jailbreak detection test is being implemented. I guess the tool has not been installed perfectly. Okay, let me just disable all the tweaks and let me just exit the application and now again rerun it. And now let's hook the tweak that is jailbreak disable. And now you can see that the job iOS jailbreak disable has been registered with our application. Now, if I go inside the jailbreak detection methods and if I click on jailbreak test one, you can see device is not jailbroken. Once you click on test one, there are certain things that pops up onto the terminal. Let's understand that. So there's something that has been popped up onto the terminal that says check for /bin/bash was successful with 0x1, which basically means that when the user clicked on the jailbreak test one, the application tested if the root access has been taken by the user or not. The application was successful in testing that and it replied with the response that is 0x1. What did objection do for us? It marked the response 0x1 to failed. You can see it is written over there marking it as failed. Now once the response was marking it as failed, this particular response was sent to the application. And once the response was sent to the application, we can see that we are shown with the alert box that the device is not jailbroken. So this is exactly how objection works. You can see except okay, I'm sorry. You can see except for /bin/bash, there's something as well. There's something called as /user/sbin/sshd as well. This is again a checking point that the application developer has checked that if this particular function is available, this means that the device is jailbroken. Again, what objection did for us is objection marked this with failed. It replaced 0x1 and it marked it as failed. Let's now try to check the second one, that is jailbreak test 2. So let's now try for jailbreak test 2. I'm sorry, jailbreak test 2. So in jailbreak test 2 as well, you can see that again, the same repositories were checked in jailbreak test 3 as well. The same functions or the same repositories were checked. And for each of the successful check, objection was marking it as failed. Let's check for the jailbreak test 4. Again, for jailbreak test 4, it was same. And you can see etc apt path was same, and for jailbreak test 5 again it was same. And what objection did was objection was marking it as failed. So this is how objection works, and this is how exactly objection manipulates the response that is coming from the application or from the iOS device and then sends it to the application. So in this way it helps us to bypass the jailbreak detection. I hope you understood this. Thank you. In the previous videos, we were looking at how you can bypass jailbreak detection that is present inside an application. We have looked at 5 different methods that includes tweaks and other methods to bypass jailbreak detection. However, if each of this method has failed for you, do not worry, I have you covered. There are various other scripts and various other tweaks which are available in order to bypass jailbreak detection. I've written some of them over here. These include FlyJB, HideJB, Liberty Light, vNode Bypass, Hestia, iHide, Kern Bypass, etc. There's a list of all the different tweaks that can be found that can be helpful to detect or to bypass jailbreak detection. You can find the list of tweaks onto this particular website that is called as iosgods.com. So what I'm going to do is I'm going to open this particular link and I'm going to show you up. So let me just copy this particular link and open it up for you. I'm just going on to my browser and let me open this up for you. And once I open this up, you'd be able to see there are all the different tweaks along with the sources of them as well. So you can simply copy each one's source and you can paste it inside your third party app store and then check out for each one of the application and check out which application or which tweak is going to help you bypass your jailbreak detection of your target application. So you can use FlyJBX, you can use KernJBX, etc. So you can search for, let's say I'm searching for FlyJBX. So you can search for FlyJBX. If you do not get the search, you have to add the repo. For let's search for vnode. Again, you have to add the repo. So do not worry. To know the repo, if you do not know it, you can simply go onto this website, that is iOS repo updates, and then you can search over here. So let's search for vnode bypass. Again, it's a very good bypassing technique, a very good tweak which is used to bypass it. You can install the second one, that is vnode. You then have flyjb. Let's search for flyjb. And once I click on the search button, let it get loaded up. Okay. So let this thing get load up. And once it loads up, we'll be able to see the flight. Okay, you might have to write it very particularly if you have it, or else you can directly download the repo from here. Once you get the repo, you can go inside the sources and you can add it up. So there are lots and lots of tweaks which are available. There are lots of different toolkits which are available in order to bypass jailbreak detection. So try working with each and every tweak. There might be one particular tweak which will definitely help you bypass your jailbreak detection. So that's it for this particular video. Thank you. Hello everyone, welcome back. In this session, we are going to learn about SSL pinning. SSL pinning is a technique that most application owners implement so that any request sent by the mobile application is not intercepted. SSL pinning is considered as the first and the most important step in the security mechanism of an application. But due to improper means, SSL pinning can be usually bypassed. So what exactly is SSL pinning? Let's first understand that. Let's say I have an e-commerce iOS application and my iOS e-commerce application should only communicate with my backend server. It should not communicate with any other backend server. So in order to implement this particular system, developers use SSL pinning. What does it do? Well, my iOS application is first going to send a hello message to the server. The server would be replying with the server certificate, that is the public key of the server. The iOS application is going to calculate that particular hash of the received public key. If the hash matches the hash that it already has, the iOS application already has, then and only then all the requests are going to get to that particular application server. If the hash is not matching, all the requests are denied. So the iOS application is not going to send any further requests and it's going to display a message stating that this application is being intercepted or this application is communicating to a third party server. Now, why do application developers implement the system? We know that mobile applications can be reverse engineered very easily and they can be modified as well. The attackers can compile the modified applications and then send it to the victim. Now, the application owners do not want victim to connect to the attacker's controlled server and hence they implement SSL pinning. However, SSL pinning is not implemented properly in certain cases, and that is the reason SSL pinning bypass can happen. So SSL pinning bypass can happen using various methods. In this entire course, we are going to use three methods using which SSL pinning bypass is very simple and is very common to do. So the first method is SSL pinning bypass using Frida. So you can install Frida using the previous slide. All you have to do is then you have to check the app package ID using frida-ps-ua, and then you have to hook the Frida script, hook the Frida SSL pinning script that can be found inside this particular link. Do not worry, I have compiled all the Frida scripts into one and shared into my GitHub repo. I'll be sharing that repo as well. Once the Frida script is hooked up inside your application, your SSL pinning might be bypassed. How does Frida work? Frida changes the response and runtime, similarly to what it used to do in jailbreak detection as well. So it's the similar thing. So it's the demo time, and let's check out how you can bypass SSL pinning using Frida. So what I'm going to do is, since Frida is already installed with us, I'm going to download this particular script, that is SSL pinning bypass script, and I'm going to copy the entire script and save it inside my device. Now this is the GitHub link which I was talking about. I have compiled all the Frida scripts into this particular link that is called as awesome Frida scripts. You can view this particular GitHub repository. And over here, I have certain scripts for SSL pinning bypass, jailbreak detection bypass, etc. So you can simply download the entire script from here if you want to. I'm going to copy this script and I'm going to paste it inside my Sublime text, and I'm going to save this as SSL pinning.js. Remember to always save it as SSL pinning. Remember to always save it as JavaScript file. So what I'm going to do is, first I'm going to go inside desktop and I'm going to write the command frida-ps-ua in order to find the identifier. Since my application is not running currently, I'm going to open the application, and now as you can see, it's running. Now I'm going to write frida-u. I'm going to give this identifier by -f, and I'm going to give the script using -l. And the script which we are going to use is the one which we have saved as SSL pinning -new. I'm just going to save this up and hit enter. Once I hit enter, you can see the Frida script has been hooked with my application. I'm going to go into issues and network layer security issue. Now I'm just going to enter any data over here, and I'm going to send that data over HTTP connection or over HTTPS connection. Now, in order to intercept the data, first what we have to do is we have to set up a burp suit. Now, how can you set up your burp suit? We have already seen this in the previous videos. If you haven't watched the previous videos, I would recommend you to please watch the previous video. Over there, I have showed exactly how you can set up your burp suit and how you can set up your iOS device with your burp suit. And now what we are going to do over here is we are going to click on intercept on, and I'm going to send the request over HTTP. So you can see the request has been sent over HTTP. You can see at the above that request to http://example.com, wherein your data is being sent. You can see all the data is being sent and it has been captured by our burp suit. Now, one thing very important to note is only if and only if you're bypassing SSL pinning inside an application, inside an iOS application, only then you would be able to play with the request and the response that is being sent by the application. If you're not able to bypass SSL pinning, your application, if your application is not vulnerable to SSL pinning bypass, you cannot find any runtime related vulnerabilities in your application. In order to find runtime related vulnerabilities or vulnerabilities that purely depends on the request and the response, you have to bypass your SSL pinning. And hence SSL pinning implementation is considered as one of the most important steps inside any iOS application or inside any mobile application in general. So you can see we have captured the request and then we can play with the request and the response. Now I'm going to close the intercept and I'm going to send the request over HTTPS. Let me turn on the request again. And now, as you can see, we have now sent the request over HTTPS connection. So you can see inside the edit section that the request is being sent to https://example.com. So it's an HTTPS connection. Okay, let me turn the intercept off. And now let's turn it back on and send the certificate using certificate pinning. Now you can see there's a GET request which is being sent. Let's turn it off and let's send it using public key pinning. And now again you can see it's an GET request, another GET request which is being sent. So in this way we can bypass SSL pinning using Frida. I hope you understood what exactly SSL pinning is, and I hope you understood the first method of bypassing SSL pinning using Frida. Thank you. Hello everyone, welcome back. In this video, we are going to look at the second method of how you can bypass SSL pinning using SSL Kill Switch 2. SSL Kill Switch 2 is an SSL pinning bypass tweak. It is the most famous tweak which is used to bypass SSL pinning. In order to install SSL Kill Switch 2, all you have to do is go inside your repos and add the source of this particular tweak. Then you can go inside the search option and you can install SSL Kill Switch 2. To use this tweak, all you have to do is simply go to settings and enable the option of disable certificate validation. Once you disable the certificate validation, all SSL pinning methods would be disabled for all the applications. In most of the cases, this tweak never fails. So it's the demo time and let's understand how you can install this particular tweak. What I'm going to do is I'm going to go inside Celio Nightly and I'm going to search for the package called as SSL Kill Switch 2. Since I have already added the source, you can add the source by going inside the sources and writing over here juliovarna.github.io. So it's JULIOVERNE.github, sorry, .github.io. You can simply write this. You can add the source. Once the source has been added, you can search over here SSL Kill Switch 2. For me, it has already been installed. You can install it. You can go inside SSL Kill Switch 2 and by default, disable certificate validations would be enabled. Now, all you have to do is you have to go inside your vulnerable application or you have to go inside the application for which you want to bypass and then intercept the request. And once you send any request, all the requests are going to get intercepted inside your Bob suite. As you can see, all the requests are being intercepted inside the Bob suite. So that's it for this particular video. I hope you understood how you can bypass SSL pinning using SSL Kill Switch. Thank you. Hello everyone, welcome back. In this video, we are going to learn the third method of bypassing SSL pinning. This method is using Objection. Objection is a runtime mobile exploration toolkit. To install Objection, you can simply run the command pip3 install Objection Frida tools. Objection uses Frida in order to run, so make sure that your Frida tweak has been installed inside your iOS device. In order to explore the package, we know the command is objection dash dash gadget, package name and explore. And to disable SSL pinning bypass, I'm sorry for the error over here. It's not jailbreak detection, it's SSL pinning bypass. To disable SSL pinning, you simply have to use the command called as iOS SSL pinning disable. Once you use this particular command, all the SSL pinning would be disabled inside the iOS application and you would be able to intercept the request and the response. So it's the demo time and let's check out how you can bypass it. So all we have to do is first find the package identifier using the command called as frida-ps-ua. We have to go inside dbia, hit enter, and now we know the package identifier is this. We have to write object dash dash objection dash dash gadget, mention the identifier and hit enter once we write explore. Our application is going to reopen by hooking the objection tool with it. And now we have to just write iOS SSL pinning disable. Once we write this and once we hit enter, it's going to hook or register the job. That is the job type is iOS SSL pinning disable. Now you can go inside the application and you can open the network layer security, turn on or turn on the intercept and enter any data. Let's enter some random data and send it over HTTP. So once you send it over HTTP, you can see the request is sent, look out, and you can see it has been intercepted by a Bob suit. Now over here, if you see onto the terminal, you can see called SSL CTX set custom verify setting custom callback, which basically means that SSL pinning was implemented, but what objection did was instead of calling the actual server, objection called a custom certificate, and it matched the custom certificate with the iOS application. And custom certificate was matched, once the custom certificate was matched, we were able to intercept the request inside our Bob suite. Now, similar things happen when you send the request over HTTPS or send using a certificate pinning. So let's send the request over HTTPS, and you can see it's sent over HTTPS, and you can see again it has been set to custom verify. If you send it over any request for all of them, it's going to change the response and it's going to set it to some custom certificate. So this is how you can bypass SSL pinning using objection. Now you might wonder that once I get the request, what next? What next? Because over here the dynamic analysis part gets over. What do I do next? How do I find more vulnerabilities inside an application or inside an iOS application? Do not worry, each and everyone gets this particular doubt that once I've completed this much, how can I find more vulnerabilities? Well, from here, everything is the same as you do inside a web application. Consider this mobile application as a web application. Let's say the web application has the payment option. Consider the mobile application also has the payment option. All you have to do is click on pay. And once you click on pay, you can intercept the request and play with the response. You can use response manipulation inside the request. Once you use response manipulation, there's a good chance that you can bypass the authentication mechanism. You can report the authentication mechanism as well, bypassing of authentication mechanism. Let's say the mobile application has the feature of sending an OTP in order to authenticate the user. You can intercept the request where the OTP is being sent. You can send that particular request to intruder, send multiple requests, and you can check whether the mobile application has no rate limit implemented or not. Even that is possible. If the mobile application does not have rate limit implemented, and if your device or if your phone is getting multiple SMS from the application, then it's vulnerable to no rate limit implemented. If that particular application is leaking OTP inside the response, then you got an authentication bypass issue. You can use any OTP of any particular user and you can authenticate into his or her system. You can find access control issues. You can find IDOTs. So once you get the request and the response from the mobile application, do not worry. Now is the best time to check out for other vulnerabilities, to check out for authentication bypasses, no rate limits, to check out for IDOT related issues, to check out for access control related issues, to fuzz the endpoints, to find new endpoints, to check out whether an admin dashboard is present or not. If there's a payment functionality happening, a payment functionality is present inside the application, you can check out, you can bypass the payment functionality as well. So these are some of the vulnerabilities you can check out inside a mobile application. Do not worry. Once you get the request and the response, everything is similar to the web application. Please take this golden line. Once you get the request, once you once you bypass SSL pinning and get the request inside your Bob suite, your mobile application becomes your web application, and you can find all the vulnerabilities which you used to find onto your web application. So that's it for this particular video. I hope you understood about SSL pinning, about SSL pinning bypass. In the next video and in the next upcoming sections, I'm going to share you certain tips and tricks in order to master your iOS pen testing. So I hope you like this particular video. Thank you. Hello everyone, welcome back. Remember in the previous video, we talked about an e-commerce application that might be using Touch ID or Face ID as the basis of their authentication. And we talked about how we can bypass it. In this particular video, we are exactly going to do that. We are going to bypass the local authentication mechanism methods that might be used by an application in order to authenticate a user. These methods include the Touch ID and the Face ID. Now, this Touch ID and Face ID mechanisms can be easily bypassed by using objection. So there are two steps to it. First, obviously, we require the prerequisites FRIDA to be installed in our jailbroken iOS device. Secondly, we require objection inside our computer device. Once these prerequisites are covered, you can run or you can explode the package using the command objection dash dash gadget, the package name, and explode. Once this is done, you can disable the local authentication mechanism by using iOS UI biometric bypass. So it's the demo time, and let's check out how you can bypass this. So in order to bypass this, first you have to open the DBIA application and you have to explore that particular package. Now in this particular method, what I've done is I have installed DVIA on my non-jailbroken device. So I have created a video inside the tips and tricks section. You can go and watch that particular video. And in that particular video, I've shown you how you can install any application without the use of a jailbroken device. So if you want to install a particular application inside a non-jailbroken device and you want to use objection and FRIDA with it, you can do that very easily. So I've created a whole video for that. You can watch it later in the tips and tricks section. Currently, I've exactly done that. Why I've done this is because the Paladin application does not allow me, or the Paladin jailbreak does not allow me to use the local authentication methods. And since I wanted to create a demo which used the local authentication methods, so that's the reason I have deployed the application on my non-jailbroken iOS device. So do not worry, all the steps are same, just as one difference wherein I'm simply going to write objection explore instead of objection dash dash gadget, the bundle identifier, and then explore. So you can simply write objection explore over here. And once you write objection explore, objection is going to get hooked up inside our application. Now we are going to go inside the touch and face ID bypass. Let's read the challenge. What is the challenge? Functions that do the authentication via touch and face ID can be hooked and manipulated in order to authenticate the attacker. Having an Objective-C runtime environment definitely aids the attacker as it becomes easier to swizzle method. Use a combination of hooking debugging to bypass the touch ID and face ID checks. You can use tools like Needle, Frida, Cycrypt, etc. or just LLDB. So here our challenge is to bypass the touch ID and the face ID. The application has given us certain methods of bypassing it. The method which we are going to use is using objection. You are free to explore Needle, Cycrypt, or other such tools, but we are going to use the tool of Frida and objection. Now, in order to do this, let's start the challenge first. And before we start the challenge, we have to mention over here iOS UI biometric bypass. This is the command using which you can hook the biometric bypass script, and it's going to help you to bypass the touch ID and the face ID. So here I'm just going to write iOS UI biometric bypass, and you can see there are two jobs which have been registered. One is disable evaluate policy and the second one is disable evaluate access control. Now what I'm going to do is I'm going to click on Swift implementation, and as you can see the application is asking for my face ID. I'm going to allow the permission of face ID. I'm going to click on OK, and as you can see my face ID was successfully seen inside the application and it authenticated me. In the terminal section you can see that the OS authentication response was true. Now over here I showed you a demo that what would happen if actually the face ID was seen and if actually the face ID was checked and authenticated by the application. The face ID would give a response such as true to the application, and the application would display a message that success authentication is successful. In other case scenario, this was of Swift implementation. Let's check Objective-C implementation. Again, in Objective-C implementation, the method or the response is the same. The OS is going to authenticate and it's going to give us a response as true. Now what I'm going to do is I'm going to click on OK, and now this time I'm going to cover my front camera. If I cover my front camera, the application is not going to validate. It's going to get failed. So for example, let's click on Swift implementation, and this time I've covered my front camera. So once I click on Swift implementation, you can see the Face ID is trying to capture my face, right? But it is failing. It's not able to capture it. As you can see, face shows that it's not recognized. I'm going to try the Face ID again. So let me try the Face ID again. And now as you can see, again, it is not recognizing it. Now after two attempts of recognizing it, it has asked me for the password. I'm not going to enter the password, and I'm simply going to click on cancel. As soon as I click on cancel, you can see there's a success message that says authentication was successful. So in the terminal section, you can see OS authentication response was false. So what did the OS responded to the application as false. But due to our objection script, that is iOS biometric disable evaluate policy, what objection did for us is it marked the response of false to true. It modified the response from false to true. And this response was then sent to the application. So now the application is thinking that yes, the face has been captured correctly and I can authenticate this user inside my application. And that is the reason you are able to see the success message. A similar case is present inside the second one, that is the objection C implementation. So let me just click on OK. And let me click on objection C implementation. And this time as well, I'm covering my device's front camera. My face is not recognized. I'm going to click on cancel. And you can see the OS response was marked as true instead. The first prior OS response was false. And now the OS response was marked as true. And you can see biometric bypass hook complete using evaluate policy. This is how you can bypass the local authentication mechanisms like Touch ID and Face ID, and you can log in inside the system. If you find such a vulnerability, you can definitely report this to the application owner. So that's it for this particular video. I hope you understood how you can bypass the local authentication mechanisms. Thank you. Hello all, welcome back. In this video, I'm going to take a live target and I'm going to attack that target. I'm going to perform a static analysis and dynamic analysis on that particular target. Now, this video is going to be the most longest video of this particular course. So, if you want to see how you can approach a target, you can always view this particular video. In this video, I'm going to use a live target. Please note that all the findings which I have found in this particular video are already reported to that particular target. So please do not use that functionality or please do not exploit that particular functionality which we are finding in this particular video. And please do not report them as well, since these vulnerabilities are already reported to that particular target. So let's start. In this particular video, I'm going to target the application 99acres.com. That is an application which is being used to find or rent houses. So as you can see, I'm using my jailbroken device that has Celio inside it and Substitute as well has been installed in it. And let's open the target first. As you can see, the target opened without any notification stating that this particular application cannot run since the device is jailbroken, which basically means that this particular target or this particular application allows its application to run on jailbroken device. So we have found our very first vulnerability, that is application can run on a jailbroken device. So you can report this particular vulnerability. It has already been reported to the target application owner. Okay, now before moving to the dynamic analysis of the application, let's start with the static analysis. In order to perform static analysis, I first need the IPA file. Since I've directly downloaded this application from App Store, I need to create the IPA file. I'm going to use one of the methods which we have already seen before. The method is Frida iOS dump. That is the method using which I'm going to collect the IPA file. Now, before running Frida iOS dump, we have to run the iProxy tool. So we are going to run that. That is iProxy 222, and now we are going to run the Frida iOS dump. So in order to run Frida iOS dump, we know the command is Python 3 Frida iOS dump.py and the application identifier
to know the application identifier, we are going to run the command frida-ps-ua, and this is going to give us the application identifier. So let's run the command. Over here you can see the identifier is this, and let's run the command python3 dump.py, and we are going to give the identifier over here. Once we hit enter, we have to start the target app, and once we start the target app, Frida iOS dump is going to create a dump of this particular application and is going to give us the IPA file. So let's wait until the IPA file is being created. And you can see over here, the IPA file is being generated. So once the IPA file is generated, we are going to use mobsf and we are going to upload the IPA file. So let's upload this particular IPA file. Perfect. So uploading and analyzing that is done by mobsf is going to take a little bit of time. So let me just fast forward this particular video so that our time gets saved over here. So here, as you can see, that mobsf has accepted the file and it has done its static review over here. And you can see the security score that mobsf has given is 16 out of 100. Over here, all the information is provided by mobsf. You can see the supported devices list, the description. Let's view the info.plist file first. So let's find out if there are any vulnerabilities that are present in info.plist file or any hard-coded strings, application permissions, etc. So let's scan the info.plist file for such vulnerabilities. So you can see that there's a Facebook application ID, and this is a secret key or sensitive key that is being stored. You can see the minimum OS version is 15.0, which means that the application will only run with minimum operating system or minimum iOS version of 15.0. You can see the application permissions that are used are NS camera usage description that is used in order to access and to click photos. So in this case scenario, usage of camera description is not a wrong permission or is not a high severity permission. The application definitely uses camera in order to click photos and hence it is allowed. We have NS contact usage description. This allows 99 acres to access contacts. This will enable you to save contact details in your contacts. Well, we can consider this as a low to medium severity risk. Why? Because the application has a functionality to store the contacts directly into your phone book. However, it can access the all the contacts of other personals as well. So this could lead to some troublesome or some recon of what contacts are stored into your device. So we can consider this as a low to medium severity. But again, it depends on the application owner whether they want to accept this risk or not. Then we have NS location allow and when in usage description, which basically means that this particular application is going to use our location. So there are multiple location usages which have been enabled. There's also photo library usage using which you can upload photographs. We have speech recognition usage as well, wherein your microphone access is being used. So let's scan for more vulnerabilities if there are present, if any. And you can see there's a Firebase JSON raw wherein we have some string over here. This is a base encoded string. Most likely the string would represent the version number. Over here you can see mobsf has given us the application permissions, which we have already looked out for. Now, if you can see, mobsf has also detected that app transport security allows arbitrary loads as allowed. This basically means that HTTP, unsecured HTTP connections are allowed. Over here, we find a second vulnerability wherein HTTP connections are allowed, and hence we can report that ATS is being allowed and it should be disabled. So we have found a second vulnerability over here, that is app transport security. Now let's go to the binary code analysis, and you can see over here we have insecure APIs that are being used. So let's check out whether these APIs are actually present inside the application or not. For that, we are going to first decrypt or unzip this particular IPA file. We are going to rename this to zip.
And let's use the extension zip, and we are going to unzip it. There's a new folder that will be created called as payload. Let's go inside payload, and inside payload we are going to go inside that particular application, and we are going to search for 99 acres Unix executable file. So this is basically the application under which we are going to go. So as you can see, this is 99 acres.app. We are going to right click and check and click on show package contents. So here we are going to find the Unix executable file. So let's search for it. And as you can see, the Unix executable file is over here only. So we are going to give the path for this particular Unix executable file. So let's write the command otool-i-v. We are going to give the path for the executable file, and we are going to grep for printf functions. So in this case, we are going to grep for printf functions, and as you can see, there are so many printf functions which are being used. Now let's search for memcpy function, and you can see memcpy is also being used. Now let's check for each one of them. Let's start with fopen. Fopen is also present. Let's go on to the next one, strcpy, that is also being used. Scanf, that is also being used. Let's check for strncat, that is being used. strncpy, again, this is being used by the application. And start, again, start is also being used by the application. You can see fstart, start fs, mstarts, etc. So these are also being used by the application. Now let's check out if malloc function is being used or not. So we are going to search for malloc, and you can see that malloc is also being used. With malloc, let's check for the hashing algorithms, weak hashing algorithms, and you can see MD5 weak hashing algorithm and SHA-1 weak hashing algorithm is also being used in the application. Now, MD5 and SHA-1 algorithms, over here we find our third vulnerability, that is insufficient cryptography, insecure usage of APIs and functions, insecure usage of memory allocation functions. So these are the three vulnerabilities, or the third vulnerability which we have found over here. Now let's continue to read the report, and you can see the binary is not encrypted, our path is not set as well. So again, we can report this as well, that the binary is not encrypted and the developer has to encrypt the binary as well. These are the file analysis, these are the server locations, and moving forward, we'll be able to see all the different URLs as well. Now, these URLs might not be so much helpful for us. What is helpful for us is some secret hard-coded key or Firebase URL. Now, as you can see, there's a Firebase URL which has been found over here. That is nnacres-ios-dev.firebase.io.com. If you try to open this particular URL, you won't be able to load this particular URL. However, if you try to open the second URL, and you can see that it is high, and if you try to load it with the endpoint /.json, you can see there's a JSON format that has been outputted. So this particular Firebase URL does not authenticate properly and is available for any user to view this particular Firebase database. So we have got the session and the user. However, no sensitive content is being leaked, but still we can report this since this particular URL is available publicly. So let's move on with the report. You can see Firebase databases export publicly. You can see there are certain test emails which are being used. You can see leads.propertycafe@gmail.com. There are some IPA string dumps. You can see there's a possible hard-coded secret that stays Firebase underscore JSON underscore raw E30 equals to. However, this is just the version number of Firebase the Firebase which is being used. And with this, we complete the static analysis of this particular application. Now let's move on to the dynamic analysis of this particular application. In order to move on with the dynamic analysis, we have already seen that this particular application is available or can be run on a jailbroken device. There is no jailbreak detection check which is being implemented. Now let's check out if there is any SSL pinning check that is being implemented or not. Now in order to check for SSL pinning, I need to set up my verb suite. So I'm going to set up my verb suite and I'm going to copy the IP address. I will just fast forward this because there was some issue with my internet at that point of time. Okay, so I'm going to configure my proxy and yes, now my internet was working fine. I'm going to configure my proxy to the IP address which we are going to mention of the Mac machine. So the IP address of the Mac machine is 172.20.10.4 and the port number is 8080. And now we are going to intercept the request in our burp suite. So let's try with a demo request and let's search, and you can see the demo request is being intercepted in burp suite. So let's try again with a second request, and you can see the second request is also being intercepted. Now let's turn off the intercept and let's move to our target application. Let's intercept the request. Over here I'm just going to write my email ID which I used to create my account. So it is badhackerboy28@gmail.com, and I'm going to click on continue. As you can see that we have successfully captured the request from 99acres.com, and we are going to click on cancel. And if, for example, if your request is not being captured, you can disable the certificate validation. As a precautionary measure, I'm going to disable this so that even if there's some SSL pinning implemented or there's partial SSL pinning implemented, SSL kill switch 2 will help me to disable those partial SSL pinning that is being implemented. So I'm just going to enable it just for a safety check. And now I'm going to try to perform some dynamic analysis. So I'm going to exploit the forgot password functionality over here. So let's start with the forgot password functionality. Over here, we have to enter the username and the password. Sorry, the username in order to get the password. So I'm going to enter my username, that is badhackerboy28@gmail.com. And I'm going to intercept the request and click on get password. As you can see, the request has been captured. I'm going to send it to repeater for further reference, and I'm going to check the response of this particular request. You can see there's an HTML response that states that the email link has been sent to your provided mail ID to create a new password. Now let's check out our email ID. So we are going to go on to our email ID. And over here, you can see that we have got a new request from 99 acres. Now, what we can do is we can send this particular request to intruder and we can check out if no rate limit is being implemented or not. So what I'm going to do is I'm going to click on payloads and I'm going to use the payload type as null. And I'm going to generate, let's say 40 payloads, and let's start the attack. Now, once we generate 40 payloads and once we start the attack, my email is going to be flooded with unnecessary emails or unnecessary forget password links. So as you can see, after 30 payloads or after 29 or 28, 26 payloads, the 27th or the 26th payload, 26th request was saying that there's a captcha which has been implemented. So here, as you can see that we definitely got around 26 requests, but after 26 or 30 requests approximately, let's say after 30 requests, the captcha had been initialized onto the application. So although this particular application is vulnerable to 30 requests, after 30 requests, there's a hidden captcha that gets generated onto the application. So let me show you the hidden captcha. And let's go back to the screen, and now let's again try the forget password functionality. So in this functionality over here, you can see that there's a captcha which has been implemented. Now, since we have got a captcha, just like our web application, we can try to bypass this captcha as well. So let's try to bypass this captcha and let's check out if the captcha is able to bypass or not. So let me select all the wrong tractors. So here you can see one of the tractor I have not selected. And I'm going to go inside actions and I'm going to intercept the response to this request. However, you see, before we send the request or before the response get comes back to the application says that suspicious activity has been detected and it logs out. So this means that the application might not be vulnerable to captcha bypass. No worries. Let's continue with our testing phase. So what we are going to do is we are going to again send the correct captcha, and with the correct captcha, once we are verified with the correct captcha, let's again come back to the screen of sending the reset password link to our email ID. Now you can see that in this particular section, the reset password link is again available. Now again, I can capture this particular request and send around 30 emails to the target victim. Now is this was a good implementation to stop rate limiting. However, it was not a perfect implementation. The captcha should be implemented with each request that is being sent and not after certain requests. So what the attacker can do is after every 30 requests, the attacker can come back to the application, enter the captcha correctly, and then again reframe the attack and again send multiple emails or mass emails to the victim. And this could also lead to increase in the revenue of the email server as well. So even if the developer has implemented a fix for no rate limit, that is the captcha implementation, the fix is not a proper fix. So again, we can report this particular vulnerability. Over here, we have found a fourth or the fifth vulnerability. The first one was jailbreak detection not implemented. We had certain hard-coded secrets, Firebase URLs, insecure cryptography or API functions which are being used, SSL pinning bypass or SSL pinning not implemented. And the sixth one is no rate limit or poor implementation of no rate limit. Okay, so once we have found out this particular vulnerability, let's try to log in inside the application. And while logging in, let's check out if we are able to bypass the authentication method or not. So let's say I have entered a wrong password over here for this particular account, and I'm going to check the response of this application. And you can see the first response of this particular application was invalid credentials. Let's try to change this invalid credentials to valid credentials by deleting, okay, by deleting this entire message and changing the login status from false to true. Now, once I change the login status from false to true, and if I forward the particular request, you can see our application is, has gone into an infinite loading loop. This basically means that the application is not vulnerable to authentication bypass, and I had to quit the application and reopen it in order to end that particular loop. So this proves that the application might not be vulnerable to response manipulation attacks. If you go inside profile, you'll be able to see that we are not logged in. Okay, no worries. Let's try to log in with the right username and the right password. So let's logging in with the right username and the right password. And now you can see that we have logged in, and let's try to edit our particular profile. Now in the profile section, you can see that we can edit phone numbers. However, we cannot edit the name and the email address. Let's try to bypass this particular functionality. So email address and name cannot be edited. However, mobile numbers can be edited. So let me just click on the save request. Before that, let me just intercept on and click on save request. And you can see there's a parameter called as email, which is being sent. Now let's try to modify this particular parameters value. So I'm going to change the email address from badhackerboy28 to my second email address, that is localhost 2829. And I'm going to forward this particular request. And once I forward this request, you can see that email has been saved successfully. Now, if you check over here, the email has been saved successfully. You can see over here. And now let's change this particular email to from bad hacker boy to admin1244. Okay. The previous email was already being used inside the application, so that's the reason it was not able to change it. However, we can change it to admin12443, and now you can see that our particular email address has been changed. Let me just intercept it off, and you can see onto the screen that our email address has been changed up. Perfect. So we now know that our email address has been changed, and over here, let's try to delete an account. So as soon as you click on the delete functionality, there's a request that comes up that says that do you want to delete and delete my account? And as soon as you check for the intercept on, you can see there's a profile ID which has a JWT token implemented in it. So I'm going to copy this particular token, and I'm going to go on to a website called as jwt.io, which is basically a JWT decoder. And let's drop this particular request because we do not want our email address to be deleted or our account to be deleted. And over here, I'm going to paste this particular request which we have copied, the JWT token. You can see the algorithm used over here was HS512, and you can see the payload which is used is JTI. Now JTI, this is the subject, this is the IAT, and this is the EXP. Now JTI is basically the JWT unique identifier for the token. And once we get this particular identifier for a particular account, there's a high chance that we can delete that particular account. However, we currently do not know any identifier for it, so we cannot perform anything. So let's continue with the attack. So now what we are going to do is we are going to get started with posting property. So let's say we are looking for a particular property and the city name, and let's enter the city name over here. Let's say the city name is Central Delhi. I'm just using some default values, and at the above you can see there's an option of post property. Let's click on post property. Let's explore this particular feature. Now over here we have to add certain basic details. So let's say we are adding certain basic details, and over here inside the contact number, it has sent an OTP to my mobile number, that is this particular mobile number, and it has sent an OTP. Let's try to exploit this particular functionality. So here I'm going to enter a default OTP. So let's say the default OTP is 0000, and I'm going to verify via OTP, and you can see the OTP that is being sent is 0000. You can see there's an API key as well which is being sent. So again, we can use this API key. We can report this particular API key to the user stating that the API key is being leaked in the request itself. You can see we have found out the profile ID as well. So this is the profile ID of our user. I think that this profile ID might be helpful for us in the future. So I'm going to send this particular request to repeater so that I can look at this profile ID in future. So I'm going to send this particular OTP and I'm going to manipulate the response. For that, I'm going to intercept the response. And inside the response, you can see the verification status is invalid. Now let's change this verification status from invalid to success, and let's forward it. And over here you can see the OTP entered is incorrect. So the verification status, although it was changed to success, it was not validated successfully. Now I have only used one particular verification method over here. What you can do is you can try to use other verification methods values such as verified or such as true, etc., and try to bypass this particular functionality as well. However, I tried to bypass it and I failed every time. But nevertheless, let's try to exploit more. So here you can see that our OTP is being resent onto a mobile number, that is this. Now, what if I enter a new parameter of the same mobile number? And let me change the value of the mobile number to my second number, that is this. And let me generate the response for this. And now over here, you can see that the OTP was sent to a second mobile number. You can see over here, the OTP is being sent to this particular mobile number instead of the previous one. So this basically means that our OTP was generated to the arbitrary value which we added inside the request and not the actual mobile number that is saved with the application. Now, this again is a vulnerability. Why? Because the attacker can grab the OTP of the user. He can enter the OTP and verify the mobile number of that particular user. So again, we have found a high level vulnerability that states authentication mechanism bypass. And using this bypass, we are able to verify the victim's mobile number. Now, perfect. So over here, we are able to give the victim's mobile number as well. And you can see the OTP code has been sent. Now let's try to check out whether no rate limit is being implemented on sending OTPs or not. So again, we are going to send null payloads, and let's say in this case, we are going to send 30, and let's start the attack. So once we start the particular attack, let's say after 30 requests, I'm going to check the response. So let me check one of the response. And okay, so in one of the response, you can see that the verification status says rejected generation, which basically means that there's a limit to which the OTP is being generated. And my mobile device only received 5 to 6 OTPs. So I believe that there's a rate limit that has been implemented over here of about 5 to 6 messages per, let's say, 30 minutes or 35 minutes, whatever the business logic has been implemented by the application. So now we know that there is a rate limit that has been implemented on sending OTPs to the mobile device. So this vulnerability again does not hold true over here. So let's continue and let's check out if we are able to implement certain file upload functionalities or certain file upload exploits or not. So let me continue the process of adding my apartment. So I'm going to add all the details over here. And after adding all of those details, finally I've come under the option wherein I can upload the photos of my device. So I'm going to upload the photos of my apartment from my device. And okay, over here I'm able to upload it, and if I intercept a particular request while uploading it, as you can see over here, let's intercept the request. And over here you can see that that particular image file is being uploaded. I have seen a parameter called as file name. Let me try to implement certain JavaScript based vulnerabilities on this particular file name. So let's say we are going to try out for stored XSS, and we are going to write our XSS payload. However, this functionality fails. So our application says that unable to upload the particular file. Let's retry again. So you can see the file is not being uploaded. Let's retry again. This time again, I'm going to upload I'm going to retry to upload that particular file, and I'm going to insert my JavaScript payload. And let me intercept the particular request. Let's forward this particular request and wait for the response. And you can see that we did not receive the response from the web server, which means that this particular functionality might be not vulnerable. However, you can still try to test out more test cases as well. So you can see that the failure of uploading file. We can also try to implement JavaScript payloads inside each and every text box that we get. So here you can see that we have a text box wherein we can add a JavaScript payload. However, this particular text box does not allow you to add the opening angular and the closing angular braces. So you can see opening and closing angular braces are not allowed. Let me try to rewrite it and you can see they are not allowed. Now when I click next, let's try to modify this particular request onto Bob suit. But again, if you can see, the all the data that is being sent into the Bob suit is encrypted data using JWT token. So we cannot modify this particular data as well. So let me just decode this data first using URL. So this is not HTML format, it is URL format. And over here you can see that a lot of data is being sent to the web application server, but the data which we are interested in, the profile ID is being sent. However, the data which we are interested in has been encrypted using the JWT tokens. So we cannot modify that particular data. So you can see over here, the data that is being sent is using JWT token, so we cannot modify it. Now there are a lot of different test cases that you can perform onto this particular application. Yeah, since the application is very huge, you can just go and test out each and every functionality and you can find business logic errors, you can find authentication bypasses, maybe you can find certain session related issues, no rate limits, etc. However, for this particular video, we are going to stop the attack over here. My main purpose for this particular video was to show you that how you can perform the static and the dynamic analysis of an iOS application. I hope that you have understood how you can begin with and then how you can continue to exploit the particular application. The later part of exploitation of the particular application is as similar as to the web application. So that's it for this particular video. I hope you enjoyed this particular video. Thank you. Hello all, welcome to this new section of tips and tricks. In this particular section, I'm going to introduce you to certain tips and certain techniques using which you can master your iOS pen testing. The very first one is the iOS pen testing checklist. Now it is practically not possible to remember all the iOS related vulnerabilities. So what I have done for you is I have created a checklist using which you can remember and check off a particular vulnerability that might be found or might not be found inside the iOS application. So over here I have created a checklist. This checklist is basically on the basis of the most common vulnerabilities that are found inside the iOS application. This checklist over here, the first sheet contains the OWASP mapping 2016 against the check name or the test name that needs to be performed on the iOS application. So for example, let's say inside improper platform usage, we first have to check for app permissions. So you can go on to your application, your iOS application, go inside the info.plist file, and inside the info.plist file, you may check out if there are certain app permissions which are misused or not. If you find certain app permissions which are misused, you can write over here that you have found that particular vulnerability. Similarly, you can also check out for keychain, touch ID, and other security related controls. Minimum device security requirements are absent. Default credentials, if there are any default credentials that are being used on the application server, you can note them as well and you can mention it over here. For M2, we have insecure data storage, wherein you will be able to find all the insecure data storage related vulnerabilities such as unrestricted backup file, insecure shared storage, insecure application data storage, information disclosure through logcat, Apple system logs, application backgrounding, copy paste buffer caching, keyboard press caching, etc. M3, insecure communication, you would be able to see whether SSL pinning is implemented or not, disabling certificate validation, insecure and depreciated algorithms used, insecure transport layer protocols, end-to-end encryption, etc. So these are certain tests. Similarly, I have listed down over here for insecure authentication, insufficient cryptography, insecure authorization, client code quality, code tampering, reverse engineering, and extraneous functionality as well. In the second tab, again, over here, I have listed down all the tests, but these tests are divided into two categories. One is the static analysis category, and the second one is the dynamic analysis category. So inside the static analysis category, over here, you'll be able to find all the tests that are used or that can be found inside the static analysis. For example, reverse engineering of the application code, information leakage, hard-coded credentials, misuse of app permissions, insecure version of OS installation allowed, cryptographic based storage strength, insecure backups, custom keyboard, sensitive information in application memory, etc. You can find the test name, you can find the description, you can find which tool is being used or which tool can be used in order to find this particular test. You can find the applicable platform. So this particular checklist, you can also use this checklist for Android as well. So if there are certain tests that are only related to iOS, you will be able to find these tests only related to iOS as well. So for example, sensitive functionality exposure through IPC, checking for custom URI handler, universal links, UI activity sharing, UI pasteboard, app extensions, web view, etc. These are only related to iOS. So that's what the applicable platform over here is written, iOS. The OWASP category and the result. Again, over here inside the result, you can either write yes or no. If you have found a particular vulnerability, you can write it yes. If you have not found this particular vulnerability, you can write it as no. This entire checklist you would be able to find in the description section. So you can download it from there and you can save it into your system for further reference. For dynamic analysis, again, we have mentioned all the dynamic test names over here, the description for the dynamic tests, the tools that can be used in order to perform the dynamic test, applicable platform, OWASP category, and the result. There's one more checklist which usually people follow. This is a checklist mentioned by Hacktricks. So all you have to do is you have to copy this particular link, go on to Chrome and paste this particular link. Once you paste it, you'd be able to see an iOS pen testing checklist. This checklist is one of those which users prefer or which the community prefers. So over here you have preparation wherein you can read about iOS basics, prepare your environment, read all the sections. Then you have data storage related vulnerabilities. So you can tick them off if you have found any vulnerability in plist file, core data, YAP databases, Firebase misconfigurations, Realm databases, Couchbase Lite databases, binary cookies, cache data, automatic snapshots, keychain. So if you have found all of these, you can just checklist or check all of these and then you can move forward. It also has keyboard related attacks, log related attacks, backups, application memories, broken cryptography, local authentication, sensitive functionality exposure through IPC. It has various list of sensitive information disclosure through IPC. Then you have network communications and certain miscellaneous as well. So you can follow any checklist as you like. You can also create your own checklist. Nevertheless, this particular checklist which we have created, we want to share it with you. And hence we are going to paste this particular Excel sheet inside the comment section, or inside the description section. You can download it from there. So that's it for this particular video. Thank you. Hello all, welcome back. In this video, we are going to look at an iOS pen testing mind map. So what I've done for you guys is I've created a mind map that is going to help you to understand what are the different checks which you can find in the static analysis of iOS pen testing, as well as the dynamic analysis of the iOS pen testing. With the static analysis and the dynamic analysis checks, I have also introduced the tools that are used or that will be helpful for you in order to find the static and the dynamic vulnerabilities respectively. So this is the iOS pen testing mind map which I have created. You can find this particular mind map. You can download it from the description section and you can save it for your future reference. So I've divided the part into two parts. I've divided the entire iOS pen testing into two parts, the static and the dynamic. Static, I've again created two distinctions. One is the checks. These are all the vulnerabilities that you can find inside the static analysis of iOS pen testing. And the second one is the tools. These are all the different tools that is going to help you to find these vulnerabilities. So let's first check out the checks. So here I have
I have given all the different checks which you should check out for whenever you get the hold of the IPA file. So first check which is the application ecosystem. Is the application created on React, or it's created on Flutter, or it's created maybe by the native application, native language, that is the Swift language. You can then check whether the code has been obfuscated or not. You can check for sensitive strings. Sensitive strings include client IDs, bearer tokens, API keys, passwords, authorization tokens, device UUIDs, etc. You can then check out for certain weak crypto algorithms like MD5 SHA-1. You can check out if there are non-parameterized SQL queries which are being used or not. You can check out for deserialization methods if they are used or not. You can check if WebView has been enabled inside the application or not, and if WebView has been enabled, whether JavaScript is enabled, whether JavaScript is disabled, or whether the WebView is debuggable or not, or if the WebView ignores SSL errors or not. You can then check out for custom URI handlers and secure backups, whether the application is storing certain sensitive information in logs or not, whether jailbreak detection is properly implemented or not, SSL pinning is properly implemented or not, asset detections, dangerous permissions, vulnerable third-party libraries. You can then check out the info.pls file, universal links, UI activity sharing, UI baseboard, application extensions, custom keyboards, and whether ATS has been enabled or not. These are certain tools that are going to help you out to check these static vulnerabilities. So IPA installer is going to help you out to install the IPA file. MoveSF is going to automate most of the tasks for you. Hopper, IDB, iFunbox, again, these are going to help you to check your static analysis part, whether jailbreak detection is implemented, whether there are certain sensitive information which are being stored or not, etc. Then you have OTool. OTool is basically going to help you out whether your binary has certain malicious functions or certain insecure functions that are used or not. Lib iMobile device is again a replacement of OTool. Binary cookie reader is going to help you to check the cookies. It's going to help you whether any sensitive information is being stored inside cookies or not. You have iPhone backup extractor, Xcode, code sign. So these are again certain tools which are going to help you out in order to check your static analysis checks. For the dynamic analysis checks, we have all the different checks such as analyzing logs using emulator logs, jailbreak detection bypass, SSL pinning bypass, Touch ID, Face ID bypass, checking for certain hidden functionalities, keyboard cache, whether the application is protected against screenshot taking or not, abusing URL schemes or deep links, runtime manipulation, WebView vulnerabilities such as cross-site scripting, input validation issues, access control issues, storage related issues, encryption decryption related issues, copy paste buffer, etc. So these are the common checks which you should always check out while performing the dynamic analysis of an iOS application. Now the tools that can be used are Frida, objection verb suit. These are some of the jailbreak tweaks which I have written down over here. The list is not limited to just these tweaks. You can install any tweaks to bypass jailbreak detection. On device shell, IDB, Frida code share, iPhone box, iPhone backup extractor, clutch, strings, snoopet, IPA installer, libiMobile device, Filza file manager to view all the device file contents, and you can also find other tweaks on iOS repoupdates.com. So this is a small pen testing checklist, pen testing for iOS checklist, and you can use this checklist in order to find certain common vulnerabilities that are usually found inside an iOS application. You can get this checklist from the description section. You can go and download it from there. So that's it for this particular video. Thank you. Hello everyone, welcome back. In this video, I'm going to show you certain private nuclei templates using which you can automate your static analysis finding while doing your iOS pen testing. So let's start. So here I have a couple of few templates which you can find inside the download section. You can download each and every one of this template. Some of these templates are curated from the community, while some of these templates I've created on my own. So for example, let's say the template of application permissions. So I'm going to open this particular template, and once I open this particular template, you can see that
This template is basically going to check for all the permissions that an application is using. So if an iOS application is using camera permissions, it's going to grab that and it's going to show you that it's using certain camera permissions. If the permission is being used of location, it's going to grab and it's going to show you that location permissions are being used. Similarly, I have curated templates for each and every one. So let's say ATS, if you want to check out whether ATS has been enabled by the application or not, you can simply run this nuclei template in order to check for app transport security. You can run this particular template for custom URL schemes. Similarly, you can run each and every template for Touch ID. If you want to check out if Touch ID has been enabled or not, you can run this particular template. If you want to check out whether Amazon AWS, there are certain links containing Amazon AWS or not, you can run this particular template in order to check that. If you want to find out whether Google API keys are running or not, you can run this particular template in order to check that as well. Now, how do you run this particular template, or how can you find, or how can you automate these vulnerabilities? Let's have a look. So in order to automate this vulnerabilities, all you have to do is first you have to download the IPA file. So I've downloaded over here the DBIA IPA file, the Swift IPA file. I'm going to go inside my Finder and inside the download section where I have downloaded this particular file. What I'm going to do is I'm going to right click it and I'm going to rename this file from IPA to zip. So I'm going to extract the the app file. So I'm going to use zip. I'm going to extract it. There's a new folder that is created called as payload. Inside this, I have this particular file which has been created for me. Now I'm going to go inside my terminal, and inside my terminal, I'm going to write echo and I'm going to paste this particular app over here. Okay, this is echo dvia version 2 dot app slash, I'm going to put the pipe keyword and I'm going to submit this into nuclei. So once I submit this into nuclei, I'm going to give the repository to my templates by providing -t flag, and I have stored all my templates inside nuclei templates inside a folder called as nuclei templates. Make sure your folder name is correct, otherwise nuclei is not going to use your custom created templates that you have just downloaded. Instead, Nuclei will be using the templates which are curated from its own GitHub repository. So we do not want to use that. We want to use our own custom created templates which we have downloaded. So make sure that you give the correct path over here. And once you hit enter, Nuclei is going to scan the application for each and every file for each and every template that you have mentioned. So for example, Nuclei checked out for file protections and it has checked out that this particular endpoint has certain file protections in place. It has then checked out for required device capabilities as well, which can be found inside info.plist file. Inside info.plist file, you can also have certain other required data, required device capabilities. You can see that there's a Twitter secret which has been disclosed, and this Twitter secret is what? Twitter underscore RLM identity provider username password. So in this case scenario, it is a false positive because the value of this is something else. So we are going to consider this as a false positive. However, if it was a real application, if there was a secret disclosed over here, you could have reported it as well. You can see there's an ATS, application transport security. This has been enabled by default, and hence it can be seen inside the info.plist file. You can see custom URL schemes as well, wherein this particular endpoint has certain custom URL schemes which we can check out for. You can see there's certain app permissions as well. These are the app permissions. You can find out whether the application permission is the dangerous one or not inside info.plist file. Now these are my custom created templates. What you can do is you can modify these templates as well. So for example, over here, I haven't added the extractor to extract that particular keyword and show it onto your terminal. If you want, you can extract that keyword, show it on the terminal, uh, show it on the terminal, and that is going to help you to check out whether that permission is a dangerous one or not. For the basic ones I have created, you can create your own custom ones. You can create your own advanced nuclei templates as well. If you're going to create your own advanced nuclei template, do share it with the community, do share it with me as well so that I can share it with other people in my network. So that's it for this particular video. I hope you understood how you can use Nuclei to automate your static analysis part. Thank you. Hello all, welcome back. In this video, we are going to look at iOS pen testing reports. So what I've done over here is I've created iOS pen testing report templates for each and every commonly based vulnerabilities that are found while performing an iOS pen testing. So here you can see that I've created around 5 to 6 reports. These includes dangerous permissions, insecure API functions used, jailbreak detection bypass, SSL pinning bypass, Touch ID bypass, or you can call it as Face ID bypass, weak hashing algorithms used, application transport security load enabled. Yeah, so these are 5 to 6 reports which I have created for you guys. So all you have to do is you have to copy this entire report template. You have to only replace the proof of concept over here, and the application name. If you want to add it, you can add it, or else you just have to add the proof of concept over here and you have to paste this report and send it to the application owner. So for dangerous permissions, we have written over here the summary, the OWASP category it comes under, the severity which is as low, the complexity easy, from remote external, steps to reproduce. You have to mention all the different steps which you have performed in order to reproduce this particular issue. The proof of concept is attached in the video. If you are not attaching the video, please change this to attached in the images that are given below. Impact is already mentioned. The affected path is mentioned. And any recommendations, this is mentioned. And the references are mentioned. All you have to do is just add the steps to reproduce and the proof of concept. Similarly, for insecure APIs as well, all the different insecure APIs and functions which were implemented or which are present inside the application is mentioned over here. And what are the recommendations for it is also mentioned over here. For jailbreak detection bypass as well, everything is mentioned in this particular report. All you have to do is just copy and paste it. I'll just, okay, it's jailbreak detection bypass, not root detection bypass. Similarly, for SSL pinning bypass, everything is mentioned over here. Touch ID slash Face ID bypass. Okay, it's Touch ID and Face ID bypass. Everything again over here has been present. What are the different recommendations as well? It has been present over here. Weak hashing algorithms, everything has been present. And ATS, application transport load enable, is present. Now you can customize these reports according to your needs as well. These are 6 common vulnerabilities which I thought is found every time in an iOS application. So I've just created this reports templates for you for your work to be simpler. So that's it for this particular video. I hope you understood how you can use these templates in order to report your findings. Thank you. Hello all, welcome back. In this video, I'm going to show you how you can use objection and FreeDA without jailbreaking the device. Now, as we know that in order to run objection and FreeDA, the iOS device should be jailbroken. Only then you would be able to install the FreeDA server tweak from the third-party app store. But over here, I'm going to show you a method using which, even if your device is not jailbroken, you can use FreeDA as well as objection. How do you do it? There are certain steps in performing that. First, you have to create your own code signature. Do not worry. I will be showing you how you can create your own code signature. Then you're going to patch your new application using that particular code signature, and you're going to install objection inside it. Once you install objection inside it, the patched IPA file would be created. You're going to unzip that particular IPA file, and then we are going to install that IPA file inside our iOS device. Once we install that IPA file inside our iOS device, we can successfully run objection inside a non-jailbroken iOS device. So it's the demo time, and let's check out how you can do this. Before showing you the demo, there's one disadvantage of this method. The disadvantage is that you would require a Mac OS device. Why Mac OS? Because Apple has a limitation that you can only sign IPA files through Mac machines, and you can install those IPA files into your iOS device only using Mac machines. So that's a reason you would require a Mac OS. Do not worry, I have already created a video on how you can install a Mac VM inside your Windows machine. So if you have not watched that video, do watch it and you can use that. So let's start with the demo. So over here, The first step is to find the valid security code signing. So for that, you have to go inside your Xcode and you have to create a new Xcode project. Once you start on creating a new Xcode project, you have to go inside your Xcode options, and inside the Xcode options, you have to click on settings. Once you click on settings, you have to add your Apple ID over here and make sure that you have a valid certificate over here. So as you can see in manage certificates, I have a valid signing certificate over here. How do you create this? Let's see it. So I'm going to add another account, another Apple ID. You have to click on Apple ID. You have to click on continue. I'm going to enter my second Apple ID over here. So let me quickly enter my Apple ID, and I have to enter my password as well. Once I enter my password, it's going to sign in over here. Once I sign in, I'm going to click on manage certificates. For this Apple ID as well, a certificate has been added up. You can create a new certificate by clicking on the plus button and clicking on Apple development. Remember, there's only one certificate per free account. So this is a free developer account which we are going to use. This is the free account, and hence only one certificate is available for a free account. You can get a paid developer account that is for $99 per year. However, the free account would do the job. So you can simply click on plus and add certificate, and a certificate would be added to your Apple ID. Once you click on done, I'm just going to remove this so that there's no confusion. You have to create a new application. Over here, give any product name. Now, why are we doing this? This is because we have to create a provisional profile, and a provisional profile can only be created once you first create your first application. So that is the reason we have to first create an application to get the provisional profile, and then using that provisional profile, we are going to patch our main application. So in this particular example, I've created a product called as Hello, and you can see the team is this. I'm going to click on next and I'm going to save this particular project. So you can see I'm going to save it inside desktop. Now, once I save it inside desktop, this is the default application that Xcode is going to create for us. All you have to do is click on that play button. That play button is going to run that particular project and download that particular IPA file inside our iOS device. So if I click on run, and this is my iOS device. Now, if you see, this iOS device is different from the one that we used in the previous videos. This is because this is a non-jailbroken iOS device. And once the IPA gets installed up, it's going to open up and you can see a first Hello World program being installed. Now you can simply remove this particular application as it is no longer needed. You can also close or minimize Xcode, since now what we needed was given by Xcode. We needed a provisional profile and we have got that provisional profile. Now is the actual steps which we have to perform. So open up your terminal. Once you open up your terminal, we first have to write the command that is security find identity dash p code signing dash v. And over here, you would be able to get your code signatures. Now there are two code signatures for this particular PC of mine. I request you not to use these code signatures, because if you use these code signatures, they are not going to work for you. Instead, please follow the steps and please use your own code signatures. So I'm going to use mine, that is this one. I'm going to check the second step. What is the second step? The second step is to patch the IPA file, and patch the IPA file in such a way that objection of Frida server gets installed in it. So we are going to use this particular step called as objection patch IPA. Patch IPA basically means to patch the IPA file dash dash source. This is dash dash source and this is dash dash code sign signature. And source is basically the source of the application, which application you want to patch. So we are going to patch the DVIA application, and over here is the dash dash code sign dash signature. This requires an argument that is the signature file. So we are going to copy it, the signature, and paste it over here. And once you hit enter, you can see what objection does is it automatically defines and gets the provisional file to patch the IPA, and it's working with the application to patch it such that the Frida server gets installed in it. So you can see code signing the patched IPA, which basically means that using your Apple ID, it is going to sign this particular IPA so that it gets installed into your system. Now, once that is done, what happens is a new patched IPA gets installed. So you can see DBIA Frida code signed IPA that has been installed over here. We have to unzip this particular file. So let's unzip it. So we are going to unzip this code signed IPA file. And now if you see there's a payload, which there's a folder called as payload that has been created. If you go inside this particular folder called as payload, you would be able to see that the application DVIA version 2 has been created for us. Now we have to install this particular DVIA version 2 inside our non-jailbroken iOS device. In order to do that, what we are going to do is we are going to write a command that is called as iOS deploy, and iOS deploy is going to help us to install this particular IPA file. So what is the command? The command is iOS deploy dash dash bundle, and then we have to give the bundle name. So the bundle name is nothing but the app name that is present inside the folder payload. So let me just change that. This is dash dash bundle, and we are going to give payload, and inside payload the file name that is dbia version 2, and this is the file name, and we are going to mention two flags. One is dash w and one is dash d. Dash d basically stands for that you are going to deploy this particular application in debug mode. What is debug mode? Debug mode is basically a mode which helps Apple developers to debug the particular application, and dash w basically means that you're writing that application. So once you hit enter, your file gets downloaded onto your iOS device. So if you have to wait for a couple of minutes, and then you can see that DVIA version 2 is being installed inside our iOS device. Now this terminal, you have to keep it running, because as soon as you close this terminal, our application is going to get deleted. That is what we meant by debug mode. But nevertheless, what you can do is you can open a new terminal or a new tab in a terminal, and you can simply write objection explore. Once you write objection explore, objection is going to get hooked up with your application, the application which you downloaded, and then you can run any objection commands or any Frida commands using using whatever commands you want to write. You can use those, and you can basically perform it onto your iOS application. So now we are going to perform a command on Touch ID and Face ID bypass. I'm going to start the challenge. Before that, I'm going to give the command as iOS UI biometric bypass, and I'm going to start the challenge. Okay, and as you can see, it's going to successfully check my Face ID and activate it. Now once I hit enter, and once I cover my screen, you can see OS authentication response is currently true. But if I cover my screen and if I cover my screen, it's first going to get failed, and if I hit cancel button, okay, this was the second test which we had performed. That is OS authentication response is true. But now if I cover my screen, as you can see that Face ID is not being recognized. As soon as I click, let's try to use the Face ID once again, and now also it's not being recognized, which means my screen has been covered. Now as soon as I am going to hit on the cancel button, okay, it has marked the response as true instead. So as you can see, OS authentication response was false, but now the OS authentication response was marked as true instead. And that's how we bypassed authentication mechanism. So this proves that our objection is being successfully implemented. Whatever commands we are entering into objection are being successfully executed inside a patched IPA file, that too on a non-jailbroken device. So that's it for this particular video. I hope you understood how you can install an IPA file, unpatched IPA file onto a non-jailbroken device and use objection in order to use certain commands. Thank you.
Hello everyone, welcome back. In this video, we are going to look at some iOS hacking reports. In InfoSec, it is always said that in order to learn something new, you should always read reports. So that's what we are going to do in today's video. I've found four very amazing reports from HackerOne that are related to iOS pen testing. So let's start.
This report is onto the application called as Nextcloud. There was an SSRF on the local storage of an iOS mobile. So let's check out how the user lol1ch3ng found an SSRF onto the local storage of an iOS device. So what did he exactly do? The tester uploaded the text file containing test SSRF message in order to prove SSRF attack. So inside the Nextcloud application, there was an upload functionality wherein a text file that contained the message test SSRF was uploaded. Next, the tester uploaded the common file and then manipulated the content and extension file to HTML format in order to find the application path svg slash onload equals to document.write document.location. The tester accesses that file and found the application path to use for SSRF local file disclosure. So what did the attacker do? The attacker first uploaded a txt file. After uploading the txt file, he uploaded a common file and manipulated the content and the extension of the file to HTML format. He manipulated the contents to something like svg onload document.write document.location. He then accessed the file and found that the application path can be used for SSRF local file disclosure. So the application path was vulnerable to SSRF local file disclosure. The tester uploaded the common file and then manipulated the content and the extension file to HTML format in order to view the local file via SSRF attack. So what did he do? He again uploaded a new test file, and in this particular file, he then manipulated the contents and the extension to the HTML format, just like he did before. But this time, he manipulated the HTML content not to something like document.write. Instead, he used an internal file to be disclosed. He used the file keyword over here, that is file colon slash slash. The scheme was file colon slash slash. And then he went on to a particular endpoint wherein the ssrf poc.txt file was displayed. And once he was able to grab this particular file was displayed inside an HTML format. This can be proved using the screenshots which he has given up. So in the step 1.png, he uploaded a file called as ssrfpoc.txt file. In step 2, he uploaded a new file, and in this particular file he changed the file name to path.html, and inside this particular file he uploaded svg contents. Now as you can see, the response is 201 created, which basically means that this particular file has been created over here. And step number 3, what did he do? He used the file parameter in order to find the internal path. So as you can see, this is the file scheme, and this file scheme is leaking where exactly the files are being stored. As you can see, for path.html, the file is being stored over here. So in step 4, what exactly did he do is he created a new file called as ssrfpoc.html, and this time, instead of using document.write, he used a file scheme in order to load a particular file from the internal repository. So he used a file scheme in order to load ssrfpoc.txt, and he used a width and a height of 400. You can see that this is 201 created, and when he opened the file ssrfpoc.html, he was able to view the ssrfpoc.txt file. So as you can see, the contents are test ssrf. These are the contents of ssrfpoc.txt file. So this was how this particular user was able to find an SSRF on the local storage of iOS device. The next report is about bug in iOS application which could lead to unauthorized access. This vulnerability was found in the application IRCC Cloud, and a bounty of $100 was rewarded for it. What was the vulnerability? The vulnerability was very simple. The file under the preference folder within the iOS application stores sensitive information. Which file it is? The file is com.irc cloud.irccloud.plist file. So it's a plist file that is storing some sensitive information. This file is accessible from the phone even when the phone is locked with a passcode, suggesting that the application does not secure the file using the appropriate data protection classes. So we have already looked at what are the different data protection classes. This particular application was not using those data protection classes, and we were allowed, or
even if an unauthorized user accesses the particular file, it was allowed to view for them. Once the user accesses the file, he was allowed to capture sensitive information such as session cookies. So let me open this screenshot, and over here you can see that this is the plist file wherein sensitive details are stored. So you can see sensitive details such as APNs, Crashlytics, UUID, session keys. Over here you can see there's a session key which is being stored over here. So any attacker can take this particular session key, he can replace his session with the new session key, and he can then view the account as the victim user. So this was again an unauthorized access vulnerability which was found in this particular application. The third report is about the application Twitter. Twitter iOS application fails to validate the server certificate and sends OAuth token. So failing to validate server certificate basically means that SSL pinning is not implemented properly on Twitter. So as you can see, there was a bounty of $2,100 which was given to this particular user. Now, this is not because he had found SSL pending bypass or the server certification validation did not happen properly. It was because OAuth token was being sent by Twitter. OAuth token is a sensitive token which directly gives you the access to the victim's session. So what are the steps to reproduce? Start burp or any other proxy software in transparent mode. Setting generate CA signed per host certificate, which means that CA certification of burp is used, which is not trusted on the iPhones. You have to then start ROG Wi-Fi access point on the same machine as burp. You have to redirect all the incoming HTTPS traffic on the ROG Wi-Fi access point to the transparent proxy. So over here we are using two proxies. We are transferring all the HTTPS traffic from the mobile device to the ROG Wi-Fi access point, and from the ROG Wi-Fi access point to the burp suit proxy. So there is basically two hops which is happening before the request has been intercepted by burp suit. So this was simply done onto Linux by using this particular command, that is iptables -tnat -a routing, and basically the user routed all the HTTPS traffic onto the ROG Wi-Fi access point and then to the burp suit proxy. Connect the iOS device with the Wi-Fi access point. Open Twitter app on iOS. In Burp, only the calls to api.twitter.com are visible and include sensitive information or sensitive authentication information. So as you can see, the user has given the entire request details. You can see the host is api.twitter.com. The session token has been blurred over here, obviously for obvious reasons, and then you have certain headers which are being sent to the request. Now this particular request is intercepted in Bobsuit, and this is the response to that particular request. Now this request also contained the sensitive OAuth token which was being sent, and hence the severity for this vulnerability has raised to high, that is 8.1, and hence this amount of bounty was given to this particular user. The next report is about blind stored accesses on iOS app due to unsanitized web view. As you can see, the bounty for this is also $100 which has been given to this particular user. This was again reported on Nextcloud. Hi team, I have found a blind accesses that can be executed on iOS app due to unsanitized web view. Using this issue, attacker can extract information from the victim. So what did this particular researcher did was he uploaded a malicious HTML that can be shared to the victim. And what did he do inside that malicious HTML file was he made a reverse connection. Now he was waiting for the victim to open this particular file, and once the victim opened the particular file, as you can see, it got connected to his IP address. Now once he got connected to his IP address, he could have executed any JavaScript related code, and this is a stored XSS. So this is the HTML payload which it has attached, and the recommendation for this is to disable JavaScript on web view. So once JavaScript is disabled on the web view, JavaScript related attacks such as cross-site scripting is not going to happen. So this is the POC which he has attached. The impact for this is that the attacker can extract information from victim, and which information particularly.
such as IP addresses, location, the operating system used by the victim, etc. So that's it for this particular video. I hope you understood all the 4 reports. Thank you. Hello all, welcome back. In this video, I'm going to show you the collected collection of iOS Frida scripts which I have been talking about. So remember in the dynamic analysis, while we were doing jailbreak detection bypass and SSL pinning bypass, I told you that I have created a collection of all the Frida scripts that can be used in order to bypass jailbreak detection, SSL pinning detection, and local authentication methods such as Touch ID and Face ID detection. So in this particular video, I'm going to show you where you can find all of those scripts. So I'll go on to my GitHub repo, which you can find over here. That is github.com/302found1. You can go over here and you can search for awesome Frida scripts. So once you go inside awesome Frida scripts over here, these are all the Frida scripts that I've compiled from all over the web. So I've divided this into Android and iOS. Since we are doing with the iOS pen testing, we can go inside this, that is iOS pen testing. Oh yeah, I've created 3 folders for you. This is jailbreak detection bypass, this is SSL pinning bypass, and you have something for Touch ID bypass as well. So inside jailbreak detection bypass, we currently have 6 to 7 different types of jailbreak detection bypass Frida scripts. These all are collected from different sources. You can use the scripts in order to bypass jailbreak detection. For SSL pinning bypass, we currently have 3 different SSL pinning bypass scripts. You can use this to bypass SSL pinning. For Touch ID bypass or Face ID bypass, we have 2 scripts which can be used in order to bypass Touch ID or Face ID. If you are someone who is doing Android pen testing as well, for Android pen testing, we again have created this particular repository wherein we have root detection bypass scripts. So here we have around 8 to 9 root detection bypass scripts. We have SSL bypass scripts as well, around 4 to 5 SSL pinning bypass scripts. The script where root plus SSL bypass is given. Over here, this is basically a combination of script where first it's going to bypass root detection and then it's going to bypass SSL pinning. So there are 2 scripts wherein root detection and SSL pinning both have been bypassed. We have fingerprint bypass scripts wherein we have 3 scripts for fingerprint bypass, which you can use. So I just wanted to introduce you to this particular repository, and over here you would be able to find each and every script of Frida that can be used to bypass SSL pinning, jailbreak detection, root detection, and local authentication methods such as Touch ID and Face ID detection as well. So I hope you understood this particular video. Thank you.
Over here, we officially end the course. I hope you enjoyed the course and would now be able to pen test any iOS application and squash bugs. I've created a WhatsApp community group wherein you can share your achievements and can discuss if you have any doubts. The link for the same has been provided in the next article. I've also added my social media handles so that you can reach out to me if you have any doubts. Oh, do not forget to claim your certificate as well. Thank you for being a wonderful audience. All the best and happy hunting.